Alright, boys, we are going... Listen, we're going to talk about this for like 2 minutes, okay? I'm going to tell you how both answers are correct. And then we're never going to talk about this fucking thing again, okay? I don't know what the fuck this autism picture is, but it has nothing to do with anything, okay? Okay. I'm going to explain... First of all, why is this so fucked? Does anybody have a screenshot of this? Or the original image that's not like super fucked? This is really, really simple. I promise. After I explain this, it will be very, very simple. You will understand it very simply, and you'll be like, oh, yeah, I totally get how it could be A. And then afterwards, you'll be like, oh, yeah, I totally get how it could be B. And it'll totally make sense. And I can answer your questions in chat. I've had time to go over this in my mind. I'm fucking ready to do this, okay? The only reason I want to bring this up is because somebody posted something on my subreddit saying... The correct answer to the portal question is A, okay? Can I get a better picture of this so that we can see this more clearly? Also, with the way that these discussions work, if you say something in chat like X is fucking retarded and you don't put a reason behind it, I'm probably just going to ban you for 500 hours, okay? Just as an FYI, okay? Alright, okay, we have a better quality picture. Okay, let me explain this, okay? This is the most fundamentally important part about asking the question, okay? This is the most important part about asking a question. You have two different portals, okay? Two different types of portals. So you either have portal A, I shouldn't call this, okay? The first portal type is a portal that has vectors that are identical to one another, okay? That's what, so these are one type of portal. What does that mean? That means that these portals are always facing the same direction and moving at the same speed relative to one another at all times, always, okay? So that's the first type of portal, okay? So these are always connected to one another in such a way that they are always moving in the same direction and at the same speed, okay? They have the exact same vector at all times, okay? Then you have option 2. In option 2, the portals are not tied to one another in any way, size, shape, or form, okay? They have no bearing on each other whatsoever. They can be facing any direction, anything can happen, okay? So looking at the two different types of things, in example 1, if this orange thing were to be moving down at a very fast speed, okay, a very high velocity. Let's say that it's moving down at 100 miles per hour, okay? If this orange thing is moving down at 100 miles per hour and then the cube goes through it, okay, a couple things are happening here, okay? If the orange portal has a vector facing this direction and is moving at 100 miles per hour, that means that the blue portal is also moving in that direction at 100 miles per hour, okay? So if the cube is stationary, okay, then with respect to the cube, the orange portal will fly into it and absorb it, and then the blue portal will fly away at 100 miles per hour, okay? If the orange thing moves down and continues moving, then the blue portal will be seen from the cube as flying away at 100 miles per hour. Or if we look at this picture and go by the picture, if this orange portal slams down onto the platform and stops, then what will happen is the cube will come out of the portal at 100 miles per hour, but as soon as the cube exits the portal, the blue portal will stop. So the cube will just come out of the portal and just stay right there, kind of like in A. It wouldn't plop down, I guess, unless it was going into some place with gravity or whatever, but I don't like that. I don't like that. It makes it too complicated. So this is the solution for A. That interpretation of the portals gives us answer A, where the portals are connected to one another necessarily, where they have the same vector at all times, okay? The second thing, okay, am I retarded? I really don't understand what you're saying. What do you not understand? Okay, whatever, never mind. I'll go on and explain the second thing. The second thing is, if we are to believe that these two portals are not related to one another in any way, size, shape, or form, if they're completely and totally separate, they do not share the same vector, then that means that the only possible way that these two things can communicate information to one another is that the orange portal will send to the blue portal whatever happens in respect to the orange portal. So that means that the movement of the portal is completely irrelevant. And that means that the only thing that the orange portal will see is a cube entering it at 100 miles an hour. So the blue portal will have a cube exiting it at 100 miles per hour. And that's it. That's all that matters. So that gives us solution B, okay? So the only thing that changes your solution is how these portals interact with one another. If the portals are connected by an invisible tether that maintains the vector of these portals at all times, that makes them identical, then you get solution A. But if the vectors are different on the portals and they can just be off doing whatever, then that gives you solution B, okay? So that's the correct answer to this problem. I'm 99% sure, all right? I don't know what a vector is. A vector is a speed, a velocity, and a direction is what a vector is. Destiny, why would the two portals be different? Okay, I'm sorry. Only solution B makes sense when considering Einstein's theory of relativity. No, it has nothing to do with any of that. The only reason why solution B probably makes more sense is because the picture leads us to believe that these two things, that both the portal, orange portal, and the blue portal have different vectors. That's what we're led to believe by the picture, because we see the orange portal moving down at a very quick speed, and the blue portal appears to be stationary, okay? So the correct answer based on the picture is probably B, but that you can make an argument for A, I think is how this works, okay? You take the instant where half the block is inside the portal tube, then wouldn't the half that's inside the portal tube be moving at 10? Okay, so here, we'll talk through problems, okay? So here's the thing. Let's say, wait, so what exactly are you asking? Give me hypotheticals and I can tell you what it would look like for both of these two things. When you say that the blue portal is fixed, A is thrown out the window, right? Well, wait, what? The box doesn't have any velocity, but the platform does. Oh, fuck. Oh, shit. Okay, I'm sorry. Let me explain this real fast, okay? Because I feel like a lot of people don't understand this, okay? If this is an object, A, and this is an object, B, and this object, B, flies into object A, okay? What's happening here without some type of neutral third-party observer is completely unknown. You have no idea what's moving. That all depends on your particular frame of reference, right? It feels like a lot of people in chat don't understand this, okay? If you have a platform here and you've got a ball here and the ball hits the platform at 50 miles an hour and you're floating in space, there's no possible way that either of these two observers can tell which one is moving. Is the ball coming towards me at 50 miles an hour, or am I moving towards the ball at 50 miles an hour? You cannot ever answer that question. You cannot ever answer that question. It's impossible without a third-party observer, without a third-party frame of reference telling you. And even independent frames of reference can be biased depending upon their vectors, you know? Like, what if the blue platform is moving up at exactly the same speed the orange platform is? Then that means that you are going with interpretation B, and then you would solve for that based on that. Yes, you can't answer that question, but the picture clearly shows that the portal is moving towards the box. But it doesn't matter. It doesn't matter. It doesn't matter. If you have an object on Earth, and this object is a circle, and it detects what the speed of something moving through it is, if you toss something in the air and take that device and move it really quick through it, it's gonna see the object as moving through it at a certain speed. Whether you throw it or whether you hit it through like a hoop, it can't tell. There's no possible way to know. What happens if instead of a portal there's just a hole? Does the cube start flying upwards because of the force, or does it mostly stay stationary? Wait, what are you asking? Okay, let me solve this for you. Okay, so here is one thing that a lot of people keep getting hung up on, okay? So let's say that we have our finger here, okay? We have our finger here, and then we have our thing here. Well, Destiny, when you slam this down here, your finger doesn't go flying up, right? Correct. Why doesn't my finger go flying up? Because because in here, we're assuming solution 1, where the blue portal and the orange portal are sharing the exact same vector, right? The bottom of and the top of my hand always have the same vector. That means that if I slam my hand down, when the portal enters and exits, and then I stop my hand when I hit the bottom, the vector of the orange and the blue one are the exact same, and they both stop. So even though the cube kind of comes out the top, since the orange one stops when it smashes into the bottom, the blue one also stops, meaning that the cube will just float there on the top, right? Is that... How do we always get 22 times combos? I'm asking what happens if there isn't a portal on the orange platform, but just a hole? Does the cube move any significant amount? No. Of course not, no. What is that? But I don't understand what that has to do with anything. If you believe that the vectors are shared, which is what the hole analogy implies, because a hole is the same vectors on the top and bottom, then you're implying that the tunnels are connected to each other and share the same vector at all times. Destiny, you can't use the word vector like that. What is vector? Just means a direction and a speed, no? Am I wrong? Destiny, your explanation for B is a teleportation, not a bend on space. The explanation for B is two disconnected portals that do not share the same vector. That's all that means, is that if these are totally disconnected, it could be anything, okay? Not velocity. Wait, what? Oh, shit, is velocity a speed and a... Oh, I'm sorry. I should be using velocity, not vector. I should be using velocity, not vector. My bad, my bad. Your explanation is teleportation for B, A is velocity. Sure, a type of teleportation, sure, if you want. Oh, velocity is a vector. Okay, fucking kill yourselves then. Can you explain what would happen in the second scenario if the top piston stops while the cube is halfway through? If this thing comes flying down while the cube is only halfway through and then it suddenly stops, then I imagine that the cube would be pulled through the blue thing because it's already got all of that acceleration pulling it in that direction. That would be my guess, right? Is that if the orange thing comes slamming down this cube and then stops halfway, because the cube would be thrown out here at whatever it went in at, it would just be pulled through, would be my guess. Motion requires kinetic energy, which the box doesn't have before impact. But it does. But it does. This box has kinetic energy, and if your frame of reference is the orange portal, then the box has kinetic energy. It's coming right at you. It's conservation. No. There is no conservation of anything when you're dealing with portals. We're not conserving energy, and we're not conserving energy. When you're talking about portals, that's not for this discussion. You can't possibly be. You looking at this as trying to conserve energy is not possible. It could be possible, but we would have to make this much more complicated in order to conserve energy. So what's your verdict? It must be A. So the verdict is, it just depends on how you view the portals. The example that's shown makes it seem like the portals are completely independent from one another, which would mean that the solution is B. But if we consider that the portals are entangled in such a way that their velocities are always the same, then it would be A. If the box moves into portal A at 10 meters per second and portal B is also moving forward at 10 meters per second, at what speed does the box come out relative to B? I mean, are we saying that the portals are completely connected to one another and moving? Are the portals moving at all? Like, is it coming into a stationary A at 10 meters per second, and then a moving B is moving this way at 10 meters per second? And then how does it come out? Is it thrown out at the same, like, I don't know, it depends, you have to... Jesus, fuck, when the fuck was this posted? All right, we're gonna read a 9gag post. A is way more natural. Well, kind of, but the problem with the portals is that the portals betray the conservation of anything unless they become a lot more complicated. There's too much spam in chat. I don't know. I'll read this. Hold on. So, like, again, this guy is mistaken. He doesn't understand. This means stuff with some kinetic energy. Keep that energy when they travel through the portal. The cube in this problem has 0 kinetic energy. But that's not true. How much kinetic energy does my hand have right here, right now? Okay? How much kinetic energy do I have right now in my hand? Is it 0? You can't answer that question without having a frame of reference. Because now my hand right now has 0 kinetic energy, I guess, right now on Earth. But if Earth was flying by another fucking planet at however many thousands of miles per hour we're moving, and a planet slaps by my hand and I fucking smack it, well, according to that meteor, if it was looking at my hand coming by, right, my hand would have kinetic energy. Do you understand? Kinetic energy is relative. There is no absolute frame of reference where you can say, like, oh, like, this is... Destiny, 0 relative to you, but an insane amount of kinetic energy relative to Mars. Exactly, right? And even in reference to, you have a different amount of kinetic energy in reference to somebody in an airplane, in reference to somebody walking by you, in reference to our moon, to another planet, to the sun, to another solar system, to another galaxy, right? Like, So this is already wrong off the bat. This person doesn't understand what a frame of reference is, right? This means stuff with kinetic energy. Keep that energy when they travel through the portal. The cube in this problem has 0 kinetic energy. Imagine that. So we're already off to the wrong start. Okay. Imagine, he spelled imagine wrong. This scenario: you're lying on the roof of a car which drives it into a wall at 50 kilometers an hour. If the car drives into a wall which is a tiny bit lower than the car, or let's say it has a hole as big as you right at your level, you will be catapulted over the wall / through the hole because you keep your momentum. However, in the same scenario, if the wall bangs into the car at a speed of 50 kilometers an hour, you will not be catapulted away from the car roof, but the car will probably slip out. I can't even understand the fucking analogy. Okay, hold on, let me read this again. If the car drives into a wall, which is a tiny bit lower than the... So this guy is saying if you drive a car into a wall and then you slide off the car when the car crashes, versus if the wall bangs into the car at 50 miles, you will not be catapulted away. But even that's not true. If you were on top of a car and a car hit something going 50 miles an hour, you will fly this way in respect to the collision, right? But if you were sitting on top of a car and a wall hit you at 50 miles an hour, you'll still fly away in respect to that collision. Yet just you won't be moving because now your frame of reference is the earth, right? Yeah, he's not even right in his example. He actually proves the point. The problem with all these examples is people are using the earth as a stationary like frame of reference, and then they're trying to apply the same thing. So like, let's say that you were on a rocket, on top of a rocket, and that rocket were to crash into something at 50 miles an hour, and the collision causes both of these things to stop. You will go flying away. With respect to you, the rocket and the asteroid will be flying away from you, okay? But if you were on top of a rocket, and the asteroid and the rocket was stationary, and then the asteroid hit the rocket, right? And you still slide off, you're gonna be sliding off, and the rocket and the asteroid are still going to be moving away in respect to you. The only way that you could know who's moving where is with a tertiary frame of reference right here. Like if you were on a planet and you were watching it happen. So his analogy completely doesn't even fit his thing. Can you please accept that some people don't get it? I think everybody should understand this though. It's not that complicated. I don't think it is. No? So what is your answer, A or B? The answer depends on your interpretation of the portals. If the portals are connected to one another and share the same velocity at all times, then the answer would be A. If the portals are not connected to one another and function completely independently of one another, then the answer is B. All right, you've got the floor. What am I wrong about? Slick like that. Can you not figure out TeamSpeak? Really, dog? I don't get why it would ever be B. Can you explain? Okay, let me explain why it's B, okay? If the portals function independently from one another. The reason why it's B, if the portals function independently from one another, is because as a portal, you are a portal, okay? The only thing that you can do is when something comes into you, okay, all you can see is something moving into you at some speed, and then it goes out the other end at whatever speed it entered you in. That's it. It doesn't matter if you're moving or if the object is moving. There's no possible way for you to ever make that determination. It is physically impossible without some third party telling you. So if you move into something at 30 miles an hour, it's going to spit out at 30 miles an hour. If it moves into you at 30 miles an hour, it's going to spit out at 30 miles an hour because from your frame of reference, whether you're moving towards it at 30 miles an hour or it's moving towards you at 30 miles an hour, you have no way of making that determination. It's not possible. So assuming that the two portals are completely independent, that it's 30 miles an hour in, it's 30 miles an hour out. It doesn't matter. Destiny, so the portal is creating energy? Yeah, these portals do not conserve energy. No. We're not talking about conservation of any force. It's not possible. That would be the B interpretation. Apparently Slick Like That can't make his microphone work.
Can you hear me now?
Yep.
I can't hear anything.
Testing, 1, 2. You can't hear me? It's pretty pointless arguing about this. The picture doesn't state the physics of the portal, so there really isn't a correct answer to the problem. Except there is. You can arrive at two different correct answers depending on your interpretation of the portals, I think. What? Can you hear me?
Yeah, it works now.
Okay.
Yeah.
What's up? What did I say that you disagree with?
Isn't this the picture of vacuum?
Sure, I don't think it's relevant, but sure.
No, you're saying that the Earth is moving and everything.
The Earth moves, sure. What about it?
Yeah, but in this picture, there is no Earth. That's how I see it.
Okay, so there is no Earth, sure.
There's only a portal and white space, 2 portals.
Okay.
So it can only be A, because you're saying that the box should fly away, like in B.
How did we get there?
Why did you think B? Wasn't it because the Earth moved and everything?
No, I thought B because if the portal sees a box coming into it at some speed, then it's going to spit it out the blue end at some speed.
But the box isn't moving. The speed arrow shows that the portal's moving.
How does the portal know? How is the portal moving? How does the portal know that it's moving and the box is stationary? You can't possibly know that from the portal's frame of reference.
But we are in the third party. We are the camera that's watching it from the side.
Okay, but we're not determining what the speed of the object is coming out of the blue portal. The orange and the blue portal are the things determining the speed coming out of the blue portal. So the only way... What?
The speed is showing on the...
Okay, but if the question was, if a computer was calculating what speed the cube should fly out of the blue portal at, then I would agree with you. But there's not an independent third party observing this, making the determination for how fast the cube will come out of the blue portal. The only thing making that determination is the orange portal, meaning that the only thing the orange portal can possibly go by is the speed at which the cube enters the portal. Whether the portal is moving towards the cube or the cube is moving towards the portal can never know the answer to that question. Right? Or here, my question to you then is how does the orange portal know that it's the one moving and that the cube is stationary?
Does it change if it knows or doesn't know? All we in the third party sees that the orange portal.
But we're not the ones making the determination of it coming out of the blue portal. Right?
Who is?
The portals are.
Yeah, and we can see that the orange portal is falling down.
We can, but how does the orange portal know that it's falling down and the cube isn't rising up to it?
How does it know? I don't get it.
It can't know. It can't know. You have no idea. If you're sitting in space and an object is getting larger and larger in front of you, how do you know if you're moving towards that object or if the object is moving towards you?
If we think like this, if my hand is slapping my face,
okay,
how does my hand know that it's slapping my face?
It doesn't. Your face could be slapping the hand. The only way that you know that is to look at other things like your arm and the other things around you. But in space, if your hand comes to your face and hits it at some speed, it could be your face hitting your hand or your hand hitting your face. It depends on what you look at it. If you look at it from the perspective of your hand, it's just your face hitting your hand. The only way that... Wait, what?
Those lines on top of the orange portal.
Sure.
Aren't they showing that it's going down?
Yeah, sure, but we know that because we're looking at it from our independent frame of reference. We can see that. But what I'm saying is the orange portal, which is the thing that determines what's going to happen at the blue portal, has no idea if it's moving towards the cube or if the cube is moving towards it. That's what I'm saying. Like, the orange portal can't possibly know, right? Like, we know. That's why I said if the question was, let's say a computer is watching two objects interact, how would the computer calculate the thing being thrown out of B? Then, yeah, then you could say, like, yeah, sure, well, we see that that's moving down and the cube is stationary, sure. Much the same way that we can see, well, our face is stationary and the hand is hitting the face, but in terms of, like, just looking at it from the portal's point of view, just from the orange portal, where the portal is just there, it doesn't know if the cube is being moved up towards it or if it's being moved down towards the cube. It has no way of making that determination without a third party.
Okay, this is too much for me. You win. I can. Sorry.
Okay, I love you, buddy.
Yeah, thank you.
Well, wait, hold on. Wait. Are you still here?
Yeah.
Okay.
Just said what?
Let's say that, like, you're floating in space, okay? Right? Let's say that you're floating in space, okay? Let's say that you're floating in an asteroid belt, okay? And let's say that an asteroid is floating towards you, okay?
Okay.
How could you possibly know if you were moving towards that asteroid or if the asteroid was moving towards you? There's no way for you to really know, right?
But the camera, the third party, is seeing.
Sure, a camera, now a third party could look at both those things above a planet and maybe see that the person is stationary and that the asteroid is moving towards the person, or that the person is moving towards the asteroid. However, in respect to the asteroid and the person, for those two people, it doesn't really matter, does it? Right? Like, let's say that the person is hurtling towards the asteroid at 100 miles an hour, or let's say that the asteroid is hurtling towards the person at 100 miles per hour. The collision is going to be the exact same no matter what, right? If the person is staying still, or the asteroid is staying still, but one is moving towards the other, it won't matter at all, right? Because the collision will be the exact same. Does that make sense?
Actually, it doesn't, but...
Wait.
I just don't understand them.
Okay, let's say that,
Because the way I see it is, like, we all live by the laws of physics.
Sure.
So if something happens, it doesn't care if I know it or doesn't know it. As long as it happens, it happens.
Sure, but what is happening here when the asteroid and the person collide?
Like, let's say that the portal is falling down. We can.
Well, no. I just want to focus on the asteroid and the person, okay?
Isn't it's the same thing?
Okay, yeah, but let's just talk in terms of the asteroid and the person, okay?
Okay, let's say that asteroid is flying towards me and I'm standing down.
Okay.
Standing still. And when the asteroid is hitting me, it doesn't care if it knows it's hitting me. As long as it hits me, then I'm flying towards the other way. The way it's hitting me. Do I need to know? Oh, it's hitting me, or does I hit it? Do I?
Hold on. Let me think of how to answer.
I could be wrong.
Truly, this is the dankest dungeon.
1 second. Let me.
Sup, BAE. Sorry, never mind. You'll just skip this.
Okay. Let's say that you're floating in space, okay? The problem is, I think you're getting like really hung up on whether or not a third person can tell the direction of these objects or whatever after impact, okay? So what I'm saying is, let's say if we're only looking at the collision, okay? Let's say that there is a large asteroid is moving through space at 100 miles per hour and you're floating in space stationary, okay? And the asteroid hits you. Okay? What you're going to feel is the asteroid hitting you at 100 miles per hour, right? You understand that, right?
Yeah.
Okay. So in respect to you, right, you're going to be stationary, and then the asteroid is going to hit you, and then you're going to be moving along with the asteroid, right?
Yeah.
Okay. So let's say in that same scenario, from your perspective, let's say that you are moving at 100 miles per hour towards the asteroid, okay? And then you fly into the asteroid. When you hit it, the impact will be the same, and then you will no longer be moving, right? You'll just be stuck on the asteroid. Does that make sense, right?
Yeah.
Okay. So the result is the same from your point of view, regardless of who's moving, because you don't really know who's moving, right? The only way to know that, like, oh, well, that person smacked the asteroid and then stopped versus, oh, that asteroid hit the person and is taking them along with them is a third party watching. Like, if you're just floating in space and an asteroid is hurtling towards you, you don't know if you're going towards the asteroid or if the asteroid is coming towards you, and the end result is always going to be the same. You're going to get hit by the asteroid and then just, like, carried along with it, right?
Okay.
Does that make sense, or?
There it can be two answers, but in this picture, we are the third party, so then we can see that it's only one answer.
Okay, but the thing is, I'm not... the portal, I'm looking at the portal. The things that come out of the blue portal are only being determined by the orange portal, correct?
Isn't it by everything?
What?
Like, the laws of physics.
Wait, what?
Like, if someone's throwing something in, then it will fly. But if something is... like, just put in.
Okay, but at the point of impact, it doesn't really matter. It's like what I'm trying to say. Let's say that if you hold your hand still and I push a knife down into it at 50 miles an hour and I stab it, right? That's going to be the same result as holding a knife stationary and me moving my hand down on the knife at 50 miles an hour. It's going to be the same thing no matter what. The knife is going to move through my hand at 50 miles an hour and come out the back at the exact same speed, right?
Yeah.
Regardless of whether the knife is moving or my hand is moving, it doesn't matter. Now, I can tell from a third party can look and say like, oh, well, look, like the hand moved down onto the knife or the knife moved into the hand. But in respect to the hand and the knife, you don't really know, is the hand moving into the knife or the knife moving into the hand? Well, it depends on your frame of reference. Like, are you looking from the knife or from the hand? But the result is the same. The collision is going to be interpreted the same no matter who's actually moving, right?
I still don't get it, but maybe I just, I don't know. Because for me, the portal, like, if the portal is falling down, then the cube will never fly away. Are you still
Oh, I'm sorry. Yeah, I'm assuming that the asteroid and the person have the same mass. My bad. I'm assuming that the asteroid and the person have the same mass. Because if the asteroid has more mass, it's going to carry the person. If the asteroid has less mass, it's going to fly off or whatever. Yeah. I'm assuming that they have the same mass. I'm sorry. We're in a frictionless science vacuum where everything has the same mass. Okay. I'm sorry. Go ahead.
Yeah, but I just said that I didn't get it, but maybe the chat did.
Okay.
Maybe it's too hard math.
Well, I don't think it's math. It's just understanding, I think, concepts.
How portal works.
Sure. All right.
Yeah,
okay. Well, thanks for talking to me, buddy.
Thank you.
Oh my god. Am I totally fucking wrong on understanding all of this? Other people, I don't know in chat like who's like really doesn't know anything, or if I'm like really fucking long. All right, what's up?
What's up? How's it going?
Okay, what's your background?
I don't have any physics background. I'm just a random dude.
Okay, do you think I'm wrong about something?
Yeah, I think A is literally impossible.
Okay.
So the way A can't work is that you can't have the momentum that plops it out. If there's no momentum coming through, it's not going to plop out. It's just going to go right back in. What makes B work?
Wait, what? Can you explain that?
Yeah, okay, so the orange portal goes through the cube at some high speed, right?
Okay.
So why would you have a low amount of speed with option A? How? How does that work? How do you calculate that difference?
I can tell you how. Do you want me to tell you how?
Yeah, go on.
If you assume that the orange and blue portals share the same velocity at all points in time, and that when the orange slams down onto the cube, that its velocity changes in the same way that the blue velocity changes, and that means that the cube will just float at the edge of the blue portal, and it won't move, like in B. Would be how. If the two portals are connected to one another, that would be the same thing as having a tube or just a circle or a hula hoop, slamming it down onto the ground, and then the cube would just pop out at the top, but it wouldn't fly off, obviously, because the velocity of both the blue and orange portal have changed simultaneously, connected to one another. That's the explanation for how A would work. And then it plops because there's gravity. For some fucking retarded reason, the guy made it plop out, but it would just float there.
Okay. Now, so let's assume there's some significant speed of the orange portal. Say it goes through the cube at, I don't know, 0.1 of a second, okay? So if it goes out of the blue A portal at 0.1 of a second through the cube, it needs much more speed than just enough to hop out of it. Just the speed, nothing, I'm not talking velocity, nothing else.
Yeah, I think the confusing part here is you're trying to add like gravity on, because you're saying it would fall right back into the portal, right?
No, not at all. No gravity.
Oh, wait, okay, can you explain that one more time?
If the orange portal goes from the start of the cube to the end of the cube in 0.1 of a second,
okay,
it's gonna need that much speed to exit out of the blue portal.
Okay.
0.1 of a second from the start to the end of the cube.
Sure.
If the cube exits from the blue portal in 0.1 of a second, it's not gonna go into scenario A. It's going to have much more speed. Now, what makes it...
Here, I understand what you're saying. Just a real quick analogy.
Sure.
Let's say that you're standing... This is what this analogy is saying for A. You're standing on the back of a truck, okay?
Yeah.
On the back of that truck, you're a pitcher. You're going to pitch a fastball at 90 miles an hour off the back of that truck. What this example is saying is the truck, you are going to throw a ball at 90 miles an hour off the back of a truck going 90 miles an hour. At the same time it collides into a wall, the ball will essentially just stand still. Right? And it'll be seen from the truck's frame of reference. The back of the truck will just see the ball just barely move and stand still, is what, right?
Yeah, that's right.
Yeah. So that's the A argument. It wouldn't fall back into it. It would just be still right there, right?
No, not really. So where does the cube go? How long does it take for the... So we know, suppose, 0.1 of a second for the cube to go through the orange portal. How long does it take the cube to exit from the A blue portal? 0.1 of a second?
Well, we're assuming that it's an infinitely small amount of space between the portals, that it's just a smooth, continuous transition from one to the other.
Yeah. Shit. Sorry.
No problem. So we're just assuming that it moves right through. Yeah. Okay. So.
Okay. So if it's a smooth, but even then, okay. So that's one of my points. I need to think about it. What you said. So another point I've got is that what supports option B is that if you add resistance. So right now, from an outer point of view, from an outer scope, I admit that that might be an error. But so the cube is stationary to us, to the observer. Okay. Going out of option B, the portal B, the cube is no longer stationary. Now you could imply added resistance as the orange portal goes through the cube. Resistance would be enough to eject it from portal B.
What does resistance mean?
So resistance, so you've got the speed of the orange portal slamming down onto the cube, right?
Okay.
That could, as it goes through matter, the cube or anything else, it would potentially face resistance that is translated then to the force ejecting the matter, the cube, out of the portal.
Well, I don't think we have any resistance implied in this example, though.
We could, though. I mean, that's something that supports option B.
Well, we could also say that they're on a supermassive black hole and that everything is pulled down, so it's always going to be A, because nothing can escape the gravity. But I mean, that wouldn't really be...
Well, if it's a supermassive black hole, then we don't really care because there's nothing in there.
Sure, but I don't think that, like, if you start adding things like resistance, then I mean, you could say things like, well, the friction of the portal, since portals have high friction, it would never come out. Like, I mean... Right, I don't think the resistance is implied at all in any part of this example. I don't think.
I mean, yeah, still, as long as you assume the cube has some dimensions that don't change, be it, being squeezed or stretched or anything like that, I just don't see A working. Like, even if with that example of, throwing the ball off the back of the truck, the cube has dimensions that they need to stay somewhere.
Yeah, but the idea is that passing through the portal is like passing through a window. You just pass through it. You just go from point A to point B and you just walk through it.
Is it though? Don't the portals work more like, flat surfaces more so than anything else?
Yeah, but there's no resistance. You just walk from one end to the next. There is no resistance or anything pushing back against you.
Okay. I'll think about it and I'll let you know.
Okay, sure thing.
Okay, take care.
All right.
Bye.
Okay. I'm sorry. Okay, listen. People that are asking questions about the energy, okay? Where is this energy coming from? When you say, where is the energy coming from, you are implying that energy is conserved. That cannot be true ever unless we make the examples have to be much, much, much more complicated, and you have to start making a lot of like really difficult assumptions that put this way, way, way more harder. Let me give you a quick example. If you have a portal here and you've got a portal here, and there is gravitational things or gravity. I should just say gravity. Gravity is impacting these two portals. Then entering this portal and coming out of this portal is violating conservation of energy. Do you understand that? Like, because now you have created potential energy from the cube here, right? The only possible way that this could work is if the gravity propagated through the portal. I don't know. Things would become very, 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 very complicated. Very, very complicated. We are not conserving energy through these portals because we're moving these through different fields of energy. I don't know how you describe it. This is too complicated for me. But you're not conserving energy with these portals, right? Because you can make things, even in the portal game, energy is not conserved, right? You've got a portal up here, that's creating potential energy out of nothing. I'm sorry, the portal down here. When you drop a cube, it falls continuously over and over and over and over and over again. This is a perpetual energy machine. And that's because the reason why this is a perpetual energy machine that's creating perpetual energy is because you are creating energy by teleporting it up here and creating more potential energy when the gravity is acting upon these two things, right? I'm sorry. So the only reason I'm saying this is because people keep bringing up conservation of energy or whatever, and it's not relevant to the question. These portals are not conserving energy at all. Do you understand? Wow, nice fucking picture, dog. Does Destiny think it's A? It's either A or B, depending on your interpretation of how the portals connect to each other. It's like dropping a hula hoop over an object. It does not make the object launch. Listen, I've used this example. If you drop a hula hoop onto an object, what you are saying is that the velocity of portal B, which is the bottom of the hula hoop, and the velocity of portal A, which is the top of the hula hoop, are the same. If you drop the hula hoop and then it hits the ground, the reason why the object doesn't come flying out the other end is because the velocity of your orange portal and your blue portal have changed at the same time. So you've got a cube here, the portal goes through here and stops. The portal will, the cube will come out of the portal, but the portal is moving at 10 miles per hour this way. The cube comes out at 10 miles an hour, but then the portal stops instantly.
IDK_.
So it sits there, okay? If you believe that the portals are connected and share the same velocity at all times, that means that the cube, once it comes out, if the orange thing is slamming into the ground and stopping, that the cube will just stop and sit there, okay? That's what I'm saying. Holy shit. That's the interpretation for solution A. However, the problem, the A portal will conserve the energy of the cube entering it. Well, conservation of energy is totally different. We're not talking about, nothing is conserved. We're not talking about any conservations of any bullshit, okay? Imagine you're standing in front of the blue portal looking in. What do you see? You would see a platform launching a block towards you. Sure. Oh no.
Hey buddy, what's up?
What's up?
So the hula hoop example.
Yes.
Here's why it's wrong. When you drop the hula hoop,
okay.
You say the velocity changes for both of them.
For the hula hoop's top and bottom, which are representative of the blue and orange portal, yes.
Correct. So if the orange portal goes through the cube at 100 miles an hour,
yes,
the blue one does as well until it goes through.
Correct.
In which case, for A to follow this, you'd need to instantly stop the cube to reduce its speed, because the hula hoop then stops, right? It hits the ground. It completes the transition.
Okay, but the problem is, if the orange portal is moving through space at 100 miles per hour and the cube is stationary, as it is in this example, the blue portal is also moving through space in the same direction, okay, with the same
Correct.
velocity, 100 miles an hour. They're both moving through space, okay, at the same thing. If
Correct.
the orange one swallows the cube up and then hits something and stops, okay, the cube is going to come out of that blue portal at 100 miles an hour. The blue portal is moving at the other direction at 100 miles an hour. So when it stops, then it zeroes out, and the cube will just be floating there.
So what you're saying, so in order for this to be plausible, to be true, you'd need the cube to somehow magically fucking stop right as it exits the blue portal A.
For A to be true?
For A to be true, yeah.
No,
it goes through at 100 miles an hour.
If you're on the back of a truck and you throw a baseball at 90 miles an hour and the truck is moving at 90 miles an hour, does the baseball magically stop in the air?
No, it just...
Yeah, it does. It just stops. It just sits there. Even though it comes out...
It accelerates to a zero from an outer point of view, yeah.
Sure, yeah.
Decelerates.
Yeah, so that's what's going... Well, yeah, so that's what's going on here. If the portal itself is running through, if it's going in some direction at 100 miles an hour, then that means that if the cube enters the portal on one end at 100 miles an hour, but then the portal suddenly stops, it's going to come out, but the cube will stay there.
But it's different. The truck continues. It's just the ball that stops. So you've got the transition.
Well, but not if the truck stops. Okay, hold on, no, we're really close, okay? What you're talking about, the truck continues and the ball stops, correct? What you're saying is correct. That if you throw the fastball at the back of the truck, the ball will be moving away at 90 miles an hour, correct? And that would be true in our example if the orange portal continued moving down. If the orange portal continued, but it doesn't. So the fact that the portal slams to a stop as soon as the cube comes out would be like throwing a 90-mile-per-hour fastball off the back of a 90-mile-per-hour moving truck, and then the truck slams and stops immediately. Instantaneously, the truck stops right after you throw the ball. The ball will just float there. It'll hang there. So like, let's say that you've got an indestructible wall, and the truck is driving at 90 miles an hour into that wall, and you've got a pitcher on the back, and he throws the ball. Then the truck will smash into the wall at 90 miles an hour. The pitcher will throw the ball, and all you'll see is the ball will just hang there, floating in front of the wall, as the truck smashes into the wall, right?
Yeah.
Yeah.
But the ball doesn't magically stop either. So your motion, the pitcher's motion, essentially in an outer scope, stops the ball from moving with the truck.
Correct.
You've got that motion, that pitcher. You don't have a pitcher here. You don't have that activity stopping the ball in motion. In order for A to work, you got the transition at 100 miles an hour, and then as the transition completes, you're trying to find a force. You'd need to find a force that stops the ball, stops the cube. You don't have it.
But the cube is never really moving, though. That's the point.
So what you're implying is that portals are not surfaces; they're more like tunnels, tubes.
Well, yeah, it's just like stepping from one universe into.
Okay.
There's no resistance.
Okay, that's fine. That's fine. That's like a window. Yeah, as per your example.
Like I guess, like if you look at, okay, hold on. Like I got my little paint up. What I'm saying is that if you have a circle here and a circle here, and you've got a cube here, that as you move the circle down the cube, it will appear out of here. And that if you move this circle down at 100 miles an hour, the cube will fly out of here at 100 miles an hour. But if you move the circle to the bottom of the cube and then stop it, then the cube will come out of this circle, and then the circle will instantly stop because the other one stopped. This is assuming that the portals are tethered together through some imaginary force, okay?
Okay, that's fine. The stream delay is not helping, but if you go back to the... hold on, let me just open the image. Holy shit. Okay, so following that, there would be essentially no external force, no real speed attached to the cube going through these portals in this case. Because we're looking at them as a window, as a kind of as if there was a tunnel instead of a surface there.
Sure, yeah.
So in that case, given even looking at the angle of the blue portal in option A, it wouldn't hop out of it. It wouldn't fall off. It would just fall straight back in.
Well, no, because we're imagining there's no gravity. The plop is really bad, okay? Technically, A is never happening in this example because the plop shouldn't happen, but the cube will just sit and float on the edge of the circle. It won't plop out, but it'll just float and you'll sit there at the very top of the circle. It'll just float there, is what I'm saying.
Yeah. If that's the case, then I suppose A can work, but it's really a stretch, isn't it?
Well, the only reason why I don't believe A is a valid interpretation is because the picture shows us that orange is moving and B is stationary, which implies that the two portals are disconnected, which would lead there to be the B answer, most likely, looking at this particular picture. Is what I'm saying.
Plus, there's like logic, like you can actually follow up with B, as I previously said, with a force that there can be resistance as you go through matter, and that resistance can be translated to the difference in velocity of portals, orange and blue.
But we're not. But resistance is a force, so we're not really just like friction or gravity. We're not really considering those things here.
Yeah, but in theory, like this is a way it could work more so than A, at least in my opinion.
Yeah, maybe, sure, I guess. I don't like resistance and all these things are things that I don't think are relevant to the problem. I mean,
so resistance in this case would be used like to propel the cube out of B, because conservation of energy and all that bullshit. From an outer scope, everything needs to match.
Well,
and
but
the only way for things to match is B using kind of a imagine a magnetic resistance on the orange portal as it goes through matter, just used to propel it out of B. Therefore, the energy spent on the orange portal swallowing shit can be used to shoot it out of B. If that makes sense.
Kind of, sure.
Okay.
Okay.
Yeah, so that's all I got. That's why I think B has, some backing, some validity to it, whereas A is completely bullshit. But,
okay.
Yeah.
Okay, alright. I'm gonna watch your video, okay? Alright.
Awesome. Take care. Bye.
Hello. I don't know how long this has been floating around, but...
Am I gonna get triggered as fuck? This has 4,700 fucking views.
I saw this on Reddit a while ago, and I have been obsessing over it for a few reasons. One, I'm a huge fan of Portal, obviously. Two, I've always had a bit of a fascination with physics, especially theoretical physics. And 3, a massive majority of the folks in that thread on Reddit argued for outcome A, and I disagree. I expect B, and I tend to get a little obsessive about these things. So, unfortunately, because portals are science fiction, and the game does not allow moving portals, we can't test this. We just have to think about it and try and figure it out. This also means I'm reduced to animating, which admittedly doesn't prove anything, as I could animate anything to happen. My hope is that with this visual aid, that your intuition will kick in and say, you know, that animation looks a little more reasonable than the other animation. So, first of all, I think the main reason people went with A is because they simplified it and compared it to something that can be seen.
Oh my god, I just remembered you can speed up fucking videos. Hallelujah. Okay, okay. I'm sorry, let me go back. I'm fucking falling asleep.
Admittedly, it doesn't prove anything, as I could animate anything to happen. My hope is that with this visual aid, that your intuition will kick in and say, you know, that animation looks a little more reasonable.
Intuition? We're going to talk about intuition in a problem that is entirely unintuitive. Okay.
Animation. So, first of all, I think the main reason people went with A is because they simplified it and compared it to something that can be seen in reality. Falling at a ceiling with a hole in it. Once the ceiling hits the floor, it stops. You don't go flying through the air. You don't gain momentum because the roof fell around you. That's all well and good, but these are portals, not holes. A hole is one thing. If the hole is moving, the other end of the hole moves with it.
Exactly, which is what gives us solution A, which is what I was talking about. The solution A only assumes if the back of the hole moves with the front of the hole, right? If the velocity of portal A and portal B are connected to one another through some tether. That's the solution to A, all right? That's the solution A. So I'm going to guess that he's going to say that I don't believe these things are connected. And that's
portals
solution
don't necessarily do that. One can move independently of the other. One can move while the other is stationary. This is what makes the problem a challenge. Let's find some common ground first. I'm turning off gravity for the moment and letting this cube hang motionless in midair. There are no forces acting upon it. And the pistons are moving at the exact same speed in opposite directions. If the pistons are matching each other's speed, they may as well be on stationary surfaces. Any effect their motion might have on the cube would be negated. Therefore, the cube with no forces acting upon it must remain at rest.
This is a good animation for solution A. This is a great animation for solution A, guys. Everyone should be able to understand this animation.
Directions. If the pistons are matching each other's speed, they may as well be on stationary surfaces. Any effect their motion might have on the cube would be negated. Therefore, the cube with no forces acting upon it must remain at rest. However, the cube did go through the portal, so something was moving. It wasn't the cube didn't move. The portals moved. The cube did not move through space. Space moved around the cube.
However, with the same thing, if the blue portal does not move, and you assume that these things can have different velocities, and the orange portal moves, then the blue cube will necessarily fly out, or the cube will necessarily fly out of the blue portal, which is probably what he's going to go on to say.
Let's take another look at the problem. One portal is moving while the other is stationary. If it made sense for the cube to remain still in the previous example, surely something different should happen here when the portals do not have synchronized movement. Flip gravity back on. This is what I expect to happen. The piston does need to go fast enough to overcome the force of gravity to launch the cube into the air. However, while it's moving slowly, note that the cube has to move at all to emerge from the blue portal. That should be the first indication that the cube should, in a sense, gain momentum. But it started from a stop, you say. It doesn't have any momentum, you say. Well, on the left side, sure, the cube is motionless. But the cube and the orange portal are moving in relation to one another. On the left, the orange portal is moving. On the right, the blue portal is stationary. That speed would stop if it were just a hole like this. But these are portals, not holes. And if you're thinking, but the orange portal stops immediately after it passes the cube, so the blue portal has to stop too. Again,
no, because they're not tied to one another.
Not portals. Portals move independently of one another. From the cube's perspective, the orange portal moves past it and then comes to a stop. Why did it stop? The piston. A force was acted upon the orange portal. The blue portal, however, has no reason to stop. It is actually stationary, but not to the cube it isn't. To the cube, the blue portal is sailing on by. The cube is moving through it after all, so there must be some movement in relation to one another. But no force.
This is 100% right. This is my explanation. You said I was wrong earlier. What? That guy was right? That guy wasn't giving this explanation. What are you talking about? This is exactly what I started. I started the stream off exactly saying these two things.
Suddenly acts upon the cube or the blue portal, so they just keep on continuing on their merry ways. Let's turn off gravity again. This is an extension of what would happen under the laws of answer A. The orange portal passes over the cube. The cube pops out of the blue portal, but then immediately stops, even though there are no forces acting on it. The cube was not initially moving, but the orange portal passed over its space, moved around the cube, and that relationship should be maintained, but in this example...
And this is what I was saying with the truck analogy. If you throw the ball off the truck can continue to move, but the ball will remain stationary, right? Like,
And just in case you're thinking, this extension is just silly, it's not even like the original problem at all. In the original problem, the orange portal stops, and when the orange portal stops, the cube stops too. This idea seems even stranger to me. Here's an extension of that idea. Gravity is still off, so there are no outside forces affecting the cube. If the orange portal's movement somehow has a bearing on the cube's movement, or even the blue portal's movement, long after the cube has already passed through it, then this example should look totally natural to you. This doesn't really look right to me, though. It is following the rules, though. The cube moves in exact relation to the orange portal. It goes up as the orange goes down, and it stops when the orange stops. And with that, I will leave you with my solution, answer B. I hope I explained this well. I don't mean to be an authority on it, but I thought about it for quite a while, and I'm pretty damn convinced about it, so... But questions are welcome. I'll see you later.
Okay, so your description wasn't the same. My description was the exact same. So let me go back to the very beginning, and I will describe it one more time. The solution to this problem was either A or B, depending upon whether or not you believe the portals are sharing the same velocity. If the portals have the same velocity to one another, then the cube will come out and it will sit there, because the orange thing will stop and the blue thing will stop, and after the cube goes through, it will just be sitting there. If you believe that the portals do not have to share any kind of common velocity and they can just float and do whatever, then when the cube enters at X fucking velocity or X whatever into the fucking portal, it will fly out in the exact opposite way or whatever, in the exact same way as it enters the orange, it will fly out of the blue, if you believe that they're not tied to one another. That's exactly what I said at the beginning of the stream, okay? This video just said exactly the same thing, and he had nice and easy to follow animations to fucking prove it. Fucking kill yourselves. Everybody in chat that disagrees with me can literally kill yourselves, okay? You were describing motion between the box and the orange portal, but it's the motion relative to each... Never mind, I'm not gonna read any of your shit. Never mind, you're fucking retarded. I'm done, I'm good. All right.
Option C, kill yourself.
Call me on Skype, IP me if you don't like my answer. Oh my god. What do you want, TPX? I don't even have your fucking Skype name. On my phone, in class right now. I don't even... What? If you're in class, how can we talk? Should you really permaban those people just for being wrong? I don't permaban anybody if they're wrong. I permaban people when they call me retarded and they don't offer any kind of opposite or contrary explanation. Then you get fucking banned for being a fucking retarded.
Truly, this is the dankest dungeon.
Alright, so if the first portal falls at full speed, the cube will fly out. But at what reduced speed will it have to go for the cube to only plop off 33% or 25%?
Oh, I gotta get baited. If we assume B, what happens when the orange portal stops after eating half the cube? Then you would assume that the cube would be pulled through the portal because of the momentum that it would have on the other side, right? If the orange portal slams down halfway, then you would assume that as it starts coming out of B, that the cube would pull itself through, would be the assumption. Yo, Reddit thread creator here, wanna Skype. Should I Skype with the Reddit thread creator? Oh no. Destiny, portals don't have velocity, only the pillar does, and it isn't... I'm gonna kill myself. Why won't you call me? I'm not gonna call you if you're in class, TBO. I'm not gonna call your fucking phone number. I don't even know if I can do that on Skype. I'm not gonna pay for fucking Skype credits. The fuck, dog? Imagine an empty frame passing through your arm. Your arm won't fly off. I've already explained why that works. I've already explained how the frame and hula hoop things work and gives you answer A. Do I really have to explain that again? Oh my fucking god, if I was a high school teacher, I would fucking kill myself. Do I really have to give that same explanation one more time? Destiny, that is nothing to laugh at. That is the answer. The portal is moving. Nothing is moving. Nothing in life is moving, ever. You're never moving. Do you understand? Do you understand that you're never moving? This right here, when I drop this, I'm not actually dropping it. It's stationary. The entire planet is moving up towards it, right? It all depends on your frame of reference. What do you mean?
Fucking kill me, kill me, kill me, kill me, please don't get baited, Dad. We just want our rest memes. Let's be real, it would be me paying for Skype credits. Here you go.
I don't know how to call people on Skype, dog. I told the one dude that made the Reddit thread to add me on Skype, but he hasn't added me. If nothing is ever moving, velocity can't... No, I'm just saying that you can't say that, like, this X isn't moving. Everything is moving. Always.
Destiny,
like,
what
everything,
the fuck are
depending
you
on
talking
what...
about? How else would I hatch my Pokemon eggs if I wasn't moving?
Everything is moving, always, depending upon what your frame of reference is.
Truly, this is the dankest dungeon.
I haven't been paying attention, but the bottom platform would halt all momentum when the top platform hits it. Therefore, the box would only plop out. Please just play a game. These faggots are giving me AIDS. Even Rust would be fine. No tears.
I've already explained this. The reason why you wouldn't go, the reason why you don't go flying out of the door is because the entrance and the exit of the door have the exact same velocity. Much the same way that if you believe that the orange and blue portals are moving in tandem with one another with the exact same velocity, that the cube will just sit there and stay on the other side. It wouldn't fly out. That's the solution for interpretation A. Or the interpretation for solution A, I should say. Oh God. Do we want to watch this 27-minute? I don't know, dude. I feel like I would get in trouble from Twitch if we watch this whole thing.
We are used to seeing things from a particular point of view. That is, from a particular frame of reference. And things look different to us under different circumstances. At the moment, things look...
You look peculiar. You're upside down.
No, you're the one that's upside down.
No, you're upside down.
No, I'm not.
Oh, this is just like what I was saying earlier. How can they know who's upside down? Much the same way for the portals, you're flying at me at 50 miles an hour. No, you're flying at me at 50 miles an hour. If these portals are totally disconnected, there's no way to know who's coming at who. It's not possible. Much the same way with the guy that said your hand slapping your face. Well, you know your hand is moving towards your face. Your hand doesn't know that. Your hand, the face is hitting the hand instead of the hand hitting the face. There's no way for you to know for either object. You have to have a third party looking at it from a different perspective to actually determine who's where. I really want to watch this whole video. Fuck, I feel like we would get in trouble for watching this whole video. It's 28 minutes long. I really want to watch this video.
Used to seeing things from a particular...
Ah, fuck.
Upside down. You better come into my frame of reference now. My frame.
Your hand does know because you can feel your hand moving based on the air you're displacing. But you don't know that. What if the air is moving with your face towards your hand? Dude, Bug, how do you not understand this? What the fuck? You can't know.
Are you making a point, Destiny? Are you trying to make me reconsider my hate for Rust? I could definitely...
Fuck off. Dunebug, if you close your eyes and air is moving through your face, how do you know that you're not in a car driving with your head sticking out the window, or if there's a fan right in front of you blowing air? You can't possibly know. Just because you can feel air moving through your hand doesn't mean you know your hand is moving through space or something else. The air and the person's head could both be coming out. He could be blowing and then hitting, like, you can't know. What kind of fucking autism is that? It's not autism, Dunebug. How can you not understand this? Dunebug, I feel like this has been explained 50 million times. We're not even talking about subjective anything right now. If your hand and your face contact one another, I need to give flares for people with degrees. If your hand is here and your face is here and they hit each other, you have neither one of these know who is coming at who. You have to have an independent third observer watching to actually be able to determine who's moving through space. The hand sees the face hitting it and the face sees the hand hitting it. That's all they know. They can't possibly determine which one is moving through space relative to a third party to hit the other person. What? Right? This is like... I want to watch the video, but we can't. I would get him. Are there any Twitch cups here? That Mr. Fit guy will show up and shout at me. We can't watch this whole video. I wish we could though. Is this like public domain? Do you think? Can it be public domain? Wow. We're watching for educational purposes.
Truly, this is the dankest dungeon.
No fuck you, Destiny. Do you want to deal with $1,000 worth of charged back donations? Didn't think so.
Is the Earth spinning or is the universe spinning around the Earth? You don't, it depends on who you ask. Remember the whole beginning of the astronomy and shit? That's what we thought. We thought that the Earth was the center of the universe or whatever, right? Based on our particular frame of reference. That's how everything looked like, right? Obviously, we determined different things with calculations later on, but like it really depends on who you ask.
If I'm face fucking right the bare arms mom and I come on her face, is it the cum moving or is everything else moving? Answer, it must be the cum because right the bare arms will never move out of his mom's house. Peppy.
Dude, I can't. Okay. Look, so would you come flying out of the blue portal when you pass through the orange portal on the moving train? Is this person standing on the train or is he standing in front of an oncoming train?
Degree in autism requesting my flare.
Never mind, I don't want to do it. I mean, like, I can answer this question with both portal interpretations, depending on how you interpret it. It's not that difficult.
But destiny, if I go through the door, regardless of the physics, will my noose still stay on and give me the sweet embrace of death?
Okay, if this guy is standing in front of the train, okay, then the idea, and if these two portals share the exact same velocity as they would if you had interpretation A, okay?
Did I just send $5 or did you take my $5? I have no frame of reference anymore.
Listen, if you have interpretation A, where these portals are intertwined with one another, that means that as orange moves towards you at 300 miles an hour, and the blue portal moves, this blue portal is also moving on the ground.
If I slapped your face and there were no witnesses, could I say your face assaulted me?
That means that this blue portal should be moving along the ground at 300 miles an hour, okay? That means that the orange portal would pass through you, and then you would see the blue portal passing away from you at 300 miles an hour as soon as you went through. That's how that interpretation A would work. You would come through, the train would whoosh, run into you, and you would go through the portal, and then you would see the blue portal racing behind you at 300 miles an hour, and it would be gone. If you would have interpretation B, which is what it seems like you're making here, because you're saying the blue portal's not moving, that means that the orange portal will hit you at 300 miles an hour, and you will come flying out of this portal at 300 miles an hour. That would be interpretation B, okay? Right? Both of these can make sense depending on how your interpretation of portals work. I'm firmly option B. Well, it just depends on it depends on how you assume the portals are entangled with one another. It's never A. No, it doesn't matter.
Nigga PLS.
So it's B. I personally, if I was looking at this and it was a life or death question, my answer would be B, because from the drawing of this picture, it appears as though these portals are not entangled with one another in a way that they have the same velocity. Meaning, the way that I would guess that these would work is whenever an object enters this portal orange, whenever an object enters it, it comes out of portal blue with the exact same properties as it entered it. And whatever it entered it as is how it's going to come out of blue. So in this particular perspective here, the cube is entering it at whatever speed this portal is being thrown down onto it, which is causing it to come out of B at whatever speed it entered the orange portal at. So I would go by B based on how this picture works, but there is an explanation for A to make sense as well. But the picture isn't drawn to make it look like A makes sense. That's there, all right? Let's do a final poll and we'll just see where we all are, okay? Here we go, okay? Which one, based on the picture, is correct? A is the only right answer. B is the only right answer. A, but I could see B being correct. B, but I could see B being correct. Or I could see A being correct. Oh my god, this fucking split. So B is, or this is where I sit on this one that's at 29%. Some people think A because they're literally retarded. So whoever voted for 1 is actually literally retarded. Whoever's voting for 2 is okay, I guess. And then 3 is probably retarded. And then 4 is the master race. That's what we got. Dyson, are you gonna come on Skype or not? What the fuck? Yeah, I like that. I like that. I like that. I like that, Laetus. I like that answer. Imagine, so let me tell you why the people that think it can only be A are actually retarded. Okay? Are we ready? Did my thing actually go through? Did we listen to my explanation, or I accidentally hit my Ethernet cord out of my computer, okay? Let me tell you why people in A are retarded, okay? This is what's going on in A, okay? In A, you are standing still, okay? And you are looking at a portal. You're looking at a portal. And in this portal, we see a cube that's on a platform larger than the portal. We see a cube, and we know that it's on a really big platform. And this cube is rushing towards the portal. Holy shit, at 400 miles an hour. The cube is rushing. We're sitting in the room, and we look at this portal on the wall, and the cube is rushing towards the portal at 400 miles an hour. Holy shit. And then what's gonna happen is, as soon as the cube passes the portal, it's just gonna fall to the ground. That's what people think is happening in example A. And that is why the people that think it can only be A are actually fucking retarded. That's what's happening. Do you understand? We're sitting in a room, we're staring, we're locked. James Bond, some villain has locked us, okay? And we're staring into portal B. We're in example B, and we're staring inside. Or no, I'm sorry, we're in A, and we're staring inside. And in the portal, we see the cube rushing towards us at 300 miles an hour, and then finally it comes through the portal.
You
and
have
then it just
angered
plops
God.
down. That's what's happening.
Stop with this science nonsense, or else you'll get us all thrown in hell.
That's what's happening. The cube is not moving, you idiot. The portal is moving. How stupid are you? Gut69. Now, I know your name implies that you're probably dumber than a basket of fucking dicks, okay? But, like, I don't even know why we're doing this. I'm actually done. I want to watch this whole video. I think it's worth, based on the discussions that I've had with my chat today, I almost think that it is worth getting banned from Twitch to watch this 27-minute and 25-second video on frames of reference. I really want to do it. I really fucking want to watch this video. I need to get an admin. Hold on. I have to find an admin to see if this is okay. Holy fucking shit. Hassan, where are you? Nope, we can't watch it. We can't watch it, boys. Listen, maybe I should cut my stream for 30 minutes, and then you guys could all go and watch this fucking video. Destiny, see it from the other side. You're standing under the orange portal. It's coming down on you. You would just fall through when you go through it, right? That's not true, though! Let's say you're looking at the other side, and you're staring in, and all you see is you hurtling towards the surface at 300 miles an hour, and the portal is coming down, you're staring through, and it's coming, and you see that surface, and you're moving towards that 300 miles an hour, and then finally it comes through, and then you just fall out. How? What? How does that make sense? It doesn't make sense if you're looking at either portal. It doesn't make sense no matter where you're looking at. So you just magically have 300 miles per hour velocity? It's not magic! What? The bottom platform is stationary. It doesn't matter if you're stationary. The thing that you're looking at is moving towards you, and you're moving towards it depending on what your frame of reference is. How is this so hard to understand? We're done. I'm actually done. All right, we're moving on from this. This is a conversation that maybe in fucking 6 years, we'll be able to come back and revisit this topic. My mind has been blown. Every time I have a conversation with people, I feel like it just reaffirms my belief that the average person is fucking retarded. It's actually unbelievable. This is how shit like Trump and Brexit happen. It's because the average fucking person...
But Destiny, if you get banned, who will I get my Rust memes from? Beachills? Use.
It's actually unbelievable.
At the traffic circle, take the third exit onto Chesterview Avenue. Traffic is normal and you should arrive to your destination by 7:30. Sippy sippy, my nigga. Based God over Russell. Based God, no tears.
Destiny, if you're standing on a platform and a normal door is coming down on you, you're going to fly up when you pass through it? I've just told you 1,000,000 times. I've explained how that alternative makes sense if you believe in option A. But the difference there that you're not considering, no, kill yourself. Who said that? If you're standing still and a door comes down on you, you don't go flying out the other end, right? That's correct. But that's because portal A and portal B are moving together, are moving at the same fucking velocity. How can you not understand that? You're saying that, and then you're saying that the entrance to a door and the exit of the door are in two totally different parts and facing totally different ways and have totally different speeds and velocities, but that's not how fucking doors work. Why are you trying to use a door as an example? If you slam a door down on somebody, then the entrance and the exit of the portal are always sharing the exact same velocity. That vector will never, ever, ever change. The exit and the entrance are the same. So when you slam the door down on somebody and stop it, the reason why they don't fly up in respect to the door is because you're stopping both portals at the exact exact same time. The only way for that to be a valid analogy is if both portal orange and portal blue are moving through space exactly in the same velocity at all times. You cannot have portal orange move, portal be stationary, and then use
Chat
that as your
spam,
example.
I agree with you, Destiny.
What the fuck?
You're right, so we can move on, please.
How is this so hard to understand? This is actually unbelievable.
Truly, this is the dankest dungeon.
But the base is stationary, carrot. It can't just magically gain velocity, carrot.
Okay, we're done, dude.
Truly, this is the dankest dungeon.
Thank you. Wow, I really felt great. Thanks,
Destiny, is this portal 1 or 2? In portal 2, the portals would give slight extra velocity to stop some glitches from happening. Peppy. Destiny, here is $5 to nuke it.
These pictures, dude. I can't even believe this.
What happens in B theory if the orange portal stops when halfway through the cube?
Then the implication would be that the cube would pull itself through the portal. That's what you would have to imagine would happen. Is that the momentum of the cube, assuming it doesn't tear itself apart by moving through at some absurdly fast rate, you would just assume that it would pull itself through. That's what you would...
The dankest dungeon.
If you think physics is magic, I'm sorry you live in Afghanistan.
Think of a window dropping over top of a cube. Why would that suddenly cause the cube to fly up in the air? Oh my god.
Bar.
This isn't real, right? I'm genuinely asking chat. How many of you honestly think that that dropping a window or a hula hoop onto the thing is the same thing as having two independent portals that don't
dungeon.
Destiny, nice job being right. Since you're such a brilliant physicist, maybe you can use your skills in Kerbal Space Program? I love you. Actually, I live in Paris. Allahu Akbar, brother.
I don't know, dude. How isn't it the same as a hula hoop? The only difference is that the other side of the hula hoop is a different place. But that's not the only difference. The difference is the speed and trajectory of the other side of the hula hoop, dog. Dog.
Truly, this is...
I think I might be done, dude. I think I need a break for the day, man.
Did Aslan die to a portal-related accident? Is that why he isn't on stream anymore and why you have been ranting about this for hours? Let it go, Destiny. Start the grieving process. Destiny, I love you and these discussions, but for the love of feed Nathan, can you stop getting baited and triggered by chat like a Spurglord?
Are these, like... Do you people... Who's drawing these? Do you actually think... You realize that in these examples... Orange and blue are sharing the same trajectory. Can somebody link the original problem? But in this thing, orange and blue are not sharing the same trajectory. Do you not understand? In these examples, orange and blue are the same trajectory. And I said that, or I'm sorry, the same velocity. If these are the same velocity, then the answer A is correct. But in this picture, in the drawing, the orange is moving down and the blue appears to be stationary. These are not like comparisons. Is this bait? Destiny, in the problem, orange and blue can have the same trajectory of the motion lines on option B or the portal.
Destiny, here is a Creative Commons explanation of frame of references.
What is this picture? B is totally wrong. Imagine that if B theroid would be true. Orange portal covers half the box at a speed of 100,000 kilometers an hour. Water gains speed because blue portal doesn't know the orange and water.
Destiny, can't we just agree that it is a paradox? The portals create a single point in
every object
space
gaining
that
huge
from a
speed would literally
single
be teared
reference
apart at the
point
beginning.
is both
First of
moving
all,
and standing still,
you're using an
which is
extreme
impossible,
speed.
hence the uncertainty of the outcome.
Things can be teared apart at extreme speeds. This can actually happen in real life, right? right? I'm pretty sure that a person falling theoretically into like a black hole would be torn apart because of the extreme differences in gravity based on your, right? Is that not true? Based on your distance from the event horizon, isn't some theory that you can actually be stretched out and pulled apart because of how insanely different the gravity is from one area to the next because it's so dense? I don't know if that's actually true or not, but like theoretically it could happen. Like just because this would be an extreme example doesn't mean it's impossible. Like
chat spam Apather for KSPR. We will have to endure this for another hour until Destiny has an autism overload and pushes his face into a bullet at 400 meters per second. Because frames of reference and shit.
Truly, this is...
I want to be done, dude.
Dungeon.
You should look up the Dunning-Kruger effect. Think it's gonna save you from arguing with these autistics. I dunno, Destiny, can you start from the top again? I really am trying to understand Kappa.
Alright, we're done. I'm gonna flip a coin. If I get heads, I'm gonna get a drink, and we're actually completely done. Okay, all of you are fucking retarded. I actually can't believe. Okay, I will take one more person on Skype that thinks that I'm very wrong and thinks that they can argue their point cohesively, or so that you can understand it. I don't know, I'm looking for a word. One person, okay? Throw me up, I'm gonna go get a drink, you guys have to choose your challenger, and I will be back, okay? If you can't pick somebody worthy, then I get to walk away from this argument being 100% correct, and you know, go fuck yourselves.
Fuck you, chat, for doing this.
Okay. Who is your challenger? Who is your champion?
Alright, motherfucker, let's go.
Dunebug? Nihilus. Okay. Alright, Dunebug. Get on TeamSpeak.
MFW Destiny complains about sudden death in Overwatch. Literally decides what to do with his life by flipping a coin.
What are these?
It's more like Destiny is Drago, and Dunebug's Apollo Creed.
Oh god, I don't know anymore.
Time to mute.
A bit more money for the KSP donation drive.
Not a clue.
Just try it out, Steven. There's nothing to lose. You really seem to be interested in, like, what it needs to get a payload to space and stuff like that. There's a lot to learn for everybody.
Okay. Dunebug is your champion? That's who you're sending?
Yes.
Dunebug is big and strong and isn't afraid of nothing.
Alright, Dunebug, so whoever thinks that I'm grossly incorrect in either of my interpretations, is there anybody in here that matches that and thinks that they can intellectually defend that point of view?
Destiny, can you fix your mic so you stop clipping?
No, I can't do it. I always come in TeamSpeak. I don't know why. It's not possible for me to fix it. I don't know why it isn't.
Rip.
Who, does anyone in here feel like I'm incorrect? I know all you fucking piece of shit were talking shit right before I got into this channel, so who wants to be brave enough to do it while I'm here?
The only shit that's been being talked is that it doesn't matter.
Destiny, I do have one question. Are you talking about, when you're talking about this shit, are you talking about in real life, or are you talking about in a video game in Portal 2? Because I wasn't here for most of the discussion.
We're not. I'm not talking about either.
Well, that's helpful.
But
I'm talking about in real life if we're not conserving like energy or anything.
Is the forces of gravity the same on either side of the portal?
We're not going into that. That makes things too complicated. We're just ignoring gravity.
Okay. So are we assuming no gravity?
Sure.
Or...
Yes.
Okay. So it's that
Okay,
changes.
so if there's no gravity, there's no way for the cube to be resting on the piston, right? It has to be floating then. Whew.
You can never have A happen.
Well, it just has zero velocity.
Yeah, it just has zero movement.
Direction.
Yeah.
Because it never rolled down the thing without gravity.
So the two have like zero momentum?
Correct. Or zero movement, and the portal has zero movement. It would just rest on the edge of the bubble, like I said.
So wouldn't this all depend on if the portal... Oh shit, I missed.
So no one in here when I leave this room, it's not gonna be like, I can't believe Destiny said that thing and it was so fucking stupid and he thinks he's so right. No one in here disagrees.
All we have said is that it's just dumb that this has been going on for so long.
All we have said is this whole conversation is just
All right, well, then all of you are fucking retarded.
I think I can. Yeah, definitely.
No,
can someone link the problem, please?
Iota's a fucking
Calm down, Jesus.
It's not a problem.
Stop talking over one another.
Destiny, I only
just
have
Iota's
one
like
brain,
three
okay?
people.
Whoa, hey.
So they fucking increased the drop rate on Iron Sword.
Well, can't believe Destiny said that thing. So stupid.
Yeah, what's wrong with him?
Yeah, what a fucking idiot.
Destiny, there is a problem. Someone posted earlier about a picture of someone shining a light.
Destiny's a fucking retard.
The light thing is bad because you can't use light because light will only ever move at the speed of light. Light only propagates at the speed of light. If you're in a car and you're driving and you're moving 50 miles an hour and then you turn on your headlights, the headlights are not moving at the speed of light plus 50 miles an hour. You cannot move faster than the speed of light. Light only propagates from a source at the speed of light. Only ever.
Yeah, but that's because it's connected to the car itself.
No. Light can only ever move at the speed of light. It will never be moving faster than the speed of light. Right?
Yeah, it's not going the speed of light
plus the speed of the car. It can't do that. It's not possible.
Yeah.
Hey, Destiny, that's why I was a professor of physics, and then see if he actually cares about this problem.
Do you have a professor of physics so I can get on TeamSpeak?
Does Iota count?
Nice. No. He's undergrad, dude.
Yo, Destiny, I have one grab. You know when you swing your hands around in the air?
Oh my god.
Can you feel the air moving
Here
around?
Here it is.
Goodbug has been banned for 7 days.
User was banned from the server.
I just want to know, man.
Steven, read that.
Uh-oh.
Light can move slower, though. Hey, Destiny. Destiny, did you know that light can move slower than the speed of light? Did you know that? Are you aware, Destiny?
Wait, did I pull up the wrong thing? Maybe I'm fucking retarded.
Jesus Christ.
No,
I know I've read somewhere that
my chat experience.
There's certain particles that are capable. Hold on.
Wow.
Wait, Destiny.
I think they mean slower than C in the vacuum. It's
Like
medium
speed.
dependent.
He's here. Are you our savior? Have you been listening to this conversation at all?
It's B classically. It's A in the game physics.
God.
That's it. That's
wait,
it.
no, Destiny.
Well, it's B in the game
Okay,
physics, though.
Okay, so then one more time. No one in here disagrees with anything that I've said, right?
I just think it's
nobody.
Okay, that's all I want. Okay, that's all I want. All right, thank you.
It's A.
Later.
I'll do it first. Sorry.
All right, Harkton, are you ready for tomorrow, dog?
Oh boy,
I built the base we're gonna do. It's just yeah. Looks pretty nice.
It looks okay.
Here, look.
We're gonna have to determine.
I'm not moving it, dude. If you're ready, you're gonna be the builder, dog. So we're just gonna roll.
If you hold forward, right, you can just go down.
Oh shit, that's awesome.
How fucking awesome is that?
That's actually
Destiny, come into Intox.
Is
I
he
don't have
streaming?
time for that.
So.
Nope. All right.
Listen.
Shh. I think I'm done because nobody seems to want to come on and talk to me. Okay, so. I should ban for these fucking images. Oh no, dude. Oh, this is the guy that made the Reddit thread. Okay. I'm going to... This is my last conversation. Alright? This is my last one. I'm not talking to anyone else. Dizon is your champion since Dunebug couldn't step up to the plate, okay?
Destiny, through all of these portal memes and autism, your frame of reference is Harkton is still level 11.
Oh, wait. It sounds like this guy didn't want to call. He just wants to copy-paste text at me. Destiny and TS, give me your time. Okay, the Grim Haze will be the last person. I just want to get like one last so it doesn't seem like I'm just jerking myself off, okay? Grim Haze. All right, Grim Haze. Let me hear your microphone. Is it working?
It is working.
All right. What have I have said something that you disagree with, correct?
Disagree with? No. I'm just under the assumption that we were working off portal physics, but you have to think of the actual fact that what portal is a direct link between 2 points, eliminating space, distance, and time. So distance and time in itself makes the velocity. So moving that object, or moving that portal at any rate, would not change the velocity of the object passing through it. But if the object passing through it was moving at that rate, that would maintain that velocity. Does that make sense?
No. How does it know? How does the portal know? How can you tell if you're one of those two objects who's moving at who?
Because the portal in itself is the tie between 2 points in space, eliminating time and eliminating distance.
Okay, but what I'm saying is if an object is flying at the portal and you're standing on the other end of that portal looking through, how can you tell if the portal is moving towards the object or if the object is moving towards the portal?
Really, the only thing that would be able to tell that would be the actual motion that the object was taking.
But so how can you? But your only frame of the only thing that you're looking through is the portal. You don't have an independent third observer determining what's going through the portal. You're standing on the other end of the portal, looking at blue portal, which leads out to orange portal, and you see an object flying towards you at 300 miles an hour. Is that object flying towards you at 300 miles an hour, or is your portal flying towards the object at 300 miles an hour? How could you possibly know which one is moving?
By taking note of the objects around it. If the objects by the person were stationary in themselves, but you were seeing it coming at you at a fast rate, you'd be able to know that that object is stationary.
But how do you know that all those other objects aren't moving at it at the same speed? Maybe 9 different blocks were shot at the exact same time. What I'm trying to get at is there's no way for you to know, and that the answer is regardless, or is irrelevant regardless. The same thing will happen either way. You can't possibly know what's moving and what's not moving. The only way to know that is with an independent third party watching. But even at that, it wouldn't matter. The object would still fly through the portal at whatever speed the portal sees the object entering it at. But there's no way to know and it doesn't matter whether or not the portal's moving or the object is moving.
The dankest dungeon.
I disagree. For
the real question is only will the object ever...
Like I said before, it is a portal. It's a gateway between space and time. It eliminates space and time, and it's in and of itself. It is literally, you walk up to a door, you open the door, you walk through the door. That's what it is. Now, if you do take a running leap at that door, you will fly through that door at the same rate.
Yeah, and if the door is thrown at you, you will move through the door at the same rate as well.
But you are not moving. You are not.
With respect to what? With respect to the door you're moving, yeah.
No, with the door in itself is respectively moving towards you, and it is thrown at you. You are not giving any. You are stationary. You have no velocity. You are not moving at all.
But the door, if the door was looking at you, it would look like you were moving towards the door, even if the door is moving towards you. From the door's frame of reference, you were moving towards it. And if it was a portal, you would be moving towards it at whatever speed it's moving towards you.
And I think this was what happened before with the actual portal reference. Is this in reference to the game, where how the portal game in itself would interact?
Okay, this is all. But I'm not annoying the game. If you were standing in a room and there is a portal sitting on the wall, we look at a portal and the portal is sitting there shining, and on the other end of that portal, we can see through that portal and into what the portal is looking at. There is a ball, okay, or a cube or whatever, and it's coming at you at 300 miles an hour. You see it coming at you. Now, as you watch it coming at you, as soon as it hits you, it comes into your world, is it just going to plop out? Or would it continue to move at that velocity? You wouldn't be asking, well, are you, the portal, moving towards it, or is it moving towards you? That doesn't matter. At the exact point where that portal is concerned, there is a block that's coming at it at 300 miles per hour. It doesn't matter which one is moving, and when it comes through that portal, it's just going to fly through the portal, is what I would imagine would happen if you were standing there staring at the portal and you see the object flying at you.
And that's under the assumption that the actual physical object was moving.
No. It doesn't matter if the physical object is moving. What if the portal was moving and you were watching that? Let's say that you were flying in your spaceship or whatever, and you're looking at the portal, and you can see that you're probably moving on the portal. You were attached to like a torpedo and fired through space, and you're flying at an object that's flying at you, and it's coming 300,000 fucking miles an hour, and then it flies right into it. You don't think that object would come like right into the room? You think it would just fall through the portal as soon as you flew into it?
I completely lost everything you said.
Let's say that you attach the portal to the top of a torpedo, okay? And then the rocket is flying, and you can even tell by cheating and looking around. You can say, like, oh, well, look, like this portal is actually the thing moving, and it's not the object. So it's flying towards that object. You're still standing there in that room, looking at that object coming at you at the speed of that torpedo. And you're saying that as soon as you hit that object that's coming at the portal that you're moving towards at 300 miles an hour, as soon as it hits it, it's just going to drop into the room?
Correct. Simply, another analogy I would place. You have two hula hoops, one being portal A, one being portal B. One hula hoop is stationary, the other hula hoop is thrown at a person. And it lands just like horseshoes, lands directly on top of the person and goes straight down. Then in itself, that person exerted no energy.
Wait, what are you saying? Wait, say that again?
You have two hula hoops. The hula hoops would simulate the actual portal.
Okay.
And you take that hula hoop, you put one on the ground stationary, and you take one, you put it above the person, and you drop it.
Okay.
Now, that hula hoop is traveling at any given speed. And like you said before, you might be looking through the other end of the other hula hoop, seeing that there's an object there coming at it pretty fast. But that object, you know, because of the way that...
Wait, what is the second hula hoop doing here?
The second hula hoop is just sitting on the ground. It could be sitting next to it. Sitting next to the person. Sitting next to the person that you're dropping it on. Or the object that you're dropping it on.
Wait, so are you like teleporting through the hula hoop?
That's exactly it. That's what the portal represents. That's it. It's a cheat through time. So there's no time to go from portal A to portal B, and there's no distance traveled going from portal A to portal B. And distance and time in itself creates velocity. So you can't make the hula hoop, you can't make the portal any faster because it defies the very principle of speed at which it travels and the time at which it travels.
Wait, wait, so what are you saying would happen when you drop a hula hoop on a person?
Think of it as without just one hula hoop. It would drop and it would go straight around the person and
it would just drop to the ground, sure?
Exactly.
So
because the object that's going through the portal that eliminates distance and time, that is going at a velocity of 0, effectively 0.
But it's moving. It's not moving in reference to the hula hoop. In this example that you're giving me, you are assuming that portal orange and portal blue have the exact same velocity. In which case, if something moves through it, it's going to come out the other end like exactly the same. If it's not moving, then it's not going to be moving, I guess, coming out the other end. When you drop the hula hoop on the ground, what you're doing is you're moving through one portal at some speed, and then when it hits the ground, the portal is stopping behind you, and the one that you just entered stopped because they're connected, right? What?
The thing is that they can't move at one speed because they defy velocity in itself.
Wait, what can't move at
the two portals?
Why can't the two portals have the same vector or the same velocity?
Because that's what a portal is. It completely defies.
Okay, so if the portals have two, so then if the portals have two different velocities, then the hula hoop example doesn't make sense, because in the hula hoop, the entrance and the exit of the hula hoop have identical velocities, because you're entering and exiting one thing that's moving at the same speed and the same trajectory.
And that is the point. You are entering as the same speed that you're exiting. But that's the thing. You are not moving at all. That's why it is functional.
Well, but not moving at what? You are moving in respect to the portal. You're moving in respect to the hula hoop. You're moving out of it. As soon as you drop the hula hoop through you, you are moving through the hula hoop, right? From one end to the other. Even if you drop the hula hoop, with respect to the hula hoop sees you moving in through it and then out of it.
And in that regard, you'd be moving in this term, the speed of gravity. So, oh shit, physics.
9.8 meters per second squared or whatever. Yeah, whatever the.
Yeah, 9.8354. And you'd be moving at that meters per second down, so into the first portal and then out the second portal.
Sure. If you believe that but again, those portals are connected by velocity, right? You understand that if you use the hula hoop example, that those portals are connected by velocity. It's the exact same. If you go in and out and the portals are moving at the exact same speed and the exact same direction, then the portals are connected to one another by velocity.
The portals aren't connected. The object that's going through it is the actual conduit of velocity. Because you are stationary, the only thing that is denoting that you're going through the portal is because it's going from the top down. And because it's going from the top down, it's going from the top down at gravity speed. So if you take a running start or do 10 miles an hour into it, you would run through it in 10 miles per hour. You would have the same speed going through it than you would having it fall on you. But if it was thrown at you, you would not have that speed going through it.
I don't disagree. This is the interpretation for interpretation A. You're assuming, but you are assuming here that the portal. Do you understand that portal orange and portal blue must have the same velocity for your interpretation to be true, right? Because what you're talking about, every time you talk about running through something or having something thrown at you or anything, you are talking about having two portals that are connected on the front and back and are always moving in tandem with one another, right? Like that. Do you?
Yeah, I get what you're saying, but the thing is, in the situation where portal A and portal B, the generic definition of portal is that it is a, like I've been repeating.
Yeah, so if you want to say that the portals don't have the same velocity as one another, if the portals are existing separately, independently from one another, then that means that your door frame or hula hoop or whatever example, they don't match. Because the hula hoop, the only way for the hula hoop to match would be you going into one hula hoop and then coming out a totally separate hula hoop that's not in the same shape or whatever. It's a totally different thing. Or dropping a door frame on somebody wouldn't launch you out the other end because, again, the door frame thing is assuming that you have the same, you've got the same velocity between both portals, right?
You don't have to assume that you have the same velocity. You have to assume that the actual portal in itself is only like you were saying, it only has one other exit. It is in terms of a straw. So it has one entrance, one exit. It's not broken to the point where it has one entrance and you could kind of go out another way if you wiggle just right.
Okay, but the difference between exits I'm talking about is the portal can either have an exit that shares the same velocity, that same vector as the other portal, or it could have one that can face in a completely different direction, is what I'm saying. And those are two different types of things, right?
Like you just said, you're focusing on the portal in itself.
Yeah, because it's really important.
It is important because it is the actual conduit which you are going through.
Okay.
The object is going through. But the object in itself is the only thing that can carry momentum or can carry velocity.
Okay, but you're focusing hardcore on the object. Let's say a portal flies at you and it's connected to another portal at 100, then that other thing is moving at 100 meters per second, okay? And an orange portal flies at you, and then you enter the blue portal, right? So what you're saying is you're not going to go flying out the blue portal because you were standing still when the orange portal flew at you, correct?
Correct.
Correct. Now, you're right there, kind of. You're not going to go flying, kind of. But in respect to the blue portal, you will. If you're standing still and an orange portal flies through you at 100 meters per second, as soon as you come out the blue portal, you're going to be able to look behind you, and that blue portal is going to be flying behind you at 100 meters per second.
Why does the blue portal have to fly?
Because you're saying
in itself have to have velocity when in itself the portal in itself negates velocity.
No, the portal doesn't negate. You said that the orange portal is moving at you, so it has a velocity, correct?
Correct.
And so if the portal is moving at you and it has a velocity, and then it's spitting you out another portal with the same velocity as it would if in your hula hoop example, or the door frame example, then after you go through it, the portal would continue moving behind you at the velocity that it engulfed you. When the orange one engulfed you, you would look back and you would see the blue one leaving you at the same speed that you entered the orange one.
No, because the portal isn't. The secondary portal, the one you exit, doesn't move. It's a stationary portal, like in the initial example, A and B.
Okay, then if the second portal doesn't move and the first one is flying at you, right? That's what you're saying. So they can have two different velocities, right?
Correct.
Then you would then you would come flying out of the second one. Because if you were sitting there staring at that portal, if you were looking at that portal, all you would see is somebody moving towards the portal at 100 meters per second. And then all of a sudden they would be engulfed by it, and then they would fly out of your portal at 100 meters per second. If the blue one is staying still and the orange one is moving at the person.
Because I think you're getting caught up in the fact that one of the portals is moving. The portal in itself, even though it's moving, it doesn't matter if it's moving, because it doesn't carry. It negates this. Oh. Okay. How do I put it?
Like, I'm just imagining if you're standing in a room and you're looking at a portal and you see an object flying at you and it's coming at you at 100 meters per second, and then the portal engulfs it and it comes through, it's going to come spitting out at 100 meters per second. You would expect that to happen. You wouldn't expect it to come through the portal and then just stop right there. That doesn't make any sense.
Well, you would have to. You would literally have to wait and see, because like you said, you may not know that if the object in itself is moving or not, but you know that something is moving. It's like...
But again, it doesn't matter. When two objects collide like that, it doesn't really matter which one is moving. They're going to collide and the same result will happen regardless in respect to both objects. It doesn't matter which one is moving. Again, with the fist punching the face or the face punching the fist, there's no way that either one can really determine who hit who. You can determine via other means, via third-party means, but you don't know if you hit a fist with your face at 100 miles an hour, and if a fist hits your face at 100 miles an hour, it's pretty much the same result. It's the exact same thing happening, and neither the face nor the hand can determine who hit who. It's just much the same way that if you were to fall onto the floor at 100 miles an hour onto your head, it would be the same result as a ceiling falling on your head at 100 miles an hour. Like, it's the same thing. Like, kind of. No, the next one. I mean, at the moment of impact, obviously the ceiling would come and then crush you versus you just falling to the floor, but...
I'm trying to think of an analogy that would actually
sure.
make a better statement. Okay, I'm not thinking of anything. Like I said, the best way I can explain it is the simple fact that these two portals are fictional for all means, but the definition of what they would do is transcend space or distance traveled in time. So even though the portal would be moving, the object that's moving through it would have to have its own motion, and that motion would carry through the portal.
Yeah, but what I'm saying is that, like, nothing like that really has, like, nothing has its own motion. Like, when you get out into, like, outer space, like, what has a motion? What's moving anywhere? Like, on planet Earth, we're kind of sitting here and the moon orbits us, but if you're looking at it in respect to the sun, everything is going around the sun. Or if you look at things in respect to Jupiter, like, the moon is orbiting the Earth, and the Earth is going around the sun, and, like, everything, like, the motions that everything are moving are in respect to other things, like...
Destiny, I love you. Please look at this link. Love, Elliot Oler.
Or if we were moving through space and we collided with some crazy comet or whatever, it's not a comet, like an asteroid or something, the asteroid could be sitting there and our entire solar system could move into it, and from our perspective, the asteroid is just crashing into Earth, and it's like, oh fuck, ignoring gravity and shit, right? The asteroid is just crashing into us, but in reality, the asteroid could be chilling there and we could just crash into it, but it's the same, it doesn't matter, like, it just, the only thing, it depends on the frame of reference, like, are you on the asteroid, viewing the Earth coming towards you, or are you in the Earth, viewing the asteroid, viewing you going towards the asteroid, like...
Okay, it's a deep conversation. I thought it would have a little more for you.
All right, I love you, buddy. I appreciate it.
Sorry.
All right, be careful. Okay, I will ask if we're done or if I should do one more. Potato McWhiskey's a tier 4. I've been talking a lot of shit. This is the interpretation for, this is for interpretation B. So if you were standing right here, and you were looking at this, what you're seeing is you're seeing a box moving towards you at whatever speed this is following, or whatever speed this is falling. So as soon as this hits the ground, you would expect the cube to come flying through the circle. This would be what you would expect for interpretation B. However, if you believed in interpretation A, this platform right here with this portal on it would be moving at the same speed as this, or at the same velocity even, as this falling platform. So what would happen is, as soon as the cube goes through, if this thing comes to a sudden stop, then that means that this moving piece would come to a sudden stop, and then the cube would just float there right in front of it. And then that would be solution A. I feel like I don't feel like I can explain it any more than that. We're going to try one more guy. I don't know why, but we're going to fucking do it, man. One more. All right. All right. What do you think I'm wrong about?
All right. So let's talk about the actual fundamental problem. Is that you talk a lot about the frame of reference not being defined, but in the original picture it is defined. So are we talking about the original picture, or are we talking about a new problem where we remove those sort of lines of motion that give us the frame of reference, and we're talking about where we don't have a frame of reference?
Link the original picture.
I don't have it. You're gonna have to get chat to do that. I'm sorry.
I remember the original picture. The only frame of reference that matters, really, is the portal's frame of reference, because that's what's sending things through to the other side, not a third party, right? Whether the portal is falling on something else or something is falling into the portal, that doesn't matter. The only thing that matters is the speed at which an object enters the portal with respect to the portal's frame of reference, because the portal is the sole decider on what goes through the portal. Not a third party, not somebody else observing things and then sending information to the blue portal about what's coming through. The sole determiner of what gets sent to blue portal is orange portal. So the only frame of reference that matters is things moving in respect to the frame of reference of the orange portal. So if the orange portal falls on something, or something falls into the orange portal, it doesn't matter. That's what I'm saying. In respect to what goes through the blue portal is what I'm saying.
Okay. So you think it's B, where
I think that based on the way the problem is presented, B appears to be the most reasonable answer. But if you believe that the portals are tethered to one another in such a way that they always share the same velocity, that A could be a valid solution, except it wouldn't plop on the ground, it would just float at the end.
Yeah, of course. So what I think you're wrong, because even if the portals are sort of disembodied and not working like a cylinder, that it's just going to be A, because there isn't a force moving the box. Now this is only true.
There doesn't need to be a force moving the box.
Right, but there's no energy imparted into the box at any point in the thing.
There is kinetic energy in the cube in respect to the teleporter. Sure, the teleporter sees kinetic energy in the box because the box is moving towards the teleporter. The teleporter doesn't know that it's moving towards the box, right? Depending on what your frame of reference is. Again.
Okay, so I'm trying to think of how to properly explain.
Sure.
So are you looking at the original image?
No, not right now, but I know it pretty well by now.
You've been looking at it for like 6 hours. So in the actual image, I'll link it in TeamSpeak. In the actual image, there's lines of motion on the orange portal.
Sure.
Because this event is being observed from a point of reference, so it is seen that the orange portal is moving, right?
Okay.
The interpretation of A is correct, because it is the portal moving towards that's what's being observed as happening, is that the portal is moving.
Okay. But the portal itself, but the question isn't, if the question was, what do we as an external observer decide goes through portal B based on what we see? That's not the question. The question is, what will come out of portal B based on what goes into or what will come out of portal blue based on what goes into portal orange? That's the question. So the only thing that orange can do is send things to portal blue based on what goes into portal orange. That's all it can do. You're making the assumption that we as a third party are communicating with the portal saying, hey, you're moving and the box isn't moving. So go ahead and, you don't have to do anything, like, right? But the portal doesn't know that. What I'm saying is, if you were standing right in front of the blue portal, if you're standing right in front of it looking in, all you can see is that cube coming towards you at some speed. You don't know if you're moving towards it or if it's moving towards you, because it doesn't matter. The fact is, you guys are approaching each other at whatever speed it's moving or you're moving, and as soon as it connects, it's going to come flying out at whatever that speed is, regardless of who's moving, is my point.
So you're talking about a frame of reference standing on the blue portal side of the...
Yes, which I believe is the only frame of reference that matters, the portal's frame of reference, yes. Because the portals are the things deciding what goes in and what comes out. That's all that matters.
But in the question, the frame of reference is defined as something other than the portals.
No, it's not. No, it's not. The portal isn't... If the question was, you are a third-party observer, and you're standing at a computer, and you need to decide what to send out or be or whatever based on what you see, then that's a different question than what we see right here. Because what we see right here is the orange portal is moving towards the cube at some speed. What information is it going to send to the blue portal? Well, the orange portal is just going to see the cube entering it at whatever speed the orange portal is moving towards it. That's it. It's just going to see it moving towards it at some speed, and then it's going to send it out of the blue portal at that speed. There's no difference if the cube is moving towards the portal or if the portal is moving towards the cube. That's completely irrelevant.
Damn. It's sort of a similar problem to those sort of, the... What's it called? The double slit experiment. It's a sort of really difficult question to answer without actually observing it.
Well, no, that's a different...
No, it is.
No.
Because
the double split experiment has to do with the fact that observing something will actually change its properties. That's a totally different...
Yeah, no, I know that, but what I mean is that actually, like, it's a very difficult question to answer until we've seen it happen, if you know what I mean. Like, it's... Like, basically, we don't have all of the information to make a judgment on this.
I mean, I disagree. I think we do have enough.
So, for something to move, there needs to be a point of reference and a force. If the portals... I think you've actually convinced me that I was wrong, if I'm thinking about it now.
I mean, that's okay.
So, I guess I was just being autistic and retarded.
I mean, you were calling me a lot of names in chat.
That was just because you were ignoring me.
You kind of sound like the British dude in Bridesmaids. Do you know that actor?
Nope.
Oh. You've never seen Bridesmaids before?
It's funny because I'm Irish.
Oh, yeah, I think that guy is Irish. Hold on, let me find the actor name.
Calling them British sweats to me. You'll be in trouble with the rest of the Irish, man.
Chris O'Dowd. Do you know who that guy is?
Oh, yeah.
Yeah, you sound like that dude. Is he Irish? Yeah, he's an Irish actor and comedian. Oh, yeah, okay, there you go. Cool.
He comes from the same area as me.
Oh, well, there you go. All right, okay, I love you, buddy. It's been fun chatting, all right?
I hate you, too.
All right, peace out.
Peace.
Okay, so, never mind. I think we're done. Destiny, I've actually put thought into this and planned out how to explain this. Okay. You're the last one, dude. You're the last one up. Go for it.
Hello?
Yep, it's all you, buddy. Take the floor.
Okay, great. Hello. So basically, this is actually a more complicated problem than it seems because there's two different cases to consider.
Okay.
One is the obvious case, which is what most people, I assume, are thinking. You have, which is what the couple callers before me were trying to say. You have a single point of mass, basically, which is the cube. Some people are saying it's single point of mass, and that's how it's being, I believe that's how you're interpreting it. Am I correct or not?
Can you explain what you mean by that?
Basically, when the portal comes over the cube, you're assuming that it goes through all at the same time, right?
Not necessarily. I don't think so, not necessarily.
But if it was like a single point of mass, would you assume that it would still be option B?
Yeah, I don't think anything would change in my initial interpretation.
Okay, so, do you know what momentum is?
No, explain it to me.
Momentum is basically velocity times mass.
Okay.
An object actually has momentum.
Okay.
So, like, if you have an object that's not moving, and you give it momentum spontaneously, it will immediately start moving after that.
Okay.
So what you're purporting in the case of B is that after you instantaneously move the cube, you're giving it momentum, and it's gaining that momentum and starting to move.
Okay, I don't think you're right. I think that what you just said is untrue. If you are floating through space next to another object, and both you and that object are parallel with one another, and you appear to be completely stationary, okay, couldn't you argue that in reference to one another, you have no momentum, but to a third body that you are approaching, you would have momentum? Could you not make that argument? Isn't momentum
correct?
Okay, so then momentum
reference.
Momentum is just something else that is defined by your frame of reference.
It's defined by the frame of reference.
Sure. So when you just said that you have no momentum on that box, but if the orange portal is approaching that box at a high speed, then the box does have momentum.
Let me clarify.
Okay.
The momentum, whenever I'm talking about momentum, I'm talking momentum in the most standard frame of reference we have, which is looking at the picture, the momentum of the momentum in the case of the Earth.
But the frame of reference of looking at the picture is not the frame of reference determining where the box is being sent, right? The portal is what is making that determination. And even if you were making that even if we did have our own frame of reference and we knew what was moving and we were asking this, right? And I were to ask you, okay, well, using our, here's what I could say. I could say, we're going to use our frame of reference, okay? Tell me, is the orange portal hitting the cube or is the cube hitting the orange portal? You would say, well, we can very clearly see that the orange portal is hitting the cube. But then if I were to ask you, okay, now from the frame of reference of the orange portal, does the orange portal know that it's hitting the cube or does it think that the cube is coming up and hitting it? What would your answer be?
The difference here is that you're saying that what the portal does is completely different than what it actually does. If the portal actually, all it does is change the position of the object, what you would have is that the singular point in space, a singular piece of mass, would just change positions. It would not be gaining any momentum. It would not be just because it was thrown in a different position by a portal that's changing.
But that's what I'm saying. What you just said, again, defied your frame of reference. You said, with a portal that's changing. But the portal doesn't know that it's changing. That's what I'm saying the whole time. The portal doesn't know that it's the thing that's changing. The portal is always stationary to itself from its own frame of reference, much the same way that every object is never moving, right? Or always moving, depending on how you're looking at it, right? The orange thing sees itself as being stationary and the cube flying towards it.
But the only frame of reference that matters is the Earth's frame of reference. Looking at the pictures from an outsider's point of view. From an outsider's point of view, no matter how fast any of the portals are moving in relation to each other, if the object is not moving and it's teleported instantly to any other new position, it will not gain velocity
but that's like
or momentum.
What you're saying there. That's like saying there's a baseball there's a baseball in orbit, and then there's another guy, and the baseball is stationary, and a guy flies into the baseball at 200 miles an hour right in the head, and then the guy's like, "Ah, fuck! That baseball just fucking hit me in the head." And then you call him up and you go, "Dude, no. I'm on Earth, and I just watched that. The baseball didn't actually fly into your head, dog. You flew into it." And then he's like, "Oh shit, dog. Well, you're right. Well, never mind. That didn't hurt at all because I hit it." Right? It doesn't make any sense. It doesn't matter. It doesn't matter what you think from your frame of reference. What matters is the frame of the reference, the frame of reference of the object that's doing the interacting with the other object, right? Okay. It doesn't matter if we're looking at the portal and we're saying, "Oh, no, portal, you're moving down to the cube." The portal doesn't care. All the portal can see is the cube moving towards it and then spitting it out the other side. Like, that's it.
Yes, but the base assumptions here are that if we're all on Earth, this is happening on Earth, that from our point of view, the cube is stationary. And what the portal is essentially doing, it's transporting it in space from one space to another space. If the portal is moving while it's transporting it, it does not assign any extra momentum to the individual object that's being transported. It only transports it to a different space.
Sorry, hold on. I got a donation message. One sec.
Dankest dungeon.
Literally figured this out last month is college. You guys are making it so complicated.
Okay, I'm sorry. Could you explain that last thing one more time?
What's essentially happening, if we are on Earth and there is a stationary object, whenever that object is in a portal whether that portal is moving or stationary and exits the portal, what's happening is that it's changing from one place to another place instantaneously.
Okay.
It does not gain any velocity or momentum as a result of that change. Even if the portal is moving, as soon as the portal leaves, unless you assign an arbitrary momentum to make the portal keep moving in the direction of the moving
You're not talking
portal,
about a portal at this
then
point.
the
You're
portal
talking
will-
about some teleportation device that just scans in an object and then teleports it to another spot.
Correct. If you're talking about a singular point object and the portal is a teleportation device, then it would not move. If you actually have a solid 3D object, then what would happen is you're not instantly gaining the velocity. What happens as soon as a little bit of the object goes out of the portal, the rest of the object is being forced into itself, and it's basically pushing itself, giving itself momentum through that way. It's not gaining any momentum because of how fast the portal is moving. It's gaining momentum because as the portal is moving, like let's say if you want to have a stationary object and you're slamming something down on it, right? So as the portal is moving and it's slowly exiting the blue portal, the object itself is pushing upon itself to make itself accelerate. It does not gain any velocity from the actual portal itself. It's pushing itself out of the portal, not
I don't
the portal itself.
understand. Can you explain this one more time? So tell me how you think it works or whatever.
Okay, so the change, option B would be correct, but for not the reason you're thinking of. Option B is only correct because once there's a tiny little bit of it, a singular portion of it instantly transported, that portion is not any faster than it was before. But what's happening is that the rest of the object is pushing that little bit forward. And as that little bit grows larger, the rest of the object behind the portal is being pushed farther into the rest of the object that's past the portal, giving it that acceleration. So the acceleration is coming from the object pushing itself out of the portal rather than the portal having any increase in acceleration, giving it any increase in acceleration, velocity, or momentum.
I feel like I'm a broken record. I understand what you're trying to say, but again, I feel like that you're not defining anything with respect to the frame of reference, and you're just making assumptions that from the portal's point of view, you'll know whether an object is moving or not. But even though you can't, like, can you tell me using your example then? So tell me what you would see from your example if you were standing in a room and you see the blue portal and you see an object moving towards the blue portal. What would you see? As soon as it starts to squeeze through the portal, it would try to force itself through instead of just smoothly moving through like any object thrown through a window, or?
Are there two stationary portals right now?
No. Well, I don't know. You don't know. You're just looking through and you see an object moving towards the portal. But you don't know if
Am I seeing the object move towards the portal from my end, or am I seeing the object move towards the portal
You're
from
standing on the
other
blue
part of the
you're
portal?
standing behind the blue portal and all you see is an object approaching you. That's it. Because that's all you can see. You don't know if you're moving towards it or it's
an
moving to you.
object approaching me,
okay,
as the first singular part of the object enters the portal, nothing happens because that object was transported from the instant it contacted.
Okay, but we're not
the orange portal.
I think that
to
we're
the
having
orange
like a
portal.
totally different
And then-
view of how the portals work. If you're talking about like them transporting matter through rather than it just being like a smooth
That's why
transition
there's
through
such an
space.
important distinction between having a singular object be transported and having a 3D object be
Well, no, but we're talking 3D objects, but we're not talking about like matter destruction and creation. We're talking about smoothly moving through 3D space, but a portal just connecting space together.
It's gonna look smooth, but it's happening because it's happening so fast. Like, it's gonna look very smooth. It's gonna look exactly like you expected it to in option B, like the picture with the whatever it's called, the Steam game that someone demonstrated. It's just that it's pushing itself through. The portal does not add any velocity to the object, because if it were a singular piece of mass and the portal did anything to it, all that would happen was it would move positions. It would not gain any momentum or velocity. Like, okay, if half of the object went through the portal, right? Let's say that half of the object is a singular thing, and it was just transported instantaneously. What you're doing right now is you're throwing the other half of the object at 100 miles per hour towards the first half of the object. And that's what's actually adding the velocity. The first half of the object is throwing the other half of the object through the portal.
I guess so. I mean, like, but that's not. So are you saying that even I'm interpreting these portals as working like normal space, like as you move your hand through normal space. If you were to go in a portal and out of a portal, it would be the exact same thing as just moving through normal space, right?
Yeah, but when you're moving through normal space, what's happening? You're pushing your hand with the rest of your hand through normal space.
Sure. To some extent.
The portal isn't actually doing anything.
You're just moving through space, yeah, sure.
Yeah. So when you have a portal that's moving really fast and then a portal that's stationary, what's happening is that all of a sudden, instead of pushing your hand through the portal and it becoming really fast, you're just pushing your hand really fast through the portal.
Okay, yeah, I guess so. This sounds like what I was saying earlier, though. What's the difference?
The difference is that the portal doesn't actually change any velocity. You essentially become the thing that's going 100 miles per hour and pushing yourself through the portal.
Yeah, this sounds exactly like what I was saying earlier. I don't understand. What's the difference?
You were saying that the portal actually changes the velocity of the object.
When? No, I was saying that you would move through and come out at the exact same that you went in. No? If you believe in B, you would come out of the portal at exactly the same speed that you went into the portal at, I think is what I've been saying the entire time.
Yeah. So then A would be impossible unless you were doing the single mass.
No.
Single point
A
of
would be
mass.
possible if the tunnels were connected to one another. And as soon as the orange portal stopped, the A portal stopped, which would cause the cube to just float there, right? Is the only way.
You're not talking about situation A in that case. You're just talking about the hula hoop scenario.
Well, yeah, which would be situation A. It wouldn't plop out, but the cube would just float at the end of the portal.
But situation A would never be possible within the Earth's reference frame.
Why not?
Because assuming we're looking at this picture and we're just standing like a few feet away from it, situation A would be impossible unless it were just getting instantly transported.
Well, no, what I'm saying is that the A portal would be moving at the same speed as the orange portal, always. And that you'd see the A portal moving down, 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 and then when the orange portal smashes into the ground, or the thing or whatever, you would see the A portal suddenly stop, and then the cube would just be floating right on top of it.
Yeah, that could be how the A portal would be used.
That's how, yeah, if you believed in the A portal theory, then that's, yeah, that the portals are tied to one another, that they share the same velocity at all points in time. Is what was the argument for the A portal. But if the portals were disconnected, then what you were saying earlier is what I was saying would explain the B portal, right? That your momentum would carry you through, regardless of if the cube were moving or the orange portal were moving.
The A portal, no. You can't just say that the portals don't have any velocity in response to each other.
Wait, what do you mean?
Okay. If you want to completely stop it, right?
If you want to completely stop what?
Completely stop. If orange to A, right?
Okay, orange to A. Okay.
If it's going to completely stop,
yes,
it has to have movement in the opposite direction, basically.
No.
Yeah, because if it doesn't, then what you're basically saying, as soon as it gets to the top there, you're still pushing the rest of the block into it.
From the frame of reference of the portal, yes, you are pushing the block in, sure. Much the same way that if you were to hold a hula hoop above you and drop it to the ground, the hula hoop is quote-unquote pushing you through all of itself, but as soon as the hula hoop hits the ground, it would just see you floating above it or standing above it.
In A, the cube is actually going just as fast as B, except
But the portal A is moving as fast as the orange portal. So when the orange portal slams into the ground, the blue portal will come to a stop, and the cube will just be floating above it or sitting right on top of it.
It's just not appropriate for this picture.
Correct, I agree. I think that with this picture, I don't think that you can say that the portals are tied to one another and share a constant velocity. It doesn't seem to make sense with this picture. That's why I said that B was probably, if I had to put my life on it, I would say that B is the correct interpretation based on how the picture is drawn.
Yeah, B is the correct interpretation, but it just has nothing to do with the portals adding velocity, and rather the object itself pushing itself through the portal due to the speed that it's going on the other side.
Sure. I feel like that's another way of saying what I've been saying. All I'm saying is that when an object passes through the portal, whatever speed it passes through the portal, it will continue to pass through the portals on the other end, is what I've essentially been saying, or exactly been saying, I think.
But that's only true for a 3D object that pushes itself. It's not true for a singular object.
Well, it doesn't even necessarily have to be pushing itself. It could just have momentum, no?
But it wouldn't have momentum.
Why would it not have momentum?
Momentum is only in one reference frame, right? So if we're on Earth...
No. If the orange portal is looking at the cube coming at it, then the cube has momentum in reference to the orange portal, which is the only thing that matters when we're talking about what the orange portal sends to the blue portal. So the orange portal sees the cube coming at it with momentum, and it will pass it through to the blue portal with whatever momentum the cube came at it, is what I'm saying, is what is the explanation for B. Do you disagree with any of the things I said there? Do you disagree with any of the part that where the orange portal? Okay, so the orange portal sees the cube moving towards it with a momentum. You agree with that, right? That the orange portal sees the cube moving towards it with a certain momentum. Do you agree with that or disagree with that?
It would see the cube moving towards it, correct?
With a certain momentum, right? So as soon as the cube enters it, the orange and then you agree that the cube would enter orange with that momentum at that momentum, right?
It depends. It depends on what it's doing, though.
No. Well, okay. So orange is going down. Okay, so we'll do two different examples on it. The orange is going down at 10 miles per hour. Would the cube enter it with the same momentum as if the platform was pushing up into orange at 10 miles an hour? Or would those be two different momentums with reference to the orange teleporter? It would see those both the same way, right?
It depends on what the portal is doing.
No. All I'm asking is the portal itself. If there was a face there, okay, and that face could only handle a punch at 10 miles per hour and the cube was a fist. If the fist was moving up at 10 miles an hour versus the face moving down at 10 miles an hour, both of those things with respect to the face would see the fist having a momentum of 10 miles per hour. Yes, right?
They would see the face. They would see the cube with 10 miles per hour.
Yes,
which means 10 miles per hour.
Okay, which means that the orange portal would tell the blue portal there is a cube coming through with a momentum of 10 miles per hour, and then it would send the cube out at B at 10 miles per hour, regardless of whether the portal or the cube were moving. Right? Do you disagree with that? Because that's my entire argument from A to Z for how the point B explanation works. We're going to talk about this for like 2 minutes, okay? Why is the motion relative to the orange portal so important? Because the orange portal has to communicate that information to the blue portal. How is the orange portal able to transfer the energy to the cube? Magic.
That would be a way to, that would be a different kind of portal. But yeah, that would still be possible.
Okay, well that was my... That was my interpretation for how B works, I think. Do you disagree with any part of that interpretation? Or if you do, tell me specifically which part of that interpretation you disagree with.
That would be a more convenient portal. That would be more elegant than how I determine it. How I look at the portals. I look at the portals just transferring mass. So you're basically pushing yourself. What you would be doing is basically just throwing the object out of the portal, and it would be instantly gaining all that mass due to the
that it would be smoothly moving through three-dimensional space through the portal. Yeah, that there's not any kind of teleportation or anything, or creation of mass or destruction of mass on any side. No. Somebody said, if B was true and orange portal was extremely fast, it would rip the cube apart. Sudden change in momentum, right? This would be homicidal if the cube was a person. Did you ever think about that? It doesn't matter if it would rip it apart or... No, what? I don't even see how it would rip it apart. It would just come flying out. How would it rip anything apart? Maybe if the orange portal stopped halfway through, then I guess it could tear itself apart if it was going too fast and it didn't have the structural integrity to survive.
Yeah, that would completely avoid the pushing itself scenario entirely. So that would also be basically the same thing.
Sure. Okay, all right. I appreciate the conversation, Mitty.
Okay, no problem. Thanks for having me.
Yeah, no
See
problem.
ya.
What's up, Dig?
Hello?
You are incorrect about the frames of reference. You are thinking about it incorrectly. Just because there's a frame of reference that makes it look like it's going a different speed, then it doesn't mean that it's actually going a different speed. But it does. It does mean that, though. Nobody in your entire life, even physicists that measure things in our fucking particle accelerators, don't add the speed of the Earth around the sun to the speed of the fucking electrons or neutrons or protons that are being shot through whatever shit. The frame of reference is important. Moral of the story, it depends 100% on your definition of what a portal is and what it does. Kind of, but this picture's correct solution is most likely B. There is an argument to be made for A, but that is not how the picture is drawn. The answer is most likely B, but there's a plausible explanation, kind of, for how A could occur without this plop bullshit. That is the correct answer to this, okay? That is the correct answer. End of discussion. If you think anything differently, literally kill yourself, all right? Okay, swag. Okay, dude. Wait, never mind. All right. This guy says I'm an idiot. One last try, okay? Here we go.
Hi Destiny, I think the confusion comes from the fact that a portal like the one described cannot exist. If a portal were to exist, it would not be in this form. It would be impossible for the entrance to move without the exit be moving relative to it.
This is the last one. I swear to God, okay? This is the last conversation. Only because this guy called me an idiot, okay? Is X Skills coming on or is he pussying out? Okay, Blue 2 is spamming like a motherfucker. Let's get Blue 2 in here, I guess, because he's spamming a fuck ton. We'll see what Blue 2 has to say. All right, you're up. Let's hear it. This is your chance. I'm going to be super harsh on you if you say something fucking retarded, because you've been spamming my chat for fucking 2 hours on this, okay?
Okay, all right. So, do you agree that in this world, there's one point in time at which this cube exists at 2 points simultaneously?
No.
No? Why not?
Because as soon as it enters the portal, it's on the other side of the portal. It doesn't exist in 2 places simultaneously ever.
Yeah, but once the cube's halfway through the portal, there's one half of the cube outside of portal blue and one half of the cube inside the orange.
Sure, there's a half on each side, but the whole thing doesn't exist in both places. Sure, yeah. So it's split between 2 universes, or split between 2 parts of the universe, or whatever. Sure. What exactly are you asking?
What I'm saying is that okay, in this world, I'm not sure if you necessarily agree with this assumption, but in this world where there's 2 parts of the cube in 2 different places, there's 2 vectors of gravity.
We're not talking about gravity in any of this, for any of this.
I am. Look.
Well, what if when you go through the portal, what if there was a lot of friction and that slowed you down so much, though, Blue 2?
Actually, friction might actually have a little bit of part in this.
Yeah.
So when it goes, there's
what if there was a giant black hole on the other end of B, and that's why the thing comes flying out, because the black hole pulls the cube towards it? What about that interpretation?
Look, we're on Earth. There's no black holes near us.
Oh, so the portals are on Earth? What if there's a Dyson vacuum cleaner outside of B suctioning everything up, and the cube is actually microscopic?
That's not part of the problem, mate.
Oh, I'm sorry. So gravity is part of the problem now?
How would it not be a part of the problem?
Because we're not talking about gravity at all at any point of this. It has nothing to do with any of this.
Then how could A be possible?
Well, the plot part is stupid, but floating right above the thing is what I've said a million times. Do you want me to give my explanation for how A is possible?
No, because I've heard it once or twice.
Then why are you asking me how A can be possible?
Because it's not possible unless it can fall.
Yeah, that's why I said that writing it as plop is really stupid. But even if we say, okay, I will concede and say we'll allow gravity for sake of your argument. Tell me how that changes things.
So, right when it enters the orange portal, it's going downwards, right, and it's on the floor of that platform, right?
Of A or B, right? It would be being pulled down.
No, even before that, it's still on the platform, right?
It's being pulled down before the orange portal gets to it, right?
By gravity.
By gravity, sure.
And then the platform itself exerts normal force pointing upwards, right?
Okay.
So at that point in time, it's not moving at all. Right?
Okay.
And then once the portal reaches the cube, as it's moving through the portal, there becomes a force of gravity in situation A, where the Sweatstony. Okay.
I feel like we're making this absurdly complicated now.
Listen. There's a force of gravity pointing downwards at point A, in diagram A, right? So then, since the portal is pointed diagonally, that in that frame of reference that you see A, the platform then is diagonal, and since gravity's pointing down, the cube has to slip down on the platform. Since you can see the platform through, if you look through the blue portal, through the orange portal, you'll see the platform, right, and the cube.
The dankest dungeon.
Does that make sense?
Yeah.
The portal connect.
The platform in that frame of reference is diagonal. It'll slip down, and it'll fall out of the portal and make a plop noise.
Okay, so what are you trying to say?
What I'm saying is that A is conceivable and B is also conceivable, given if you define your point of reference from what Potato was saying, or if you're saying that the only point of reference that matters is if you consider the portals as one thing that's moving at the same velocity.
I'm not gonna lie, dog. I don't know what the fuck you're talking about. Okay, so
look, in a world where
tell me what happened. So which one do you think is correct?
I'm saying that A is correct.
Are you sure? Okay, so you're saying A is the correct one. Didn't we start this off by saying that A is impossible?
No, well, we did, but I'm here to refute that assertion.
Okay, so you're saying that A is the correct interpretation.
Because portals, in a sense, allow the same object to exist in two different spaces in the same time.
Well,
because if you have two portals and you put your hand through it, your hand's over there while simultaneously being here.
But not really, no?
What do you mean not really? You see your hand over there and your hand is also right here.
Yeah, but once you've gone through the portal, it's on the other side.
Right, but you can see from your point of view, you see your whole hand is intact.
Okay, but you can see everything on the other side of the portal, but that doesn't mean that it exists still on your side of the portal just because you can see it over there. Right?
Well, you can still touch your hand, right?
What if you cut your hand off then? Does it magically instantaneously change positions in the universe just because you cut your hand off at that exact moment?
No, that's not at all what I'm saying.
So you're saying that if you hold your hand through there, that it exists in both worlds, correct?
Yes.
But if you cut your hand off, does it no longer exist in both worlds?
There's no two worlds here. I'm saying, look, we're in the same world, but there's two places it exists.
Okay, if you cut your hand off, does it exist in two places then?
No.
Okay, so every object, okay, so you have a hand, you hold it through, and while you're holding it there, it exists in two places, but the second you cut it off, it ceases to exist in your place?
What I'm saying is, depending on the orientation of the portal on the other side, the force of gravity will affect it differently. And when you move your hand through the portal, as you move it through, the different force, in this case gravity, different force vectors might have a different direction depending on the orientation of the portal itself.
Okay, but how does that play into either of what we're asking? We're not asking that at all. The only difference that makes is, let's say if we think it's B, then we would think it would come out in an arc, not necessarily in a straight up or right. But I don't even think the gravity is relevant to the question we're asking. It doesn't really influence whether we think it would come flying out or whether it would just come floating out or plopping out.
So what the previous caller was saying about momentum and conservation of it is that the orange portal doesn't actually give from the reference
Okay,
point
but getting into
of-
conservation of energy makes portals impossible, because if the portal blue exists in a different potential energy field than the portal orange, then everything is already destroyed, and you've already destroyed conservation of momentum or conservation of energy, right? You agree with that, right? That if you have, because when you raise something up, right, in a gravity well, if you raise it up to the top or whatever, then you're creating more potential energy. So if you go through a portal in the bottom and it comes out a portal up top, you've created energy in essence, right? That's why in Portal 2 or in Portal, if you drop a box into a portal, it'll keep going infinitely and gain infinite speed, well, up to a mass or up to a point, because the game can't do infinite speed. But that's because you're not conserving energy. Right, it'll continue to gain momentum as it falls through the portal. So we're not conserving any energy with these portals. We've already established that conservation of energy doesn't work here.
Yeah, sure, but like in this world, it's like saying if false, then anything is true. But we're already in this rabbit hole where that can happen.
Where what can happen?
Where portals exist.
Okay.
So what I'm saying is that, like the boxes, right?
Yeah.
You can have multiple forces acting on it at the same time.
Well, but you're trying to. So are you saying that forces are propagating out of the portals? That the gravity from World Orange is going into the gravity of World Blue, even if they're the same planet, just like the two, or what?
There's one force, gravity.
Okay.
And at the point at which the portal is partway through the cube, so to speak, there's gravity pointing down, and there's gravity pointing down. But portal is oriented differently, such that from that frame, the force of gravity is pointing such that it'll slide off of the table or the platform, and it'll plop down on the ground.
I don't think that gravity is like even. I'm sorry. I feel like gravity is not relevant in this discussion. I don't feel like that's like the question of what's being like. If the orange thing is moving necessarily fast at 1,000 trillion miles an hour, then gravity becomes completely irrelevant in all this anyway, right? Would you agree with that? That if the orange thing is moving at 1 trillion miles per hour, or 1 trillion meters per second, that we wouldn't be talking about gravity at all? That it would be irrelevant?
Well, that's.
Only you would be autistic enough.
Actually, ever come in physical contact with the cube. And
Why wouldn't that necessarily be true?
Because the portal, the orange portal, the platform doesn't transfer any energy whatsoever to the cube.
Okay, we're not talking about transferring energy to the cube, though.
Yeah, but if the cube were able to fly out of Portal B, how could it possibly have the energy to do that?
Because it's entering Portal Orange with X momentum, so it's going to exit Portal B with the same momentum, is what we've been saying the entire time.
Right. We're saying that the big difference here is that there's a definition of which frame is the right frame. And since you can have the same object in multiple places, the whole frame of reference thing can be defined arbitrarily in any case.
But the point of when the object is moving between portals, the only frame of reference that's relevant there is the frame of reference of the portals. Do you disagree with that? When you're moving into Portal Orange, the only frame of reference that matters, that will determine where you go in Portal Blue, is the frame of reference of the portal itself, not a third party watching. So if Portal Orange sees you enter it at 30 miles an hour, you're going to exit it at 30 miles an hour every single time.
That's given that your frame of reference
is the portal.
Is the portal, but that's not. Look, what Potato McWhiskey and what the person right after him was saying is that the point of reference that this question is presenting, we're not even the portal at all.
Well, of course not, but the portal is the thing that's making, again, for the 15th time, the question is not asking if you were a third-party observer on a computer and you could determine the speed at which this box comes out of the blue portal, what would you tell the blue portal? The question is, assuming the orange portal falls onto the cube, how will it come out of the blue portal? So the assumption that we're making here is that the orange portal is determining what information to send to the blue portal. So if the orange portal sees the cube enter it at whatever meters per second, then it's going to exit it at the same meters per second. It doesn't matter if the cube is moving or if the portal is moving. All the portal knows is that X object is entering it at whatever speed, and then it's going to exit it and continue moving along at whatever speed.
So I don't know. This is definitely a difference in beliefs, because I don't think that's one of the assumptions.
What assumption do you disagree with?
The assumption that the only thing that matters is the frame of reference. The only frame of reference that matters is that of the portals.
Okay, explain to me on another frame of reference that this makes sense on.
All right. Well, I kind of already explained it, but...
Okay, we'll go over it again, and I'll try really hard to understand.
So, we are observing.
Okay, we're observing.
From a third angle.
Okay, we're watching.
We're not the cube.
Okay.
We're not the portals.
Okay.
We're looking at exactly what this picture is presenting.
Okay.
All right?
Okay.
Cube's not moving.
Okay.
The only thing that's moving is the portal.
Okay.
Table's not moving.
Okay.
There's right at the problem statement, the cube is affected by two forces.
Okay.
Gravity pointing down and the normal force pointing up.
Okay. You're arguing for A, right?
Yeah.
Okay. I understand what you're going to say, okay? Can I just ask you one question?
Yeah. Mm-hmm.
Let's say that in the same example, you think A would happen, correct? We're looking at what we're looking at. You think A happened. If instead the orange portal were stationary and the bottom cube were being pushed up into it at the same speed that the orange portal is moving down now, do you think that B would be the correct interpretation then?
No, because the portals aren't transferring any momentum to the cube.
So if you were to throw the cube into the orange portal, it would just plop out of A. It wouldn't be thrown through.
Actually, wait. Okay, actually, no, I changed my mind. If you throw the cube, then from the point of view of the observer, then the cube has momentum, and it will go out the portal.
Okay, so if the bottom thing is being pushed up, then you think B would be correct. But since the top thing is coming down, you think A is correct, right?
Correct.
Okay,
because
so my question to you is, how the fuck does the portal know whether it's being pushed down or whether the cube is coming up?
Portal doesn't know, but we...
The portal is the one teleporting the information, though.
What?
It's being measured. Okay, let me put it this way. Let's say that we can't see this, but we have tools where we have a measurement that we can place, where we can measure the force on the orange portal. We can actually measure the force on the orange portal so that we can detect when an object is pushing into it at whatever speed, okay? So
wait. Can you say that again? I'm sorry.
Let's say that we have some kind of instrument, okay? We have an instrument that we can attach to the orange portal that will tell us the speed and mass at which something collides with it, okay?
Collides with it?
Yeah, or passes through it or whatever, right? We can tell like what it is, right? We can measure
relative to the orange portal.
Sure, so kind of like a scale, right? Let's say that we put a scale on that, okay? How can that scale ever tell us if we're moving into something or something is moving into it?
Okay, I see what you mean.
Or for another example, if you go into the bathroom and you step on the scale and it reads 100 pounds, okay? Or you hold the scale above your head and pull it down onto you until it reads 100 pounds. How can the scale know if it's being pulled into you or if you're standing on the portal? How can it ever know the difference between those two things?
Okay, I see your point. But I think the frame of reference definition is the real, like, kicker. But
again, if the portal or the scale itself, now a third party, your mom could walk into you in the bathroom holding the scale in your head and go, "You're being fucking retarded. The scale's in your head." But the scale itself is only reading, "Hey, I know that there's this much force right here. There's 100 pounds right here. I feel it," right? The scale doesn't know if you're standing on it or if you're holding it above and pulling down. The scale can't possibly know. Only your mom knows because she's looking at you acting like a retard. Much the same way in this example, you said that if the bottom platform was moving up and pushing the cube up into the portal, that it would come flying out like B. But if the portal was moving down, it would plop out like A. But the fact is, the portal, from that frame of reference, it doesn't know if the cube is moving up into it or if it's moving down into the cube. But the result measured with an instrument is going to be the same way every single time, right?
Okay, so you're saying I'm inconsistent in that since the portal has no idea which...
I'm just saying that from the frame of reference of the portal, it doesn't matter if the portal moves at 30 miles per hour or the cube moves at 30 miles per hour. The cube will always have the same momentum, regardless of who's moving, if the frame of reference is the portal, whether the portal moves or the cube moves. And that then, once the cube passes through the portal, it will be sent out of blue at 30 miles per hour every time, regardless of who's moving.
That's all assuming that the frame of reference is the portal.
But the portal is the one sending the information. Yeah, so I'm assuming that the frame of reference is the portal because the portal is the one that does the thing that does the transporting. There's not a third party saying like, "Hey, portal, I want you to send through the cube at this speed." It's only the portal doing the transferring.
I mean, transfer... Like that like using that verb kind of implies that like the portal does any work at all.
Well, okay, the portal's not doing work. You're moving through the portal.
Yeah. It's like the moving through the hula hoop thing. The
Sure.
hula hoop doesn't do any work whatsoever.
Of course, sure. But if you drop a hula hoop around you and there's nothing below you, then the hula hoop will just continue to move away from you. And from the frame of reference of the hula hoop, you will continue to fly away from it.
Yeah, but there is something under you. It's the table.
Okay. So if you drop the portal beneath you, if you drop the hula hoop beneath you and the hula hoop stops, right, in order to make A true, what you're saying there is, in that example, the top and bottom of the hula hoop have the exact same velocity, right? What you're saying then for this example to work is if the orange portal moves down, the blue portal is also moving down at the exact same speed. And that when the orange portal smashes into that platform and stops, the blue portal, even though the cube will come out of it, will stop immediately after the cube comes out of it because the orange portal is stopped. That's the only way the hula hoop analogy fits, because in the hula hoop analogy, the entrance, the bottom, and the exit, the top of the hula hoop, have the exact same velocity.
But in this case, they don't.
It doesn't appear that way. I mean, they could, and if they do, that's the argument that I would make for A. I would agree, then A works there. But the reason why I don't believe that's an accurate interpretation is because when you look at this picture, the orange portal appears to clearly be moving, but the blue portal appears to be stationary, so it doesn't look like they're connected.
But yet the cube moves through the orange portal and appears out of the blue portal.
Well, I'm sorry. Connected was a bad word. When I say connected, I mean tethered together in such a way that they have the same velocity, is what I mean.
Okay. So since the orange portal is moving, or from the orange portal's point of view, the cube is moving towards it.
Sure.
The same thing has to happen on the other side.
Yeah. Like if you were standing outside of B watching inside the portal, all you would see is a cube moving towards you at 30 miles an hour. And then as soon as it comes to the portal, it would continue to move at 30 miles an hour. It wouldn't just magically stop.
Isn't there some in between that happens right when the cube enters the orange portal? I would agree if once it touches the space that is the orange portal, that it instantly transfers out of the B portal or the blue portal, that's the case. But there's definitely a point in time at which there's properties of both situations that apply on the cube. Does that make sense?
If you're talking about like gravity in both worlds, I don't think it's relevant.
Okay. So the difference in our points of view are that the frames of reference are the portal or the third observer. The cube, gravity doesn't affect any of this.
Sure. But even if you did have gravity here, I don't think it would have a major impact unless you were moving at very slow speeds.
But but does it matter, like, what speed? Does it really matter that much if it's moving that much faster?
Sure. If I were to throw a baseball from one end of my yard to the other, the baseball would drop a lot more than if I were to shoot my Glock, right?
Nice,
I mean, the bullet still drops, of course, but I'm just saying that, like, if you add gravity in here, the only thing that would change is on B, maybe you would draw arcing lines instead of straight lines, but it doesn't really change the fundamental question.
I'm just saying that the cube's not moving from our point of view.
Yeah, but we're not the ones making. Again, I feel like that's the same thing. Did I use the guy floating in the atmosphere with a basketball?
Leave that analogy.
Okay, fuck. I might be fucking up collision here because collision might be a different thing. But what I'm saying is, like, let's say you have a guy floating in space and you have a little tiny itty bitty meteorite. Okay, that's and that guy sees that meteorite flying straight at him at 200 miles an hour. Okay, meteorite flies at him, bam, smacks him in the face, and the guy's screaming and crying in agony. And then he calls his friend on the ground. He's like, "Dog, I just got hit in the face with a fucking meteorite. It's moving right towards me at 200 miles an hour. Holy shit!" And then the guy on the ground says, "Dog, don't worry, it doesn't hurt. You didn't. The meteorite didn't crash into you at 200 miles an hour. You just hit it at 200 miles an hour, right?" I feel like that's what we're saying. You're like, okay, I mean, you have that frame of reference on the ground to say that, like, okay, well, the meteorite didn't hit him. He hit the meteorite, but it doesn't really matter because the frame of reference you're worried about here is the guy, right? The actual individual being hit by the meteorite is the thing that's causing the pain, right? Much the same way that here, the portal itself, that's the frame of reference that we're using to determine what happens on the other end is the portal. right? It doesn't matter if we see the cube moving or we see the portal moving. That doesn't matter. All the portal knows is that something is entering me at some speed and it's going to exit me at some speed. It doesn't matter if I'm moving, and it doesn't matter if it's moving or other things are moving, or we're all moving in a giant circle, or something is orbiting, or a dick's in my ass. None of that matters. The only thing that matters is something is entering me at some speed. That's the only piece of information I can measure. That's it. The same way that a scale in the bathroom can only measure force being applied to it. It doesn't know if it's moving towards the force or the force is moving towards it. It doesn't know if you're standing on it, or if you're if you're on the head and you're pulling it down at you, or if you've got it against the wall and you're leaning into it. It doesn't know. All it can measure is the force being pressed into it. That's it. Much the same way that the orange portal only knows something is entering it at 30 miles an hour, and then it's going to measure that and send it out the exact same way from the blue portal.
All right.
That's what I'm saying. Okay.
I understand what you're saying. Let's talk about how portals work.
Okay.
Right. So imagine you're a programmer, right? You're programming the portal to do some function, right?
Okay.
In this world, you also have an object called a cube, and that cube holds also its own inherent properties. Right?
Okay.
So when you move the cube through the portal, does the portal act on the cube? Right? Saying, oh, wait, from my point of view, cube, you need to change all your inherent variables and characteristics to match what I see. Whereas the cube's like, wait, hold on, I'm not moving at all. I have these inherent variables.
This is arbitrary, right?
But it's not.
It is, because I could say that, well, in my program, once it comes out the other side, it would still have all those inherited right? Because this is arbitrary. I could program it however I want.
Well, that's what I guess that's my point. That the way that the portal works. In your argument, the portal has to transfer everything according to what its point of view is.
Sure.
So I'm saying that in this arbitrary world where you get to select.
I'm not. No, I don't believe that my world is arbitrary. What arbitrary laws do you think that I've implied or imparted onto the world that I'm giving?
That the portal transfers everything as it sees from its own point of view.
Sure.
All information.
Well, I think that's a reasonable assumption to make based on the picture that we're looking at, because we don't see a guy hooked up to both the portals sending information from one to the other. Where he's saying, right?
So the cube itself has no say in the matter. What it sees in its own frame of reference, right? The cube itself and the platform.
Wait, sorry, what?
And all the gravity around the cube, its platform. Oh, you had a donation. I'm sorry. So the cube. What I'm saying is that the cube itself has its own frame of reference and its own attributes, variables, whatever you want to call them.
Sure.
That must be preserved as it enters the portal.
From the cube's frame of reference. Sure. But I think that in my examples, in all of my examples, the cube's frame of reference will also work. I'm sorry, every frame of reference in regards to this problem should be consistent throughout all of my examples. So in my examples for B, the cube would see itself. Let's say that this portal is in a factory, and let's say that it leads to a lush forest. Okay, so if this cube was in a factory, it would look up and it would see a lush forest, and the forest would be rushing down at it. And as soon as the platform pushed in, it would be in that forest, still rushing, and then launched out of the portal, and then rolling through. Right, everything is maintained. Right,
right.
As opposed to in A, it would come in A. Now, with an incorrect interpretation, when A, it would come rushing down, and then as soon as you hit the portal, you would just plop out, which wouldn't make any sense unless we believe that the portals are tethered to one another and have a constant or a consistent velocity between the two, right? Those vectors are identical, in which case what would happen is the portal would come rushing down, and then you'd see the lush forest, and then it would engulf you, but you would just appear on the forest floor, but behind you, you would see the portal leaving at whatever speed you entered it. You would see that portal racing along away from you, right? And then that would make all of the frames of references there would agree. The orange portal would see you rushing at it, and then it would throw you out the back. You were never moving, and you would come out just sitting on the floor, not moving, and the blue portal would see you exiting out of it very quickly, along with the rest of the forest, because the blue portal is moving along at the same velocity as the orange portal, right? Mm-hmm. And then you would see the blue portal rushing away behind you. This is assuming that the orange portal doesn't stop, that the orange portal continues to move.
Isn't it worth noting that in all of your examples, the cube has no points of contact with any other object, or whatever's going through the portal?
What? How would that change anything besides just making it needlessly complicated? What do you think?
Because the only way to transfer momentum or exert a force on an object is to have a physical point of contact with the object. The portals never touch the cube. So I'm saying that since the only way to transfer force is using that contact force.
But we're not talking about any force. We're talking about momentum. We're talking about a Newton law of physics. I don't know which one it is. An object in motion stays in motion is essentially what we're talking about here, right?
So if you look at the blue portal and you look through it, you'll still see the table, right?
Sure. Depending on what the orange portal is doing.
But the table has never started moving, right? Like the table.
No. If you're looking through the blue portal, the table is absolutely moving. It's coming right at you.
So, in that case, it would be like it was pushing the cube.
Yeah, exactly. You would say, yeah. But maybe it's not pushing the cube. Maybe the portal's flying at it. But you don't know. From your frame of reference, it doesn't matter. It's irrelevant for every single calculation you could possibly do. Whether that portal is moving towards it or it's moving towards you, it doesn't matter. Everything is going to be consistent.
Even though the cube originally had its own attributes. And it suddenly
depending on what, yeah, it just depends on the frame of reference you're looking at it, though. From the frame of reference of inside the blue portal in the lush forest, that cube is coming at you with some momentum. And with the cube looking into the lush forest, it's approaching that forest with some momentum. And then from the orange portal sees it coming at it with some momentum, and then once it enters, the blue portal will see it leaving with some momentum.
I still don't think that the the fact that the cube isn't moving should be ignored. But I'd have to think about it this a little more, obviously.
Sure. Okay.
I just think that there's no way that since the portals never come in contact with the cube, that the cube's inherent properties, especially since we're on the same planet in this question, assuming that we're on Earth, I don't know why the cube would have to have its properties transformed based on whether the orange portal is doing anything whatsoever.
I don't understand. Can you explain this to me? Are you saying that you don't think that the portals should be tied to one another?
They are tied to one another.
Or I mean, you don't think that the portal should share velocity with one another? Because if you don't, then that means that interpretation B is the most likely one. If you think that the portals exist as separate entities.
I'm saying that. Okay, let me see if I can get you to see what I say based on what I think happens. All right.
Okay.
The portal comes down. The cube and the table are from the portal's point of view going upwards, but then right when it reaches the portal, as it enters the portal, different forces start acting on it. Since there are two, there's an angle, right? So there's two forces. One acting on it in the table world where the gravity's pointing down, and then in the blue portal world, as it's coming out, it's pointing down. But since the table then is at an angle,
I mean, I think you could argue that there's gravity acting upon it when it comes flying out. But the only thing that I'm saying is that all I'm saying here's the crux of everything I'm saying in like one sentence. Okay?
All right.
The cube has momentum in respect to the portal at all times. That's what I'm saying. So when the cube flies through the orange portal, it will come out the blue portal with momentum.
Right.
Is the explanation for B. If you believe that the portals are tethered together and move at the same velocity, then when the orange portal slams into the base, the blue portal, which is also moving along, will stop as soon as the orange portal does, and the cube will just come right out of it and then drop to the ground or float on the portal or whatever if you're in gravity or no gravity, and then it will see the blue portal just sitting behind it.
So how does that second explanation not match up with what I was saying? Like, how is it different?
What do you mean?
So I was saying one thing, right?
Okay. And you're saying the second explanation that explains A, right?
And you're saying the second explanation that explains A, right? And you're saying the second explanation that explains A, right?
Yes. I think there is an explanation that explains A. Yes.
But that's not the explanation that I was saying.
What was your explanation again? I don't know.
That.
Here, my explanation for A is that the orange and blue portals share the same velocity, okay? So if orange is slamming down, then blue is also moving the same way through space and time, okay?
So this diagram isn't showing the part where the blue portal is also moving?
Yes, exactly, which is why I think that B is the correct interpretation, because the portal in A appears to be stationary, which would mean that these two separate portals do not share the same velocity.
Okay. So your point is that the only frame of reference that matters is that of the portals, and the portals see one thing, and that must be conserved between the two.
Sure, the portal and the cube. The portal and the cube. Not a third-party observer, but just the portal and the cube. Yeah. And I think that in both of my explanations for A and B, I can get every single frame of reference to agree with every other frame of reference consistently from the entrance to the exit of the portal.
Okay. So, I don't know if they agree, but I think that the frame of reference, that is, from the cube, is the one frame of reference that matters the most to me. And then once it comes through A, like, the portal has nothing to do, how fast the portal is moving has nothing to do with whether the cube comes out at whatever velocity you might think it does. The only force
hold on 1 second. My door is knocking. Don't meme too hard. I'll be back.
Okay. Well, chat, what do you think? Press if you agree with mine, and press Destiny Senpai if you agree with Destiny. What happens at the halfway point when the cube is halfway through the portal? When the cube is halfway through the portal, there begins to my point is that there becomes two different forces that act. It's the same force, but they act in different forces. They act in different directions because the cube is in two places at the same time. When the cube is halfway through the portal, there's gravity acting downwards, as you can see in the table. And then, since in the blue portal situation, since the cube is also there, there's also gravity acting downwards. But since the table in blue portal is diagonal, it starts sliding down the table and plopping. I'm saying that the orange portal, whatever its velocity is, has nothing to do with whatever the cube does. That's what I'm saying. Wow. Actually, it's pretty even distributions of haze and Bluetooth entertain us. Bluetooth is retard. Nice. Alright. Oh, hey, Lil Franker Z Napa. Actually, Lil Franker Z Napa to be back. Wow. Guys, type IUL tab Franker Z Napa, Lil Franker Z Napa. He's the secret MVP of chat. Spiders is trying to nuke everyone. What a fucking masturbator. What now? Dog, just fucking stop. The answer is the way the portal fucking works. The answer is the way. So you're saying the answer lies in what we define how the portal fucking works? I agree with that. Bluetooth, I don't agree with you on some things, but keep looking for the answer. What don't you agree with me? Narek, post. Bluetooth, kill yourself. Can you haha at me? Well, there you go. There you go. Bluetooth, give me a shout out right now or you'll die in your sleep tonight. Well, since I'm on Destiny stream, I don't give anyone shout outs. Bluetooth, sub me in. No. Have you ever taken any physics classes? Yes, I took mechanics and magnetism and electricity. I saw you use the phrase hidden variables. What do you know of entanglement? What? I never used the phrase hidden variables, first of all, and I don't know anything about entanglement. Bluetooth, kill yourself. Hey, another one. Sub me in, I explain. Yeah, but with Destiny examples, it would get sucked out. Sucked out? You mean it would get... What do you mean with Destiny's example? Which example exactly, and how would it get sucked out? Can you just say he's right and end this peppy? Bad idea. Bluetooth, I know what you're saying. Let me explain real quick. Why don't you just type it out? Also, I'm in TeamSpeak anyway, so... Oh, wait! I'm in a different channel now. Wow. Alright, never mind. I can't do shit. Tell Destiny to add my in so I can tell you why you are completely wrong. Wow. Why can't you just tell me here? Would you please do a milady?
Okay, are we good? Do we need to discuss more, or are we...
I mean, the basic principle is that we differ in the way portals work in transfer. So that's basically it.
Okay, all right. I'm going to bring in X Kills Me, who said I'm an idiot multiple times, okay? To come and shut me down. All right.
Good luck.
All right, it's your up. What do you got? What have I said that you disagree with? Let's start off with that.
Well, basically, what I'm going to do is explain why it's logically impossible for B to happen. And it kind of goes back, a lot of it, to the hula hoop example. And you kind of do a rebuttal of that, which is, the popular rebuttal against the hula hoop scenario, which is that the difference in the velocity between the input and the output portals is 0. So that's why the hula hoop works, but this picture you have up here probably would work differently, right?
Okay.
So the fundamental question basically is, what is the output velocity of the object when it leaves the blue portal? What is it?
Sure.
So we're basically trying to model a function, right? And what are the inputs of that function?
The input of the function is the objects entering the orange portal is essentially what is being outputted, right?
Well, I would say we have 3 inputs. Let me know if you agree with me. We have 3 inputs. We have the velocity of the object itself. We have the velocity of the input portal, the orange one, and then we have the velocity of the output portal, the blue portal. Do you agree with those 3
I disagree.
inputs?
I believe that the first 2 variables add up into one variable, but that abstract variable makes the first 2 indecipherable. So I think that the first variable we're talking about, the movement of the orange portal and the movement of the cube might exist, but those 2 things are added into one velocity that is impossible to determine.
Okay, well then let's take it for granted then that they are the same. Or we can also equivalently say that the velocity of the object is 0. So we set that equal to 0.
Sure.
So that what you're saying is that the output velocity is due
Equal.
to the differential, right? It's
Sure.
due to the differential.
Sure.
So say that the input velocity of the portal is 5 and the output velocity of the blue one is 0. That is when you would think that you might get B, right?
No. If the input velocity is 5 to the orange, then the output would be 5 to the blue. No?
Right. So that would be B, right? Like that picture.
Correct.
Okay. So what happens if the orange is stationary, or moving very slowly, say 1, and blue is moving at 10? Then if the differential between the input and the output portals mattered, then that would be a negative velocity because it would be the inverse of the scenario where the orange is faster. But you would have to assume that you can't pass through a portal where the output is moving faster than the input. But I don't think that's the correct assumption. I think you can pass through the portal even under those circumstances. Do you agree or disagree?
I mean, we're looking at the oh shit. Okay, I feel like we are being given the velocity of the thing exiting the blue portal is going to be in the frame of reference of the blue portal. So if the blue portal is moving, or here, let's say an object enters the orange portal at 5, okay? Then it's going to exit the blue portal at 5. Now, if the blue portal is moving at 100, okay, then the thing coming out of it will be moving at 105. Now, in the frame of reference of the blue portal, it'll only be moving away at 5, but now to an external observer, it'll now be moving at 105, with the blue portal moving at 100.
Right, so the reason that doesn't work is because when we go back to the hula hoop example, how, say they're both at 5, it doesn't come out at 10, right? It comes out at 0.
Okay, but the hula hoop example is assuming that the portals are tied to one another and share a common velocity. Not that they're moving at 2 different velocities. If the portals are moving at 2 different velocities, then the only assumption that you could possibly make is that these portals are functioning completely independent of one another, right?
Okay, let's just like go scenario by scenario. So say that like the actual object is moving at some small distance. So say orange is moving quickly and blue isn't moving at all. Then that gets to B, and that's what you think. But if it's the opposite, if orange say isn't moving but B is moving quickly.
Well, I don't even agree with the first assumption that you've made though. That's not what I'm saying. I don't want to be mischaracterized.
Don't you support B?
Yeah, but I don't know if B is moving or not. I don't know. I'm only looking at the only thing that B tells us from the frame of reference of the blue portal, the object is moving out of it at some speed. Now, it's possible that blue portal is also moving at some speed. I don't know that. I'm not capable of determining that.
Right. So let me step back because it's kind of a cleaner, more logical explanation.
Okay.
So you're saying that the differential kind of gets added in, right? So say the orange isn't moving, and just suppose that B is moving. It's moving at 5. So what's the exit velocity of the object?
Well, what does it enter the orange at?
Say it enters the orange at 1,
Okay.
and the exit portal is moving at 5. Then
Okay.
what's the exit velocity?
In reference to what? Exit velocity in reference to what?
Like, in reference to the portal B.
It's
how
1.
It exits. Why is it 1?
Because we're only talking in reference to the portals. If the portal is moving at 5, okay, from a third-party neutral observer, and an object comes out of it at 1, well, then the object is moving at 6 to a neutral third-party observer. But if the object is entering orange at 1, then it's going to be coming out of blue at 1. Now, if blue is traveling at some speed to a third party, then that third party the velocity of the object entering will be the object, or the exiting blue is going to be the exiting blue plus whatever the velocity of B is.
But here's the problem. So say A and B are moving at the same distance. Say they're moving both at 5, and I have it as a hula hoop. Don't even have to say they're a hula hoop. They don't have to be right next to each other or whatever. But if they're both moving the same distance, and you just pass it through, then that would be an exit velocity of 0. I think that's pretty easy to observe.
Wait, can you explain that again? What do you mean?
Sure. So get a hula hoop.
Okay.
And assume that either side is an entry and exit of the portal.
Okay.
And when you pass that hula hoop through an object, the exit velocity of the object is 0. It's the same as it was when it went in. Isn't that correct?
Exit velocity in reference to what? This is very important. The in reference part is very important because I feel like you're conflating the observer and then the actual portal itself. These are two different numbers. Because if you have a hula hoop and you hold a baseball stationary, you put the hula hoop up and down through it, it might be easy to say, well, look, the velocity of the ball is clearly 0. Well, in reference to what? In reference to the person holding it, sure, but in reference to the hula hoop, no, it has a velocity. Whatever it enters it at, it's also exiting it at the exact same velocity, well in the opposite direction.
Well, we've established numbers of this. Assume that the input velocity is 5 and the output portal velocity is 5. And assume that the object isn't really moving; it's just sitting there and it's being passed through with the portal itself.
Okay.
Then, at what speed would it fly out? If they were both, say, moving at 100, or would it just kind of
fly out in reference to what? In reference to the portal? Yeah. If you move the hula hoop over the baseball at 100 miles an hour, then the hula hoop would see the baseball and exit it at 100 miles an hour. Yeah, sure.
But in reference to doesn't really mean anything.
In reference to means everything when we're talking about this. What do you mean?
Say it's on a table or something, just on a table.
Okay.
Or like a hula hoop. When you pass it through with the hula hoop, would you say that the exit velocity of, say, a water bottle that you pass through a hula hoop is positive relative to the actual hula hoop itself?
Are you talking about throwing? Are you talking about throwing the bottle through the hula hoop?
No, just keep a bottle stationary and pass a hula hoop through it. What would you say is the exit velocity of that bottle? It's clearly
you're talking about if you're putting the bottle on the ground and then you're like tossing the hula hoop onto the bottle.
Sure. At what velocity is it exiting, say, the other end of the portal? It's exiting at 0.
Well, no, it's exiting at whatever velocity it entered at, but then as soon as the portal gets to the other end, then the portal stops, and then the velocity would be 0 after it passes through.
Say it doesn't have to stop. Say it just keeps going. Say it just passes through the water bottle.
Okay. If it passes through, then it would if you have a water bottle floating in the air and then you take a hula hoop above it and you drop the hula hoop, then from the frame of reference of the hula hoop, then the water bottle would enter it and then exit it at the same speed. Well, it would be a speed accelerating at whatever 9.8 due to gravity, but
So do you think the water bottle itself is changing velocity?
In reference to what? This is the whole thing. In reference to what? In reference to the portal? Yes, as you drop the hula hoop, it's going to accelerate away from the water bottle at 9.8 meters per second squared.
But it's not accelerating away at all. It's not moving at all. It
in reference to what? The water bottle is moving. The water bottle has kinetic energy in reference to the hula hoop. Yes, it's moving away from it. Because you're dropping the hula hoop sees the water bottle flying away from it.
And it just doesn't make sense.
It doesn't make sense because I don't think because you're trying to intuitively understand a frame of reference as a third-party observer. You're looking at a water bottle and you're saying, oh, well, if you drop a baseball next to it, the baseball is clearly falling down and the water bottle has no velocity. Well, that's from your frame of reference as a human watching the baseball drop and watching the water bottle float in the air. But from the frame of reference of the water bottle, the baseball does have velocity. It's dropping. From the frame of reference of the baseball, everything around it has velocity. It's all moving up as the baseball moves down.
Okay, well, you don't even have to go that far. Just look at the picture. What do you think you would observe if you were looking at it? If you were looking at it, just like we're looking at this picture, do you think you would observe it fly?
In what picture?
Blue?
Wait a second. Explain.
In what picture you have on your stream, the A or B? Do you think you would observe do you think you would observe it fly away, or do you think it would just observe it remain stationary while the hula hoop itself flies away?
Are we assuming that the portals are tethered to one another with the same velocity like a hula hoop, or if they're independent?
Sure.
Okay, so if they're tethered to one another and they're moving the exact same way, like the example, right? Like you want to do like exactly like the example? You want me to tell you what you would see? You would be looking into A, you would see a table approaching A at some momentum, and you would see it going down, 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 and then as soon as the cube passed through your portal, it would stop. First of all, the portal that you were looking at would be moving down, so you would have to be looking at the portal moving down because we're assuming that it has the same velocity, right, as portal B. So the portal is moving down, you see the portal approaching a cube, the portal gets down to a point, the cube comes through it, and then the portal stops because the orange portal slammed into the surface on the other side, and then the cube would just be sitting there on top of your portal. That's what you would see.
Okay, well, tell me again what you would see if orange were moving very slowly, and then the blue portal, the output portal, is what would be moving extremely quickly.
Okay, so now you're talking about the portals not sharing the same velocity, existing in different vectors, right?
Exactly.
Okay.
I'm showing exactly. So if the blue portal is moving very quickly and the orange portal isn't hardly moving at all, and the object passes through, would it move? What velocity would it move?
From what frame of reference? A person observing
either frame of.
Well, no, because there's a. So let me give you numbers, okay? If the cube, if the orange thing going down and circling the cube is moving at 100 meters per second, and that blue thing is moving at 200 meters per second in some direction, okay? And then the orange thing smashes down, right? Then a neutral party will see that cube maybe fly. It'll still fly away, but it'll only fly at 100 meters per second, right? If the blue portal is flying away from you at 200 and the cube comes out at 100, then you'll see the cube move away from you at only 100. But from the frame of reference of the blue cube, the blue portal will also see the cube shoot out at 100. In this way, every single frame of reference is in agreement with every single other frame of reference. There's no contradiction here.
So you're saying if the orange is moving at 100 and the blue is moving away at 200, that
Sure.
it will leave at 300?
No, well, in what frame of reference? In respect to who?
In respect to the neutral observer that you're talking about.
In respect to the neutral observer, if the blue portal is moving away and the portal is facing like towards you, then it would fly out and it would be moving away from you at only 100. If it was facing the other way, then it would fly out and the cube would move away from you at 300. It depends on the trajectory of the cube.
The portal is moving 200 though, so if someone's moving away at 100, that's negative velocity.
No. If the portal is moving away from you at 200 and it is a cannon on the front, and that cannon launches it out like the orange thing at 100, then the cube coming out the front would be moving at 300. However, it would still only be moving at 100 meters per second if your frame of reference is the blue portal. If you spin the blue portal around and you aim it at you, but it's still moving away from you at 200 meters per second, and then the cube and the orange thing flies through at 100, now the blue portal is moving away from you at 200, the cube is moving away from you at 100, but the blue portal still only sees the cube moving away from it at 100 meters per second.
So here's the problem though, is that from the neutral observer, you said that it would escape at 300 would be the velocity from the neutral observer, but that's not possible because we've already established that from the neutral observer, if both the input and the output are moving at a similar speed, like with the hula hoop example, then the output velocity is 0.
Sure, but again, your problem here is you're talking about the velocity. We can't talk about the velocity. That doesn't mean anything in this problem. You have to talk about the velocity with respect to a particular frame of reference. I am talking about the velocity with respect to the frame of reference of the blue exit portal. I don't know about a neutral third-party observer. It could be anything. Like, he could be moving in any which way.
That's what you said, though.
No. Okay, then I'm sorry. I thought that you understood what I meant when I said a frame of reference, so I will be much more careful in clarifying exactly what I'm talking about. The output velocity of the blue thing is going to be in respect to the blue portal. I don't know what it'll be to some random third-party observer. I mean, you could disprove anything then. So what do you think the output velocity will be? Oh, it'll be the same as that. Well, what if there was an observer coming by at 1,000,000 miles an hour? Well, now you're off by 1,000,000 miles. No, I'm sorry. In respect to the blue portal is exactly what I'm talking about. I'm pretty sure that should be pretty clear. So give me another example, and I can explain how any example would work here and would be consistent.
I still don't think it's a consistent example though. If the orange is moving at say 0, say it's not moving at 100, say it's moving at 0, and blue is moving at 200.
Okay.
What would at what speed would it be when it passed through the portal? Would it shoot out at 200 miles an hour, or shoot out at a velocity of 200, or would it just kind of plop down like A? Would it do A or B in that scenario? Would we observe A or B? And how it.
So you're talking about if the orange portal moves down very, very slowly at like a fraction of the speed,
0.
right? And it only just barely came out of B and it was resting on B, then yeah, it would continue to move along at whatever, from a third-party observer, it would move along at whatever B's vector is.
So it would just, it would just
sit there. Yes.
But the problem with that though is why would it just plop if the blue is moving so fast? Why wouldn't it shoot out if the blue is moving fast?
Truly, this is the dankest dungeon.
Hold on 1 second.
Which one is it, Destiny?
Okay, sorry. Okay, why wouldn't it shoot out if the blue is moving fast? Because it can't. Why would it shoot out?
Exactly, that's my point.
Well, no, that's my point. Because in reference to the blue thing, it would just barely come through at no velocity, and it would just sit there with no velocity on top of blue, and that's it. And then it would continue. Blue would continue to move along at whatever trajectory it was already on, at whatever speed it was already on. Why would it? Why would it have to shoot out or away from blue at that point?
Oh, it wouldn't shoot out. It would plop. My argument is that the exit velocity is independent of how fast they're moving.
I don't care how fast blue is moving. What matters is how fast orange is moving, because that determines the exit in reference to blue.
Right.
But you're having
the relative velocity of the portals is independent of the exit velocity of the objects. The input velocity of the object is all that matters.
In reference to the portals, yes. But what you're saying, you're saying something, you're sneaking something in there that doesn't make sense. You're saying that the input velocity is all that matters and the output velocity, okay? Which I kind of agree with, but then you're going, so if I'm a third party watching that blue portal, well, now you're telling me that the output velocity isn't equal to the input velocity. No, I'm only talking about with respect to the frame of reference of the portals themselves, not to a third party. But that's true of every single thing in life. How fast you throw a ball has nothing to do with, it all depends on where you're looking from. Like, when you throw a ball, does it only matter the speed at which it leaves your hand? Well, what about the planet that you're floating on? What about the orbit that you have around the sun? What about the sun's orbit around the center of our fucking solar system? Like, that all depends on your frame of reference, right? Like, you can give me more examples, and I can give you an explanation on how either of these interpretations, on how you would solve either of them, and I'm pretty sure it would be consistent through every single.
Okay, let's go through them. Well, the solution you had for the blue one was that if the orange is moving or arbitrarily slow, and the blue is moving fast, that it wouldn't exit quickly. It would kind of plop.
It would just sit there. Yeah, it would just plop. Sure.
So what happens if they're both moving at the same speed?
So you're saying if the orange thing came down at 10, and then the B thing came down at 10, and they had the same trajectory and everything?
Exactly.
Then A would be the solution.
The dankest.
Okay, but when orange is moving, and
technically this is impossible.
Hold on, sorry, fuck. I'm sorry. Okay, say that one more time.
So we so far have gone through two scenarios. One scenario is where orange isn't moving and blue is moving fast. You agree it would plop. I agree with that too. The other scenario is where they're both moving at the same speed. And you agree that A, they would plop, and I agree A, plop as well.
Sure.
Then another scenario is where neither of them are moving, and when I think we can both agree A, plop, B, A is plop as well. So the last scenario, which is the scenario here, is that orange is moving fast and blue isn't moving. So the output would just shoot out, we get B. But I'm saying that's logically impossible, because the inverse of that would have to be true, which is that if B is moving faster than the orange, then it would have to move at some negative velocity, which obviously makes no sense.
But it can move at negative velocity. You're saying you're not using in respect to. If somebody is, if you're measuring velocity, I think it'd be negative if it's going backwards, depending on what your trajectory is. If something is moving away from you at 300 meters per second, and then the ball is thrown, back at you from that moving object at 100 meters per second, it's still going to be moving at quote unquote a negative velocity back to away from you at 200 meters per second. That's possible.
All right, so here's a question.
Okay.
Do you agree or disagree that in this setup, it's possible to pass through a portal when blue is moving faster than orange? Do you think it's possible? You said it would plop before, but do you really hold to that belief? Because that contradicts the inverse, which is orange moving faster than blue.
Hold on, one second. Fuck, I don't know in chat who's fucking retarded and who's not. I could have forgotten this from physics. Doesn't velocity measure a speed in a certain direction, and if you come back from that direction, isn't that considered negative velocity? Am I incorrect on that? I don't know if, am I incorrect or am I... Sorry, hold on one second. Yes, 100. Okay, so fucking kill yourselves. Actually, then hold on. Fuck this shit. Okay, I'm sorry. Can you give me your example again?
Yep, sure I will. So basically, the first scenario is where B is moving arbitrarily faster than orange. So we both agree that it would kind of still just plop out. But what I'm saying is that if this picture you have in B were true, it would have to quote unquote shoot out in the opposite direction.
Wouldn't have to. No, I don't agree with that. It wouldn't have to.
Well, the only alternative is it's impossible to actually pass through the portal. But I'm arguing it is.
Why would it be impossible to pass through?
So, because it would be impossible to pass through because it can't have a negative velocity.
It can though. In respect to who? If let's say the blue thing is racing along at 1,000,000 meters per second, and then you throw something through the orange one at 10 meters per second, when it comes through the blue portal, it's not gonna get sucked back in. It's gonna come out of the blue portal at 10 meters per second, and to a third-party observer, they'll see it leave the blue portal, moving at 1,010 meters per second. If it sees the blue thing moving away from it at 1,000,000 meters per second.
So why is that not true in the inverse? If the orange is moving at 1,000,000 per second and the blue is only moving at 10, then how come then it does exit at 1,010,000, so to speak? Why does B happen with the inverse is true? But it can't. It's a contradiction. That's my point.
How is it a contradiction?
Cool. So it's a contradiction because on one hand you're saying that the differential between orange and blue is resulting in A, but on the other hand you're saying that the differential causes B, depending on which one is differential.
Okay, can you give me examples where they contradict themselves, and I'll talk my way through them, okay?
Right, so...
Let's say that orange is moving at 1,000,000 miles per hour, right? Or 1,000,000 meters per second, okay? And blue is moving at 5 meters per second.
Right.
When orange hits it, it'll just go flying out of blue.
All right, so if you say that, but if say the inverse is true, that the blue is flying along in the orange, it can't fly out in the opposite direction. For that differential to have the same impact on the cube, it's a contradiction to say that in one hand it would shoot it out, and on the other hand it would just pass it through at a neutral velocity. It
would just add the velocity when it goes through orange. It would just add the velocity onto whatever blue is traveling along at.
This is.
I don't understand.
So then you would get B again.
Destiny, unmute me right now.
You just said it would plop down.
I mean, it would come out of it at 10. I mean, I don't know if it plopped down or if that's fast enough for it to shoot out.
But here's the problem: is you're saying it adds to the velocity at which it comes out yet. But
sure.
The observation with the hula hoop shows it's not true.
The hula hoop is assuming that both portals are always sharing the exact same velocity. That vector is never changing between the two.
Right, but follow them along here. You're saying that the hula hoop example assumes the exact same velocity, and
yes.
I definitely agree with that.
Okay.
But on the other hand, in explaining why it shoots out when B is moving faster, you're saying that the speeds are additive, and that the speed on orange is added to the speed on B.
Well, it's only added from the perspective of a third-party observer. From the frame of reference of B, it's only going to come out as fast as it went in on orange.
Look,
a third-party
just hold the constant reference here. Like, don't worry about the point of reference. Just tell me, don't you agree with the hula hoop example that it has, say, a 0 velocity change in that when it passes through the hula hoop? Say from whatever constant point of reference.
Maybe. I can't answer that. I don't know. From somebody looking at it, no, nothing is moving. It's just the hula hoop dropping from somebody looking at it.
Okay, great. Yeah, I totally agree that's the case. That shows in my mind that the output velocity isn't impacted by the sum of the input and output.
But that's only assuming that the portals are tied together and have the exact same velocity.
Right. But that's the point, is that the assumption that the velocity is added together both impact the output velocity is wrong. Because what you're saying is that if B is moving at 100 miles an hour or if blue is moving at 100 miles an hour and orange is moving at 10, it goes out at 110. I'm saying that's not possible, because if they both move in at 50, they don't come out at 100, do they?
From whose perspective?
Right, that's my... Look.
No, but no. Because what you just said, yes, I could give you explanations for every single one, but you keep conflating this third person neutral perspective. Listen. If the blue is moving at 50 and then it goes into the orange at 50, well, it doesn't come out of 100 miles per hour. Sure, if you're standing in front of it, if blue is coming at you at 50 and then the portal is pointed at you and it goes into orange at 50, it'll shoot out at you at 100, yes. But if you're behind it and the blue is racing past you and then the blue shoots out the back at 50, then it's going to be moving at 0. But no matter which way it goes, goes, no matter what frame of reference you take, if you look at the frame of reference of the blue portal, the thing shooting out will always move at 50. Whether you're shooting it towards someone that sees it coming at them at 100, or towards someone that sees it coming at them at 0, that it will always be moving at 50 in reference to the blue portal.
I don't know why you say I'm the one conflating the perspectives here, because like on one hand I can get you to agree that if you observe a hula hoop fall through an object, that the object doesn't appear to move, right? But then when I apply it to this, that's not an acceptable frame of reference anymore. So can you explain that to me? Because I don't understand.
I don't. Give me the examples and I'll talk. What is not matching up?
What's matching up is that you agree with me that if we drop a hula hoop through an object, we can observe that the object doesn't appear to move. Doesn't appear to move any faster, slower. It just stays the exact same speed it was when it went in, right?
Correct.
So why can't we apply that same point of reference when we observe an object fly through this scenario, where the only difference is...
Sure, we can. I just said that we could. What you would see is, you would see the orange thing moving through space, and then the cube would enter it at 50 miles an hour, and then the blue portal would leave it at 50 miles an hour, and then to the neutral observer, the cube would just float in the air and then fall to the ground. That's what A would be. That's the solution to A. I feel like we've gone in circles.
Well, I feel like I've gotten different answers on what happens if blue goes slower than orange. On one hand, you've said it plops, but on the other hand, you've said that...
No, the only time it will plop, the only thing that causes a plop is if is if the portal, the blue portal of A and the orange portal are moving at the exact same velocity. That will cause a plop every time. If in regards to a third-party observer will see a plop.
Okay,
will just fall to the ground.
So if they're moving at the same speed, that's the only case in which you see a plop.
The same speed and the same direction. Yes, the same velocity.
But if blue is moving faster than orange, or orange is moving faster than blue, you're saying that has the exact same impact. Either way, it doesn't matter.
That you would just, whatever velocity it enters in orange, it would be spitted out from blue in whatever direction it was facing. Yes, regardless of the speed of blue or direction of blue.
So you're saying it doesn't matter whether... So in this case, it could be that B is the one moving super fast. And
sure.
The orange is the one that's not moving very much. And
sure.
If you put it in, it would shoot... You think B would happen if scenario B on this picture you have on your screen. You're saying that would happen.
In respect to B, yes. B could be moving along. That portal could be moving along at 1,000 miles an hour, and then the orange thing would come down at 50 miles an hour and hit the cube.
And it would shoot out. And it would shoot out.
It would shoot out at 50 miles an hour.
It wouldn't shoot out. It would plop.
Why would it plop?
Because why would it go faster? Not going through the orange one isn't even moving, and it's not moving very fast either. So
I said if orange comes down at 50 miles an hour and the blue one is moving at 1,000 miles an hour, then the cube will come popping out of the blue one at 50 miles an hour in reference to the blue. So if it was facing towards a third-party observer, it would be 1,050. If it was facing away or towards another guy standing behind it, it would be 950.
Okay, well, I think we're kind of going in circles, but I'll just let somebody else take the reins on this. I still disagree with the whole point of reference thing.
What are you disagreeing with? What part are you disagreeing with?
Because with your scenario, it doesn't matter like how fast either orange or blue is moving.
Well, in reference to who? No, nothing. It never matters how fast B is moving in reference to anybody else, because we don't care about anyone else. What the question is asking is how fast is the cube exiting blue? I don't give a fuck how fast blue is moving. We're asking how fast it's exiting in reference to blue. So the only thing that's determining the speed at which it exits blue is the speed at which it enters orange.
Okay, well, all right, there we go. So that's the key, because this all comes back down to the function, right? So you're saying that the speed of blue doesn't matter at all. That's what you
correct.
Just said.
Yeah, sure. Yes.
But if the speed of blue doesn't matter, then how come the hula hoop example, you observe it not working? Because you have a positive speed of the orange, but you have the blue doesn't matter, right? So how come it doesn't increase the velocity relative to the exit? It's a contradiction.
Because the blue and the orange are tied together, and the orange stops when it hits the ground.
But you just said that the speed of blue doesn't matter. So it's a contradiction. That's my point.
The speed of blue, the solution for A only exists if you assume that the portals are tethered together and share the same velocity always. In which case, I said like 10 times now that it will always plop out. It will always plop out. The only time I've said the speed of blue doesn't matter is if the portals are disconnected. If the portals are disconnected, then the object will come flying out of blue at the speed at which it enters orange.
All right. Well, say they're separated by 1 centimeter. then it still holds. It's still the exact same thing.
What do you mean
However,
separated by 1 centimeter?
You say, because you're pretending like if they're attached, it makes some huge difference. But
it
doesn't
does!
make any difference at all. No, it doesn't. It makes no difference at all. And that's why I said if it does matter, then okay, pretend like they're half a centimeter apart. That wouldn't make a difference at all. And again, you contradict yourself when you say that, oh, it only works because they're moving at the same speed. Well, why does the speed of the blue even matter? Because you just said that the speed of the blue doesn't matter. So which is it? Does the speed of the blue matter or does it not matter?
It depends. Are the portals tied together or not?
I'm saying that doesn't matter, but if you want to, pretend like they're half a centimeter apart.
Okay, if the portals are half a centimeter apart, but the blue one is traveling through space at some speed, then anything that you put into the orange one will come out the blue one at whatever speed it went into the orange one plus the speed of the blue one from a third-party observer. I don't understand what the confusion is.
All right, so here's confusion. Here's two things. You're saying with the portal that you agree that it's not coming out at a higher velocity than with the speed at which the hula hoop was dropped on it. You agree with that?
From the frame of reference of the blue portal, yes. The blue portal will always see it shoot out at the speed that it enters the orange portal. Yes.
Right. So that you can't reconcile that with assuming that the speed of the it'll always shoot out of the blue portal at the same distance as the orange.
Why?
Because either the speed of the blue matters or it doesn't matter.
Why does it? No, to you, what is your speed right now? You don't even fucking know, dude. You have no fucking idea. Why? Because it doesn't matter. Because you're moving right now on the planet Earth. You're spinning around the Earth and spinning around the sun and spinning around the solar system. You have no fucking idea how fast you're moving. So why would you say your speed is so fucking important in relativity to what? In reference to what? Like, you keep going back to like, well, what does the speed of blue really matter? No, it doesn't. I'm only talking about the cube in reference to the blue teleporter. I don't give a fuck how fast the blue teleporter can be moving at any fucking speed. That doesn't matter. It's not part of the question. I don't understand how that frame of reference is so difficult to understand.
But I don't. Are you actually saying that the speed of the blue has no bearing on the output velocity of it, or are you just saying you don't care about
it? It doesn't have any bearing in regards to the frame of reference of the blue thing. Correct. Yes. That if something enters orange at 50, it's exiting blue in reference to the blue at 50, no matter how fast the blue is going. Yes, is what I'm saying.
Okay, but so in that scenario, that would still be A. That's the problem with your reference. Like,
how would that still be A?
Because if I drop a hula hoop on an object and I adopt your language of this point of reference nonsense, and I say, yeah, well, the object is moving from the hula hoop at whatever from the point of reference of the blue, it still appears like it's A.
But the velocity of the teleporter in A is changing once the cube has left it. If the portals are tethered together and an object goes into orange at 100 and comes out of blue at 100, but orange stops by smashing into the ground like the hula hoop, then what will happen is you have a portal that is moving at 100. If orange is moving at 100, the portal is moving at 100, the cube passes through it at 100, but the second the cube passes through it, the blue portal stops because the orange portal is stopped, and the cube will sit right on top of the blue portal. Everything is conserved. Every frame of reference agrees with each other.
I don't see how you can do this additive math. Like, if it goes in at 100, then it comes out at 100. Like, this seems so contrary to
how?
Like, you're not. Because if it goes in at 100 and the blue's moving at 100, then what does it come out as?
In regards to what? In what reference?
Right, exactly. You're the one who's doing this adding, but then when I do the adding, you're like, in regards to what?
I'm saying what I'm always speaking in reference. If it goes in at 100, it will come out at 100 in reference to the blue portal. I define everything, every frame of reference I'm referring to. What do you mean? If you drop the hula hoop, if the portal passes through and the blue and the cube goes into the portal at 100, and then the orange thing smashes into the ground, like in this example, okay, and the portals are tied together with one another, then as soon as it drops down to the bottom, then the blue one, which is moving at 100, will have a cube come out of it at 100, and it'll see it move out of it at 100, but the blue portal will stop immediately, and then the cube will appear to just sit there, because you're saying in the example A that the blue and orange portal are tied together with one another.
No, I'm not even saying they have to be tied together. I told you, do a half centimeter apart. If they're being tied together, actually you feel like that makes.
It doesn't matter. They could be a million miles apart. It doesn't matter. Exactly, it would still be the exact same thing if they are moving along the same vector. If they have the same velocity.
Exactly. So going back to the actually when blue is moving faster than orange, you're saying that doesn't matter.
Yes.
I feel like you've given both answers on both sides of that exact question.
Again, hit me up with any example you want, and I will give you exactly consistent answers for either solution that will agree with every single frame of reference. Give me more examples.
Right. Orange moves at 1, blue moves away at 100. What does it come out as?
It comes out at 1.
Okay, so orange moves at 100 and blue moves at 1. What does it come out as?
At 100.
Exactly. That's. So if they're both 0 and the object itself is moving at 1, what does it come out as?
How can they both be? Then the object will come out as 1.
Exactly. So that's the contradiction. That means that your function for the output velocity can't hold, because on one hand, if you write down those numbers, the math doesn't check out on those things.
The math checks out perfectly because we went through this at the very beginning of our example. I said that I do not believe there is a difference in the velocity of the cube versus the velocity of the orange thing. I believe that there may be a difference, but that those two variables add up to some number, and it's irrelevant what the two independent things are, because whatever it enters orange at, regardless of the speed of orange or the speed of the cube, it will exit at the addition of those two velocities.
Okay, then with a hula hoop example, what does it sum to?
In the hula hoop example, where you would drop the hula hoop.
Yep.
Okay, you drop the hula hoop, and the hula hoop drops at 10 meters per second, okay? So it will say in a vacuum with no fucking acceleration due to gravity, okay? Drops at 10 meters per. So as soon as it hits the cube would begin exiting at 10 meters per second from the portal, and then when it hits the bottom, it would stop. Okay. Now the blue portal is moving along in one trajectory or whatever at 10 meters per second, and then a cube comes out of it. Okay, at 10 meters per second, and then the blue portal stops, and then the cube is just sitting there at the end of the portal.
Great. Look, open a notepad and actually put these numbers, because you'll see how it they don't make sense if you try these different scenarios and you see them all in a row. If you actually look at it and you go orange 1, blue 100, what's the output? You say 1. Actually do that and visualize it, and you can actually see how the contradiction doesn't work out.
Okay, hold on, we're gonna do it. Okay, orange. Okay, so I've got orange and a blue one. Okay, so give me numbers and we'll draw it all out.
Okay, so first is orange is moving at 100, blue is moving at 1. What's the output?
Okay, if orange is moving at 100, okay, towards some box or whatever, and blue is moving at 1. And then this cube enters orange, right?
Right.
Okay.
Say the cube isn't moving. Say the cube.
Sure, whatever. Regardless, I think it doesn't matter, okay? So the cube is entering orange, or orange is engulfing the cube at 100, correct? Right?
Yes.
Okay.
The orange is moving at 100, but the cube isn't moving.
Okay. So now what's your question?
My question is, what's the output number? You said
output number in regards to who? Who's observing?
Whatever it was when you said it was 101 a second ago.
Okay, if there is an observer standing here, I'm drawing it on stream, in front of the blue thing, and the blue thing is moving towards it at 1, and the ball is shot out in that direction, then the ball speed will be 101, okay? However, in the reference to the blue portal sees it moving at 100, which is the exact same speed that it entered. If it shoots the ball out the back, then the observer will see the ball moving at 99, okay? But in regards to the blue portal, it will still see it moving at 100. Is what I'm saying.
But going back to the picture, you think it will shoot out, point the lines away, it'll shoot out rather than plop. That's what you think, right?
If it enters at 100, yeah, it'll shoot out at 100. Sure.
Okay, so it won't plop, it'll just shoot out. So now do the opposite. Say the orange portal is moving at 0, and the blue portal is moving at
if it's moving at 0, how is it going to enter the fucking portal?
Moving at 1.
Okay, so now we have an orange. Okay, so now we have an orange portal. And then we have a blue portal, okay? Now the blue...
Keep it there, because you can see the actual output numbers.
Okay, yeah, I'm drawing them all again, okay? So the orange portal is going to be moving at 1, correct?
Yes.
And the blue portal is going to be moving at 100, okay?
Correct.
So if there is an observer standing here, looking at a ball coming out of the blue portal, it's going to see that ball coming at him at 101. The blue portal will see the ball moving away from it at 1. If the ball is going backwards, then the person observing it will see the ball moving away at 99, and the blue portal will see the ball moving away at 1. All the frames of reference agree with every single other frame of reference in this example.
Look, if that's true, then you could literally write a function right now on what they are. You could add them together. Why can't you do that for this?
F of x, so we're going to say that f of x is the speed of something exiting blue, right?
Right, exactly.
Then it's just one variable.
What if it's just orange?
Sure. The speed of
right, the function.
I don't know. The speed of whatever the thing entering orange is. That's it. That's your answer every time. It's just a one variable function. What do you mean?
It's the speed at which it enters orange.
Yes.
Is the speed it exits blue.
Yes.
Okay, so then that would be it would leave at okay, well let's like test that against when the blue is moving fast and the orange is moving slow.
Okay, let's draw it out. Okay. So I'm gonna draw an orange over here.
Oh no. Here's what we need to test out.
Okay.
So you just said that it's the orange is all that matters. So now what if they're moving the same speed like the hula hoop example? Then what is it? It's zero. That's my point.
Yes, which is what I'm saying is the solution for A. Well,
so say they're both.
Wait, hold on. Oh, okay, hold on. I might actually, dude. I might actually even know what is going on. Are you ready? Okay. So let's say that orange is moving at 5. Okay. And let's say that blue is moving at 5. Okay. And then so the object enters orange at 5, and then it comes out of blue. Okay. It's going to see it moving away from itself at 5. Right? And then an outside observer will see it moving away at either 10 or 0, depending on their frame of reference. Okay? So the way that it plops is if it enters the portal at 5, okay? In which case, so let's say that it enters the portal at 5. The velocity of the blue portal that it's exiting is also 5. The blue portal is moving along at 5, and then the ball is moving in the rear direction at 5. But as soon as it exits the portal stops. That means that the portal that was moving at 5 that spit out. If it keeps going, then then the ball will just move away from it at 5.
It still plops out, right?
No, it won't plop. No, the ball will move away from it at 5. But the reason why this was a solution for A is because when the orange slams into the table, we assume that the orange and blue are stopping together. That's the only possible solution for A, is what I'm saying.
All right, here's my point. Hold a water bottle up and pass it through hula hoop through it as fast as you can. No matter what, it's gonna plop. It's never gonna.
Wait, what do you mean? What you mean put it onto the? You mean if you put a pen on the ground and then you drop like a circle around it, the pen is never gonna shoot out, right?
Right.
Okay, let me one more time, okay? Let me explain what's happening. If the portals are tied together, okay? Orange portal is moving in some direction at 5 meters per second, and there is a ball that is going to enter it, okay? Blue portal is moving in some direction, okay? At 5 meters per second, okay? So blue is moving at 5, orange is moving at 5, okay? Let's say that the blue is going to shoot the ball out behind it, okay? So what happens is when the ball enters orange, it's going to be going behind blue at 5, okay? So that means that from blue's frame of reference, the ball is moving away from it at 5 meters per second, okay? And it's traveling in another direction at 5 meters per second. So what's happening here is you're dropping a hula hoop around the pen, and the hula hoop is moving down at 5 meters per second, and the pen is moving up through it at 5 meters per second. But what's happening is as soon as the hula hoop hits the bottom, hits the desk or the floor, the hula hoop is stopping, right? At the exact same speed that the thing was moving up. So if this is moving in one direction at 5, and then it's being thrown off at 5, and then this thing stops, now it zeroes out. Does that make sense?
But you're saying it also zeroes out when the blue is moving much faster.
I haven't given any other thing where it zeroes out. What do you mean?
So when the blue is moving at 1,000,000 miles an hour,
okay,
and the orange is moving at 1, does it just plop or does it?
It'll come out at 1 meter per second.
Right, exactly. It'll just plop.
Well, it won't plop. When I say plop, I'm implying that both of them now are moving at the same velocity or moving at 0 velocity. It'll come out. It'll just be slow at 1 meter per second or whatever. I mean, that's still fairly fast, but.
So when the orange is moving significantly faster than the blue, it shoots out. and when the blue is moving significantly faster than the orange, it just plops.
It doesn't matter what the blue speed is in relativity to the orange speed. Much the same way that it doesn't matter what your speed on planet Earth is relative to whatever. That's irrelevant. It doesn't matter.
I don't see how you reconcile what you just said with your explanation for why the observer will observe a plop with the hula hoop example. Because your explanation for the hula hoop example is that they're moving at the exact same speed. My question is, why does the speed of blue even matter if what you just said is
if they're moving at the exact same speed? Because if a truck is moving one way, okay, you understand that if you're observing a truck,
blue doesn't matter. So
listen,
does the speed of blue matter or doesn't it matter? That's what I don't understand.
To who? What? To a third-party observer?
Sure,
okay, listen, you have a truck. The truck is driving at 60 miles an hour. A baseball pitcher is standing at the back of the truck and he throws the baseball at 60 miles an hour. You realize that from your point of view, the ball will float into the air and then fall to the ground, yes?
Right, but
so the only thing happening in the hula hoop example is the truck is crashing into a brick wall immediately after the baseball player throws it. So baseball player is standing at the back of the truck is moving at 60 miles an hour, baseball player throws the ball, and then the truck immediately crashes into the wall, which is the hula hoop hitting the ground, and then the ball will just float there. It'll just be right there. That's it.
Is the hula hoop the baseball in this?
No, the hula hoop, the baseball is the bottle of water. It's just floating there. Or the cube, it's just floating there. The truck is the...
Where water get involved in this?
What?
You said baseball or water or what?
A baseball, water. Your example is a water bottle. My example is a baseball. They're all interchangeable. If a guy is standing, if a water ball player is standing at the back of a baseball and he throws a hula hoop, and then the baseball crashes into a thing or whatever, if he throws it at the same speed, it will float to the observer. If the truck crashes into the wall and immediately stops, then it'll just like sit there at the end of the truck. That's the example. The hula hoop is coming down and then it's stopping immediately, right? It's crashing into the wall and then the cube is just floating on top.
Okay, so to the observer, if the blue and orange are at the same speed, they'll observe the same exit as when the orange is moving much slower than the blue. Give
me more examples and I can explain like exactly, and I can tell you what an observer will see or what.
Truly, this is.
Right.
Here, let me give, hold on one second, and then I'll try to give another example.
Destiny, you need to stop talking about this in terms of velocity. That's not relevant. This is a problem of what forces act on the cube. It's really simple. This is Newton's first law.
Okay. Okay, let's say that you are standing in a lush forest, okay? And you believe that the portals are connected to one another, okay? Okay? So if these portals are connected to one another, let's say that the orange portal falls onto a ball moving at 10 meters per second, okay? Okay?
Does the ball itself have to be moving? Can't the ball just be stationary?
Sure. So the orange portal falls onto a ball, or moves onto a ball at 10 meters per second, okay? And you believe that these two portals are connected to one another, okay? What that means is you see a portal racing along the ground at 10 meters per second, okay? Then what happens is, hold on, if the ball is thrown out at the same speed as the blue portal, a neutral observer will see the ball just appear behind the portal and fall to the ground as the portal races along the ground. Right?
So in that picture you have in your stream, that would be plop A, wouldn't be B.
It plop in relation to the neutral observer, but the portal racing away from it would see the ball shoot out at 5 or 10 or whatever it went into the orange portal at.
But the blue is not moving though, right?
No, the blue is moving because the orange is moving. It has to be.
So if the blue isn't moving and it passes through, you think it would shoot out? You don't think it would plop?
If the blue is not moving and the orange is not moving, and then the ball is thrown into the orange, then the ball will just come thrown out of the blue.
No. I agree. If the ball is thrown into the orange, it'll fly out of the blue. But say the ball is not moving. Say the orange portal just flies over it. Then you're saying it's going to shoot out at that speed out of the blue?
If the blue is not moving, so now we're assuming that the portals are not tethered to one another and they can move independently of one another. Then yes, then the ball would come flying out of the blue at whatever speed it entered the orange.
Okay, so then now say that the orange isn't moving very quickly, and then the blue is just like wishing through the lush forest, through the trees, and then I kind of like very slowly roll the ball through the orange. You're saying that it's gonna like shoot out.
In reference to who? If you have an orange let's say that you have a blue thing rushing along the forest at 100 meters per second, and then you've got a blue portal that's stationary, and you throw a ball into it at 5 meters per second, right? Is what you're saying? Yes? You throw a ball. You throw a ball into an orange portal at 5 meters per second, and you see a blue portal moving at 100 meters per second. Correct? So you want to know, because the blue portal is moving fast, and then the orange entrance is going to be very slow, right?
Right. Orange.
So what you would see as an observer,
even stationary.
Sure. So what you would see happening is the blue portal would rush along you at 100 meters per second, and then a ball would come out the back of it, moving in the blue direction at 95 meters per second if it was thrown behind it, or moving forward at 105 meters per second if it was thrown in front.
So you're saying I would see it go, but how could it go 95 meters per second if the blue is moving at 100 meters per second?
Because it's moving at 95 meters per second in reference to the person watching the blue portal move away from them. In reference to the portal itself, it's only moving away at 5 meters per second in every single direction thrown, because it will always be moving at 5 meters per second. If that's what it entered itself at, it will always leave itself at 5 meters per second in every single direction. Now, it could be moving towards you at 105, it could be moving away from you at 95, depending on where you're standing, but every single frame of reference will agree there in that example.
So, and if they're moving at equal speed, say they're not tethered together or whatever, they're just moving at equal speed, then say they're both moving 100 miles per hour, then would I observe in the forest a plop, or would I observe it shoot out at the summation of those two speeds?
It depends on where you're standing. Is the blue portal moving at you or away from you at 100 meters per second?
What do you mean? It depends on where I'm standing. Would the ball just kind of just fall out, or would it actually roll in any direction?
Where are you standing? You're saying if the blue portal is moving and the orange portal are moving at the same speed, correct?
Yes, they're both moving very quickly at equal speeds, and I gently roll the ball through the orange portal as it's moving so very, very quickly. Then at what speed would it exit if both the blue and the orange are moving at the same speed, and I lightly roll it in? Would I observe it shoot out of the blue away from the blue, or would I observe it just make it through the...
It would shoot, if the blue portal would observe it exiting at whatever momentum it entered the orange portal. And if you were an observer and you were standing in front of it and it was shot at you, then the speeds would be added together. If you were standing behind it and it was shot out towards you, then the speeds would be subtracted from one another. So if that's it. Right? Does that make sense?
Yeah, I guess the problem is I think it would plop. That's the issue, and I think that's just like
plop in whose frame of reference? Who would it plop to?
To me, that's not. I don't see the validity of that distinction. It's like you would observe.
So you think that something can plop in reference to me and in reference to the portal? That both things just somehow exist in the same, and it'll just plop on the blue portal and plop on the ground, and it'll break. I don't understand how you don't understand how the frame of reference is literally everything in this.
Right, I guess I don't understand the whole frame of reference thing, because to me it's like you can either observe just look at it as like a vector. What vector does it travel away when it exits? Like that doesn't depend on the frame of reference. It's like a vector. Like it's moving at some point. Is it moving like...
You don't think vectors are at all relative to the frame of reference that they're observed in? You think that vectors are some godlike... ultra, when we draw fucking vectors, we do them as gods, and we know exactly that thing moves in that direction and it is exactly this in relation to the entire universe?
Yeah, like if you tell me a vector and I'm at a different quadrant in the plane, it doesn't mean it's a different vector. It's still the same vector no matter where you are. That's why we use vectors.
But that's if you're observing it from a graph. If you were observing it as a physics problem, then the vectors are always relative to whatever you're measuring.
And I guess the other issue is that the picture of B, there is clearly some frame of reference by which we're seeing the cube just shoot out of the blue. So what's the point of reference of the base image that we're basing all of this on? What would you say is the point of reference?
We're just a neutral third party observing what would happen.
Right, so in my mind, the neutral third party in the forest would observe a plop if they're moving at the same speed, both the blue and the orange.
Assuming that it's shooting out behind it and... well, wait, are you talking about if the portals are tethered or untethered?
Either way. It's the same either way. It doesn't matter if they're tethered or untethered or half centimeter apart. It would plop through the neutral third-party observer.
If it enters the orange portal at 50 meters per second, okay, and the blue portal is moving at 50 meters per second, then what you would observe is you would see a blue portal race along the forest floor, and then a ball would just plop out of it. The portal the portal would continue to race along. The portal would see the cube move out at 50 meters per second because it's moving at 50 meters per second.
So now what would I observe as a neutral observer if the blue weren't moving and the orange were moving at the exact same speed?
So now, if orange is moving at 50 meters per second and the blue is stationary,
what would I observe? Would I observe it plop?
You would absorb it fly out of the thing. It would shoot out.
That contradicts what you're saying. You said that the speed of the blue doesn't matter, though. That was what you held earlier.
Because the speed of the blue doesn't matter in regards to that frame of reference, to the speed to the blue portal. It does matter to a third-party observer, but it doesn't matter to the blue portal. In both of these, okay, here, let's use the same example. Let's use the same speed. Let's say that the blue portal is moving along at 50 meters per second, okay, and the orange portal moves at 50 meters per second. Orange portal engulfs the ball. The blue portal, racing along the floor, sees the ball shoot out at 50 meters per second and continues on. A neutral observer would see the ball just plop onto the ground, okay?
I
now,
agree with that.
let's say that the blue portal is stationary. Orange portal moves at 50 meters per second, okay? The blue portal will see the exact same thing. The ball will shoot out at 50 meters per second. It will see the exact same thing as before, but a neutral observer will see the ball shoot out at 50 meters per second as well, because the blue portal is not moving at a velocity to counteract what it's shooting out at.
But then that means that the velocity of the blue does matter.
Only to a neutral third party, not to the blue portal.
Right, but what do you neutral third party? Like, are you talking by neutral third party? Do you mean like actual observation? Like, because that seems to be like what we're talking about here. We're talking about third party neutral observation or whatever. That's my point. So you would observe a plop if they were the same speed, and you're saying that you would observe a shootout if there was a speed differential, right? For the neutral third party in the forest, in the lush forest.
Depending on the particular example, sure.
All right, lush forests, neutral third party observer. If they're moving the exact same speed, you get a plop. If the orange is moving much faster than the blue, then you'll observe a shootout, according to you. Now, the inverse, if the orange isn't moving and the blue is moving super fast, then do you observe a shootout, or do you observe a plop? It's a plop, but it would have to be like a negative plop, basically, because the differential is in the opposite direction, if the differential mattered. I'm saying the differential doesn't matter. The differential is input. Is independent.
Okay, I feel like I could run through the same example again. If the blue is moving at 100 and the orange shoots it out at 5, then the blue would just see it moving away at 5. An external observer would see it move away at 95 or 105, depending on if they were standing in front of it or behind it. Like, I don't know how else. What doesn't make sense about that? Because that seems to be what you keep getting hung up on. What don't you understand about that example? Sorry, go on.
So what doesn't make sense is that you're saying that the exit velocity at which the neutral third party observer observes it shoot out is, in that case, you're saying that it's blue minus orange.
No, you would have to draw vectors at that point. It depends. Is it moving tangential to the person? Is it moving towards the person? Is it moving away from the person? And what's the angle of the cannon? Like, at that point, you've got to start. It gets a lot more complicated.
No. I'm saying the velocity at which the observer sees it gain distance from the blue portal
will always be whatever it exits the orange one at. Yeah, sure. Yeah.
Right. So what is that? Like, what is that velocity at which the neutral third party observer observes the ball move away from the blue portal? Does it plop or does it shoot out?
It'll always shoot out at whatever it entered the orange at.
Right. So my point. So no, you laugh, but my point is that we agree that if a neutral third party observer watches two portals that are moving the same speed, it won't shoot out. It'll just plop. So that's my point, is that it's clearly not shooting out at the speed at which it enters the orange. Or at the speed
it's shooting out relative to the blue. If it plops on the ground because the blue is moving away, relative to the blue, it's still shooting out.
Right, but I don't know how many times. We're talking about the neutral third party.
Yes, the third party would see it plop onto the ground, not onto the portal.
Right, so the neutral third party would see it plop onto the ground if they're the same speed, and the neutral third party would also see it to plop to the ground if the orange was going, or if the blue was going faster than the orange.
I mean, what do you mean by plop to the ground?
Like, look, what do you mean? I mean, look at this picture here. You have A, where it clearly just kind of falls down from the portal because it wasn't moving when it went in, so it's not moving when it went out. And then B is it somehow adopts the velocity of the orange. That's what I mean when I look at this picture, A or B.
But nothing. When you say adopts the velocity of, whatever it comes out of the blue portal at, it's always adopting the velocity of the blue portal. And then the velocity is being added in regards to that, kind of, depending on where the third-party observer that you really want to put in these examples is standing. Like, Give me 50 million examples, and I can answer every single example consistently. I don't understand.
I don't feel like you've been very consistent though. Because all right.
Okay, tell me. Okay, give me 2 examples, and then point out my. How about wait? Why can't you give me 2 examples, and then we can draw them both, and then point out my inconsistencies? Can we do that?
Last rundown. Yes. One last rundown with a condition. I'm not talking about any fucking perspective of the blue portal. I'm talking about the perspective of the neutral third-party observer. Whatever you want to.
Okay, where is the neutral third-party observer standing?
By a bush. A berry.
Is the blue portal moving towards him, away from him?
Say the blue portal. God, I don't even think it matters, but
it does.
You decide. You decide.
Okay, we'll say the blue portal is moving away from him. Okay.
Okay.
Now, is the ball shooting out towards the observer or away from the observer? We'll say away to make things real simple. So the blue portal is moving away, and the ball is shooting.
Here's what we're gonna do. Here's what we're gonna do.
All
it's
right.
gonna be. So I'm standing by a bush. I'm looking forward, and both the orange and blue portals are on my left, and they're moving in the exact same direction, just at different speeds. We're gonna adjust the speeds. Like they're both to the left of the screen, and then they're gonna move to the right of the screen.
Okay.
Okay. So now, what happens if neither is moving, and I pass the ball very gingerly through the orange at say 5.
We'll say 1 meter per second. You throw it through the orange at 1 meter per second. It will come out of. It will come out of the blue at 1 meter per second.
I agree. And say I throw it into 100, it's gonna come out at 100. It's gonna shoot out, right?
Yes.
So now what we're gonna do is we're gonna start moving the orange. I'm gonna put the ball on the right side of the forest next to a different bush.
Orange is moving to the right, and blue is stationary.
Yeah.
Okay. Orange is moving right. Blue is stationary.
And orange is moving towards the ball.
Okay.
And say the orange is moving at say 500.
Okay.
So you're saying when it passes through, I'm gonna observe it shoot out of the blue one that's all the way over there, still on the left side.
Yes.
So it's gonna shoot out. It's gonna go say all the way across.
At some 500. Yes.
Okay, so 500.
Yes.
So
do we agree so far? Is this? Are we in agreement?
Okay. First of all, I don't agree, but I don't think we're at this difference in logic yet. So like,
if we don't even agree on this, then why do we keep going?
I'm gonna show why. Like, I'll take it for granted for now. Then I'll show why if it has to be contradictory if it's true. I'll take it for granted for now. Just take it for granted that's what happens.
Okay.
So now they're both going the exact same speed.
Okay.
And here's one more. Yeah, they're going the exact same speed. Now the orange passes over the blue ball. Does it come out stationary, or does it come out at the summation of the two speeds, or does it come out the speed of the orange only?
Okay. If the blue is moving from left to right, if those are the directions we're moving.
Same speed, yeah.
And the orange is moving from left to right at 500, and the blue is moving from left to right at 500, okay? Then it would enter the orange and shoot out of the blue at 1,000. In reference to the blue would see it shoot out at 500, and an observer would see it shoot out at 1,000.
No. I said no blue references.
Then how can I answer the question?
Well, because we're in a forest and we're observing it. That's like.
Okay, well, is it shooting out in front of the portal or behind the portal? Because if it shoots out behind the portal, then it's moving at 0. If it shoots out in front, it's moving at 1,000. Because if it enters the portal at 500 and it gets shot out of the blue at 500, but blue is moving 500, if it shoots out in front of it, it's going to be shot out at 1,000 from a third-party observer. If it's from behind, it's going to be moving at 0 to a third-party observer.
Okay. So to the third-party observer, say it moves out the front, whatever. So the third-party observer is moving at 1,000 now.
Yes, okay.
Okay, so now take those two portals and tether them together like a hula hoop, and they don't observe the same thing. They don't observe it come out at 1,000.
If you tether the two together and you assume that they have the exact same velocity at all points in time,
and tether them together, and you pass it through the ball, it's not going to shoot out, is it?
And you yes, it will. Hold on, let me think about it for a second.
Right, this is the contradiction that I've.
Okay, if both of the portals are tethered together, and they're both moving in one direction at 500, okay? And then the ball enters the orange portal at 500.
Well, the ball's not moving. Just say
or whatever. It doesn't matter whether the orange portal or the ball is moving. It enters the orange portal at 500. Then it'll shoot out of the blue portal in reference to the blue portal at 500.
What is a neutral third-party observer? Look, here's what I'm saying. The neutral third-party observer wouldn't even see it move. It would look like a real hula hoop just went over it if they were attached and inverse like that.
But that's only if the ball is shot out of the back, then sure.
But there is no front or back with portals. It goes in one, it goes out the other. Just say that they're.
Well, but we're saying that the velocities are respective of one another. They're tethered together. So if the portal moves through it at 500, right? So let's say the portal is moving from left to right, okay? Portal moves from left to right, whoom, and goes through the ball at 500 meters per second, okay? Then to a neutral third-party observer, if the velocities are the exact same, then it'll come out of the blue in the opposite direction at 500, whoom, according to the blue.
I don't think it would.
But it'll drop at 0.
I don't think it would come out at 500. I think it would look like it did. It would look like it wasn't even touched if you.
It would come out. It would come out at 500 in respect to the blue, but yes, to a neutral observer, it would drop.
So you're saying you agree that a neutral observer would not see it move at all? It would look like it was in the exact same spot it was before.
Yes, if the portals are tethered, yes.
But I think even if they're not tethered, it'll change the location, but it won't change. It'll change like the output location, but it won't change the velocity at all. Don't you agree? Why would the tether affect the output velocity to the neutral third-party observer?
Because if it enters, oh, fuck, I feel like we're.
No, I think we're getting somewhere because I think this is the actual crux of the issue.
If it enters the orange portal, okay, so are we saying they are tethered or aren't tethered?
We agree that if they are tethered, that the third-party observer wouldn't even see it move at all. It would just look like it was exactly where they left it. However, if they weren't tethered, if they were, say, 5 feet apart, that wouldn't change the output velocity.
Wait. What do you? When I say tethered, what I mean is they're moving at the same direction at the same speed. Not that they're close together one another. I just mean they're moving at the same direction at the same speed.
Right. Even if they're moving at different directions at the same speed, the third-party observer wouldn't see them shoot out. The neutral third-party observer would just see them plop or not even move at all. It would just kind of just teleport basically instantly.
Well, yes. Yes.
So they would just see it teleport somewhere else, right?
Yes. And then you would see the portals racing away at 500 meters per second.
Yes, exactly. Okay, so this is really important because this is, I think, to summarize what we've gone over so far, we claim that if the blue isn't moving and the orange is moving fast, third-party observer will observe it shoot out of the blue. We also observe that if we're moving the same speed, the third-party observer would just see it teleport. It wouldn't see it shoot anywhere.
Same speed and same direction. Yes, that's
or
important.
Even different directions.
No, that's not. It has to be same. It has to be exact same velocity.
No,
yes, yes.
Same velocity, but not same.
Velocity implies direction. Yes. If orange is moving at 500 and blue is moving at 500 up or whatever, and then the ball comes through and shoots up, then it's not going to plop at that point. Or like if the cannon is facing down, I'm sorry. If the blue is moving up and the cannon is facing down or whatever, like that'll be different. It has to be shooting out the exact opposite, the exact way it would be facing. Like if they're tethered, they have to be exactly tethered to one another. It can't change direction or anything like that if it's supposed to be consistent.
Let's summarize this. So if say they're moving the exact same speed and they're both going east, then you're saying that it'll just teleport. It won't move at all. But if say orange is going east and blue is going south, then what's going to happen? You're saying that it's going to make a difference to the velocity? Because I don't think it is at all.
Depending on where the ball shoots out.
It's not going to shoot out. It's just going to teleport.
Well, but in reference to the blue, it will always shoot out to the blue. But to a third-party observer, whether it shoots out or not depends on which way the ball is facing when it gets shot.
No. Like I said, if the blue is moving south and the
if the blue is moving south at 500 meters per second and the cannon is facing south, then if it enters orange at 500, it's going to shoot out south at 500, and to a neutral observer, it'll look like it's being shot at 1,000. But if it's aiming north and the blue is moving south and the orange passes the ball at 500, then it's going to shoot north at 500 while the blue moves south at 500, and then the neutral observer will just see it teleport. Because it'll just be standing still, because all the velocities the speeds will cancel out. Or the velocities have to cancel out even, not just the speeds, because it has to be exactly opposite from one another.
I absolutely just. So you're saying that it would be if the orange were moving east 50 and the blue were moving south 50, what would the exit velocity be to the neutral third-party observer? I think it would just teleport. You're saying it would actually shoot out at 100 at both of those?
It would shoot out at 50 relative to the blue portal and 100 relative to an observer, yes. Much the same way that if you were on the back of a truck as a baseball player and you threw a baseball forward at 100 miles an hour while the truck was driving at 50 miles an hour, an observer in front of the truck would see the baseball moving towards them at 150 miles an hour. But if you threw it the opposite direction, an observer would see the baseball moving at 50 miles an hour instead of 150. That's the difference. The direction is very important.
So you're saying that the neutral third-party observer would see it fly out at 100 miles an hour if they were both going the same speed?
Well, if it depends on the direction. If the truck is moving at 50 miles an hour and the portal is on top and it comes out at 50 miles an hour, if it's facing back, then it will cancel out and float. If it's facing forward, then it'll shoot out at 50 from the truck, which is 100.
What if it's like at a 45-degree angle? What if it's not totally opposite? What if it's not?
Then then we can get out our SOHCAHTOA fucking calculators and figure out what it would be.
That's the point, though. That doesn't make sense.
It does make sense. It would fly out at an angle, and then you would just calculate the vector. Yeah, well, how does it not make sense? What do you mean? If it's facing at an angle and it shoots out at 50 degrees, then the number would be something between 100 and 50. I don't know what it exactly is.
But then the direction would have to matter for all the other examples, too. We haven't even considered direction.
I've considered direction in every single example. I've always said that if a person is standing in frontwards shooting out, if a person is standing in the backwards shooting out, but the thing that's important, the thing that has remained consistent in every single example I've given, is that the frame of reference from the blue portal always sees the ball moving away at whatever speed it entered the orange portal. That's the important part. The blue thing has always seen the ball leaving the same speed that it entered. Now, whether a third party is standing in front of the portal, behind the portal, or the ball is being launched to the side or in front or behind, that will change what a third party views it as, but the blue portal will always see it moving the exact same way.
Cool. So the problem with looking at it as a vector, though, is that the ball is not actually moving. So the ball isn't on any vector at all. So
moving in respect to what? If a blue portal is moving away from a ball at 500 meters per second, then the ball is moving at 500 meters per second. It is moving in regards to the portal.
Well, what about when the blue is moving at 100 and the orange is moving at 1? Then
the ball would come out moving in regards to the blue portal at 1.
To the observer, would it just plop out?
Where is the observer standing? It depends.
It does not depend on where the observer
It does. If the observer is standing in front of the blue portal and the ball comes out the front, then the observer would see the ball move towards them at 101 while the blue portal moves towards them at 100. If the portal was faced on the back or whatever, then the ball would come out of the blue thing and the ball would be moving towards the observer at 99 and the portal would be moving towards you at 100. But from the frame of reference of the portal, the ball is always moving away at 1.
So would I observe it roll fast after it exits the blue portal if the blue is going much faster than the orange?
Sure, it would move at from your observation, it would be rolling along at 99 meters per second. Yeah.
So you're saying if the orange is moving at 1 and the blue is moving at 100, then the third-party observer would observe it moving at 100.
It would either see it at 101 or 90 if it was in front of it or behind it, or some other value in between. Yes, the max it could see it at is 101. The max and the lowest you could see it at would be 99.
Sorry, I've pushed the talk on. I forgot for a second.
Sure.
See, I think you throw in like a wrench and everything with the whole directional thing, which I disagree with. But really, because I think the problem is that like when they're moving the same speed, and the observer won't notice it roll at all, right? But you say only if they're moving in the same direction. But when the blue is moving faster than the orange, you're saying that you would observe it roll as well.
Yeah, I mean, this is exactly the truck thing. Like, if you stand on a truck and throw a ball at 90 miles an hour while the truck is... Okay, here, let me ask you this question, okay? Let's say that you stand on a truck and you throw a ball at 100 miles an hour, and the truck is also moving at 100 miles an hour. What do you see with the ball?
Okay,
listen, let's pretend that your life depends on answering this question, okay? So I'm gonna ask you this question. A truck is moving at 100 miles per hour. A pitcher on the back of the truck throws a ball at 100 miles per hour.
Right.
How fast do you see the ball move?
Here's the problem.
No. What is the answer to that question?
I'll answer your question. Given that I am also moving 100 miles an hour, and the observer, am moving 100 miles an hour as well, I would only observe it at the distance at which I threw it.
No. I'm asking a neutral third party watches a truck. A neutral third party watches a truck, okay? And the truck is moving at 100 miles per hour, and the pitcher throws the ball at 100 miles an hour. How fast does the ball move?
It moves at 200 miles an hour.
You don't know that. There's not enough information there for you to answer that question. Because if the pitcher, keeping all the variables the same, say the pitcher throws it at 100, truck is moving at 100, but the pitcher throws it behind the truck. Now the ball is moving at 0 miles per hour, okay? Let's say that the pitcher throws it in front of the truck and you're standing in front of the truck. Now the ball is coming at you at 200 miles an hour, right? Your frame of reference is very important to answering the question of the speed of the ball. And the direction that the pitcher throws it is very important in determining the speed of the ball. Because if the pitcher throws it back, while the truck is moving forward, then the ball will be stationary.
The number one problem with your analogy is that the truck is carrying the velocity of the ball from its reference point. This isn't true at all. The portal is frictionless. It doesn't change.
No, everything holds true, exactly true. Because even if the third-party neutral observer sees the pitcher throw the ball at 100 miles per hour, while the truck is moving 100 miles per hour, and it sees the ball remain motionless, the truck will see the ball moving away from it at 100 miles per hour.
The truck carried the ball to its initial starting point. The portal doesn't do that. The portal doesn't act on the ball in the same way the truck acts, or the portal doesn't act on the box in the same way that the truck actually acts on the ball. It's
no, the portal is moving away from the ball, the same way that the truck is moving away from the baseball. But the ball coming out of the portal will inherit all of the momentum of the portal, much the same way that the baseball being thrown off the truck will inherit all the momentum of the truck. The only difference is instead of a pitcher pitching at X miles per hour, we have an orange portal that's throwing it from the blue truck at X miles per hour, whatever it enters the orange portal at.
The problem is that the ball is already moving at that, whereas in this, the portal, the box isn't acted on by the portals in the same way that the ball is carried to that velocity and vector or what have you by the actual truck itself. That's the main problem.
Wait, explain to me the difference again? I'm sorry.
Sure. So in the teleportation with the portal, the actual portal doesn't change. It doesn't affect any of the momentum of the actual box.
That's not true.
It is true.
It won't expect. It won't.
It's a basic mechanic.
No, if the portal is moving along at 200 meters per second and it plops out at 200 meters per second, then it's still going to be moving along in regards to a third party at 200 meters per second. Now the blue portal won't see it moving, but a third party will see it moving. It all depends on your frame of reference.
Right, but I think when you get to the neutral third party observer, there's a contradiction in if you observe that they move at the exact same speed, that if you change the distance or if you change the directions, that it'll somehow change the exit velocity of the observer.
In relation to who?
What do you mean? The person we've established, the observer that we've established in the forest, observing the ball.
Yes, it will change. Of course it will change. It will definitely change. If a truck is driving at you and a pitcher throws the ball 100 miles per hour off the side of the truck and then that ball hits you while you're standing forward versus throwing it right in front, it's going to be much different, of course.
The problem is there's no equivalent to a pitcher throwing a ball in our analogy. The
pitcher throwing the ball is the portal exiting the ball. Yes, it's the exact same thing.
No, it's not. It's not the same thing at all. The portal, that's not how portals work. The portal doesn't throw it out. The portal is just... It's just that. It's a portal. It's just a teleportation thing.
Yeah, but the ball is exiting the portal at some velocity, the same way that the ball is exiting the pitcher's hand at some velocity. It's the same thing, except instead of a person throwing a ball in some direction, it's the portal spitting out the ball in some direction.
Okay, well, another kind of major problem with that is that B is only true, even under all of your assumptions, it's only true on the assumptions of the directions in which it's moving, or I guess if blue is stationary, then you can assume it shoots out. But if
if blue is moving in the same direction as the opposite direction as it shoots out, then it'll plop. Is that your next?
Yeah, because
yes, I agree with that. In regards to a neutral observer, if the blue thing is moving at 300 and it's shot out at 300 from the orange portal, then a person will see it fall to the ground, but the blue portal will be racing off at 300, and in reference to the blue portal, it will see the cube moving away from it at 300.
So with the hula hoop example, you agree that it just plops if they're moving in the same direction, but if they're moving in opposite, or if they're moving in, if they're moving in the same direction, then you're saying it'll shoot out at twice the speed at which it entered. Is that what you're saying?
Yeah. Yes. But a hula hoop doesn't do that. The hula hoop doesn't reverse fucking vectors or anything. It just comes out the exact same way it goes in. The hula hoop is not magical.
Right. Well, I guess that's an underlying just kind of assumption that I disagree with, that if they were moving in opposite, or if they're moving in the same direction, traveling at the same speed, then passing it through would shoot out the ball at what speed would it shoot out the ball if they were moving in the same
In reference to who?
The third party observer watching.
If it was shooting it in the same direction that it was moving, then the velocities would be added together. If it shot it in the opposite direction, then the velocities would be subtracted from one another.
Okay, so you're saying that the same holds true if they're moving the same direction and the orange isn't moving and the blue is moving at, or say the orange is moving at 1 and the blue is moving at, or say the orange is moving at 50 and the blue is moving at 100. So you're saying that, and they're moving in the same direction. You're saying that you would observe it shoot out of the blue faster than the blue is moving itself at 150.
Yes, it would shoot out at 150 if it was facing forward. It would be shooting out 50 away from the blue, and to a neutral observer, it would be seen as moving 150. Yes.
Okay, well, I think that logic only holds true if you assume that they're added together. But I don't think the directional thing actually makes sense. But
I mean, I think the directions and vectors are pretty fucking important. I feel like that's like a fact, but I mean, I don't know what...
Yeah, I mean, vectors are pretty important, but the problem is that the actual box in the forest isn't moving; it's just sitting there. So the idea that it's on some sort of vector.
Wait, what's not
make any sense.
What do you mean?
The actual object that we're talking about isn't on a vector; it's just on a single point. It's just there in space. So the idea that the vector, that the new vector.
You're talking about the cube sitting on the ground because the orange and blue portal are moving at the same speed.
Right.
Yes, but it had to move out of the blue thing at some speed. If you're driving a truck at 300 meters per second and you drop a baseball and you plop it off the back at 300, it will continue to roll along at some speed close to 300 for a while. The only way to get it to plop is to throw it back at 300. It's the only way to do it.
But when you get the new vector, see, I don't even want to get into like vector actual mathematics here.
Sure, we don't need to. It doesn't need to be that complicated.
But I think it kind of does, because we're talking about the actual vector of the underlying objects. And you're talking about the vector of the portals, and you're kind of equating them. That's the problem, is that they're not the same thing.
I mean, if something exits the portal, it's going to inherit all of its current vectors,
the problem
right?
is it's not really exiting the portal. The portal, the portal doesn't push it out, so to speak. The portal is just, it's just that. It's a portal. It doesn't act on the actual object. That's the problem.
Sure, it doesn't. It's going to exit the portal at whatever it entered the portal at. Sure.
Right. Okay, well, I feel like we've hit a wall, so...
All right, well, I appreciate the discussion.
Yeah, good discussion.
Yep.
I still kind of think it's A, but I mean, I see what you're saying.
Okay, all right, I love you, buddy.
All right, see you, man, bye.
I'm done. I'm killing myself. I'm actually going to kill myself.